that rocks my soul. Oh, 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 oh. That rocks my soul. Oh, 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 Lord. Oh, oh, Lord. Oh, oh, that splash against my hollow bones. That rocks my soul. Oh, 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 that splash against my hollow bones. That rocks my soul. Oh, 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 oh.
Woo!
Good morning, Demani.
Good morning, Bianca. How are you?
I'm doing well, enjoying these great beats from DJ Desired State.
Absolutely. Listen, I don't care if anyone else is not having a good time. We're having a great time. We're having a great time. We're jamming backstage. We're really simulating a in-person live conference. Like I'm having a great time. How are you?
Having a great time. We've been chatting it up in the backstage and just looking forward to getting into this deep dive today and all of our new speakers and getting technical for real. So it's gonna be really a cool day with fewer sessions but more in depth.
Definitely, definitely. I certainly enjoyed the high level overview, business like, business value conversations that were brought yesterday. I think Cornelia did a great job of kind of like wrapping things up and putting things into context for from a business perspective, and those were certainly good
Absolutely.
to hear and to see. Excited that Paul Fremantle is on board. I can't wait to get him in front of some customers because he brings another flavor to the message that was good to see as well. And I think we having him up this morning, right?
Yeah, I think he is first up after us. So coming up in like 8 minutes, at five after, we're gonna introduce him. So that'll be exciting.
Nice,
Um,
nice, nice.
has anybody in the Slack yet? Yeah, people start to come in. Good to see you guys. Feeling good. And yeah, let us know. Let us know where you're from. Would be great to see where everybody's tuning in from today. In the EMEA region.
I see some folks trickling in. Folks are still getting their coffee. Is that coffee or is that tea?
It's tea. It's
It's
tea.
tea. It's tea.
But
Cup of tea. Enlighten us. Enlighten us. What tea you drinking this morning?
it's a white tea that has some tropical fruits in it. Like it's got mango in it, which is really really lovely. I'm from a tropical country, so I like tropical fruits, and so it's all helping with the mood. Play some music, have some tropical fruits, feeling good, and even though it's starting to become winter, feels really warm, and I'm having a good time. Do you drink tea in the morning or only coffee?
I do. I usually try to go with a ginger tea. I usually try to go with a ginger
Mm,
or peppermint for the most part.
yum.
But yeah, that's my tea of choice.
Good
But
stuff. Good stuff.
so so give the audience a background on Bianca. What are you doing at weaveworks, a little bit about, you say you're from a tropical country. Talk to us a little bit about the background and kind of what you're doing
True,
now.
true. Yeah, I'm from Brazil originally, from São Paulo. But I'm living in Barcelona in Spain. And I've been the head of design at Weaveworks for some time now. I think Alison pointed it out well in her talk yesterday that we need to have an open source UI for GitOps, and that's what I'm working on next. Just building a UI that will make GitOps more accessible for everyone, more transparent, and being able to build in monitoring on an open source level. So really just looking forward to that. And overall, like at WeWorks, just support all kinds of teams in a million different random ways. We used to be quite a small company, so you gotta put on a lot of hats. Um, we were just talking about it earlier. Actually, I found out that Damani, you're Guyanese. You're from Guyana, so you're South American too.
Yes, yes, yes. From Guyana, we're actually the only English speaking country on the continent. So on South America, we're the only English speaking country. And yeah, but you know, we can wear the Caribbean hat, we can wear the Latino hat, we can wear the South American hat, we can
Beautiful.
wear there's a number of different buckets and categories we can kind of fill into. But yeah, at Weaveworks, we're really excited about WKP and Weave Kubernetes platform, and I was essentially kind of tapped on the shoulder to like scale the enterprise sales team and messaging as we're bringing that to market. So very excited about that. I think Brees did a good job of explaining how we're baking in all the GitOps principles and all of our open source tools prior to allowing those things to come in. So pretty interesting.
And Breeze is going to come in for a 90-minute session today, actually, just talking about getting started with GitOps. So that'll be a good connection of those two things.
Nice, nice. So I think it's just about just about the time to is it time to bring Paul on stage?
Yeah.
Oh,
Well, maybe a couple
in a
more
couple of
minutes.
minutes.
He's supposed to come on at 5 after, so we can
Okay,
stay for maybe 3 more minutes.
nice. So I know
so
I
so we've
know that I know that a lot of folks, I think the timing of this conference was pretty on point. When we think about KubeCon around the corner, when we think about trying a Flux 2 and folks trying to understand how that migration path, and especially Helm as well. So we're really really excited to have Scott on the team, and him being a Helm contributor is huge. He's going to give a deep dive today as well. Is that right, Bianca?
Yeah, that's right. So just after, it's a bit later in the afternoon at 14:30 GMT. Sorry, at 14 o'clock GMT. He's gonna talk about what Flux 2 can do for Helm users. So that's gonna be it's gonna be really illuminating and probably helpful for a lot of people starting out in this new world of Flux 2 that we're pretty much opening now with it because Flux 2 is not very old. So that'll be good.
Yeah. So I mean, the business value of a Helm is actually ending today. So that's big, and I know that's going to affect a lot of users. So I'm excited about that session. Also, again, just going back to Brees's session, getting started with GitOps. Yeah, I know that there's still, we automatically assume that everyone is enterprise users, but from the chat, there's still folks in the community that's now getting started. And I think Brees's talk today, he has a good 90-minute session where he's just really going to push how to get started with GitOps, right? And some folks may have started on their own, but they may not have started the right way or the way that we would have advised. So maybe Brees can maybe, put the train on the tracks, if you will.
Things just feel more accessible when you see someone loading it up on their own computer and getting things working also in the recommended way. So I think it'll make everything easier.
Yeah.
So and also we'll have this session recorded so people can always go back to it and check it out. So that's great. Now is the time to welcome Paul Fremantle from Weaveworks to the stage. Paul,
Have Paul come and join us. Paul, how are you?
I'm good, Damani. Hey, Bianca. Yeah, no, it was a great day yesterday. I really enjoyed it. I thought I learned a lot, and I'm really looking forward to today's sessions as well. It's kind of cool to be doing it on the Friday the 13th where Helm 2 is being deprecated. So we get to try and pull people out of the nightmare. So that'll be fun.
Paul, I don't know if you heard all of the hype, but a lot of folks have been sitting tight to hear Stefan. So we have Stefan Proton coming on this afternoon with a deep dive, and folks have been long
Absolutely.
awaiting that. So I'm excited to hear him come on and rock the stage.
Yeah, definitely. It's going to be good.
Yeah.
So shall I kick off with a few slides and talk us through the kind of shift we're having from business to technical, which is what today is all about?
I think so. I
Please
think so.
do.
Awesome.
The
So
floor is
take it
yours.
away.
Thanks, guys. Always welcoming, and it was great to start the day with a bit of Daniel DJ Desired States sessions. That was awesome. That was really got me in the right mood.
Have a
Okay.
good one. See everyone a little bit later.
So, as I just said, my session this morning is really just trying to kind of bring the shift that we're having. So yesterday we were really trying to dig into the business benefits and strength of GitOps. And today is a much more technical day. Now, there was plenty of good detail yesterday as well. So I don't want to say that there wasn't some interesting technical stuff. So if you didn't see it, if you were put off, please go take a look at the YouTube. I'm going to just review some of the things that we talked about yesterday and then try and introduce and highlight some of the really cool stuff that's coming today. So yesterday I started up with this message that, every CXO in the world is saying we need to speed up. Every CTO, every CIO, and every CEO. And that's definitely a big message of GitOps. And we talked about people, processes, and technology and how to address those. And those themes came up all through the sessions yesterday. But I think, if I had to look at the themes that really stuck in my head yesterday, security, security, security. We had a lot of sessions on security, on audit, and those were really important. And the same phrase kept coming up in those: supply chains. This idea that we're building a software supply chain, that we are creating a new kind of supply chain is absolutely vital. And actually, I think this is a major theme as we move from hand building software to rolling out massive clusters and fleet management and deploying and and that leads really cleanly into this idea of governance, auditability, and visibility, which were some big themes. Another big message that really fitted into the kind of people, process, technology was this idea of developer first. The idea that we really need to start with developers and get developers going, and they are the ones who will drive the starting point of all these themes and messages. And then there was cults. I was not expecting a presentation on the GitOps cult, and that was amazing. That was awesome, and I know that was a big favorite of many of you. So we'll get to that. So I think I started out yesterday with we need to speed up, but I think I ended up yesterday with we need to speed up, but don't screw up. Do you know what I mean? The big message here from yesterday was we're not just speeding up. We need to make sure that we do not create security flaws. We do not create opportunities for people to hack. We do not create challenges as we speed up. And this is kind of, I think, really going to be a big focus of these 2 days, is the fact that GitOps, that well-defined continuous delivery based around Git, based around version control, based around pull requests and merges, based around source controllers and delivery controllers, can actually enhance both of these, can actually enhance the speed that we deliver, but also improve the security, the validity, and the governance. And I think that was amazing. So that was a real message from yesterday. And just to talk about some of these things, I think that ability to fix the security problems, to fix the challenges, are really based around this idea of the supply chain. And Michael Hassenblatt was one of many people yesterday who used those phrases. And I thought it was really interesting to the results of his survey. And he had a lot of good stuff about, what C-level execs are looking for. And I really encourage you to go look at his talk. But this was really interesting that 49% of people he surveyed in this year's container security survey are not yet enforcing policies. And that's actually a pretty big number. 156 people, 155 people answered this question. And so OPA is definitely the winner in this space, but unfortunately the biggest bar on there is that number of people are not yet managing policies. So that is definitely an area that needs to be fixed. And I know this is a big area of how to use GitOps to actually make sure we don't screw up. Another great talk about the supply chain and making sure we had a security hardened supply chain came from Ivan. And this is exactly what we really talk about, is this idea that you can make sure that it's secure at every stage, at the image, the base image, coding, building, application image, and deployment. And I think that was a really strong message. And here is another really nice slide from Kenichi, who talked about managing vulnerabilities in an automated way. So actually spotting the vulnerabilities, perhaps at the CI level, but if not at the GitOps level, and then doing automatic reporting into StackRox, and same with incidents, automatic reporting to Slack, to Jira, and to on-call alert systems. And I think this was a really cool story. I really enjoyed this presentation. So we talked about GitOps for developers and this idea that we need to have an easy getting started experience, a local development environment, a seamless move from development to staging to production. And Matt from Sneak had this idea that we need to start security from developers, from the IDE, from the CLI, that we need to start analyzing the security challenges right at the very beginning with the developers. And I thought this is a really strong message. And I think one of the messages we're getting here is this shift to the left message, that in order to make all this work, we need to have the foundations in place properly. We need to create a environment where people are thinking about security, are thinking about ops. And I just to go back to GitOps for developers, this seamless move from development to staging to production is very much about that supply chain, but also making sure the vulnerabilities are detected throughout the supply chain, which was another strong message from Matt at Sneak. And I really like this chart where he talks about, detecting vulnerabilities at development time, at CI/CD, at GitOps time. Yesterday, I talked about this idea of self-organizing teams, about boundaries, and about freedom. And one of the talks that I think really fitted well with that was Steve and Gavin, who talked about building a self-service platform. And this is really about empowering teams and developers to build what they need. And this self-service concept is absolutely key. And this quote, I think, is just amazing. That got a proof of concept of a bank. I mean, this is not just a proof of concept of a shop. This is a genuine bank called Metal from NatWest. In a few weeks, showing real transactions from customers in the ledger with zero help from platform. And I think that was an incredible story. And this speed, this velocity that empowerment of the team brought is just clear in this. Look at this: 418 releases to production in the last month, 104 releases average to production every week, 807 releases on average to all environments every week, and that's from last month. So I'll come back to this again, but these metrics about velocity are absolutely key. And this bridge from our aims, we need velocity, we need security, we need governance, we need to speed up but not screw up. These are all amazing stories of how people have brought about this. Scott will be talking later today again. I think we can just sum up his excellent presentation in these 4 icons he used. I thought that was lovely. And for those of you who didn't see it, I have a little cheat sheet. He talked about velocity, simplicity, avoiding downtime, and reliability. And once again, these are all about those, speed up but don't screw up message. And Tiffany did a great presentation talking, and this slide in particular grabbed me. The idea that, move from these 8 to 10 week release cycles, big bang, with a release party, late night deployments, to a completely automated GitOps deployment with 10 to 100 deployments a day, reliable, reproducible deployments, and simple rollback. So this really talks to the process improvement and the people improvement, because this is not just bringing a more reliable system. This is giving people a happier life. They don't have to stay up all night and stress out about a deployment because it's just everyday usage. And as I said, all of these things come to these 4 significant metrics: lead time, change fail, deployment frequency, and time to restore. And we heard very good statistics from Metal about that lead time reducing by 50%, deployment frequency increasing by 50 to 75%, mean time to restore down from days to around 15 minutes. So these were amazing results. And then we had Cornelia's talk, and Cornelia's talk about patterns for GitOps. And I thought this was really insightful. And this story about delivery controllers and runtime controllers, I think, was really, really interesting. So this is the idea that we have a set of changes to the Git repository, and we have 2 steps in managing this GitOps flow. One is to deliver that configuration to the right place, and then the other is to do reconciliation and drift management to make sure that we are always at the required result. And this is really about self-healing and automation. And this is one of those key messages, I think. And there's this very nice slide from Cornelia talking about the source controller, Helm controller, customized controller, and then those runtime controllers that actually give us the reconciliation and drift management. And this creates a set of what Cornelia called GitOps pipelines, and those are really cool. And I really encourage you to sit in on the on Breece's demo, which is going to come up shortly, on how to get Flux 2 running, and that will really dive into this, into Scott's discussion of how to migrate from the Helm operator to the Helm controller, and how to really get these qualities with Helm, and then Stefan this afternoon. So there's an amazing set of technical sessions today that are going to really dive into how to implement these kind of GitOps pipelines that give you that speed, governance, and all the things we've talked about. And then we had joined the GitOps cult, which was just awesome. And David Allen's presentation was really one of the highlights of my day. And I love this quote. In fact, two quotes. There's the quote from Creed Bratton, which is, you have more fun as a follower, but you make more money as a leader. That was hilarious. But actually, I really liked David's quote, which was, you're not seeking out new GitOps members. They come to you and you're ready for them. And that's, I think, really insightful, because if you look at GitOps, you know, the world is coming to GitOps because it's so clearly solving a problem. And of course, there are detractors, and sometimes they don't understand it properly. Sometimes they have their own good reasons, but fundamentally, we've seen this huge shift. And we heard yesterday Alison talking about the growth of GitOps, and that was really cool as well. One of the things David dived into was something that I started the day with, which is psychological safety. And it's very, very important to think about not just the processes and the technology, but the people. And this quote from Google about high-performing teams need a culture of trust and psychological safety. David had this, this awesome concept of a playground. And this idea of creating a playground that creates a psychological safe environment for people to mess up, deal with mistakes, and move on, and build that psychological safety to be progress, I thought was an amazing message. I was really, really blown away by that. So what about today? So we had a great day yesterday, and we have an amazing lineup today. So we have got a whole bunch of awesome speakers. Cornelia's back. I've already mentioned Brice, Scott, and Stefan. Mahmoud, David, and Kishore are going to also talk. And we have Somtochi talking about RBAC, so role-based access control in the context of GitOps as well. So it's a pretty awesome lineup. We're starting out with Brice and the workshop on getting started with GitOps. That's a 90-minute session taking us through to a 12 o'clock break. After that break, we have David Mackay from Equinix talking about the law of Demeter. And this is really about bare metal approaches to GitOps. As I mentioned earlier, we have Somtochi talking about tool-assisted RBAC for operators just after that. And then I'll be back to host a Q&A with those guys. So I hope you join me for that. Scott, Kishore, and Mahmoud are going to be talking about how Fidelity Investments have migrated from Helm 2 and really talk about the Helm 2 deprecation in the context of the customer. And then Scott's going to follow that up with a session on what Flux could do for you. And then there's a Q&A about Flux 2 deprecation. About Helm 2 deprecation. And then we have a deep dive from Stefan. You're always guaranteed a deep dive from Stefan, but this is everything you wanted to know, but were afraid to ask about Flux v2. And again, a Q&A. And then finally, a real kind of call to action from Cornelia, which is going to be, what is your first or next step towards powerful GitOps? And ending at around 4:30, so you can all go and have a good weekend. So I'm really looking forward to this set of events, and I think this layout of really trying to build the motivation for doing these things yesterday, and then the how can we do it and how can we move forward is a great agenda for today. And of course, I do have to once more mention the fact that Helm 2 goes out of support today. On Friday the 13th. I don't know if they did that on purpose, but they published their deprecation timeline back in August with this, frankly, rather bad bit of poetry stolen from Lewis Carroll. And if you read that blog post, you'll see that today is the day. So next up, I think I'm a couple of minutes ahead of time, but really close. Next up is Brice, who is going to be kicking off a workshop on getting started with GitOps. And he's going to be setting up a GitOps pipeline using Flux v2, which has recently been renamed. It used to be known as the GitOps Toolkit, but that's really the underlying SDK now. And so Brice is going to talk through installing and configuring Flux 2 to manage your GitOps, your Kubernetes clusters with GitOps. And I hope you really enjoy it. I'm looking forward to it myself. Thanks.
Paul, thank you so much. We much appreciate it.
No
Thank you,
problem.
Paul.
Thanks, Bianca. I will stop sharing right now, and that will enable Brice to get going.
Yeah, so I'm hearing from the backstage that as soon as Brice is ready, we'll take it straight to him.
Cool.
So
Good to go.
Brice, how you doing?
Good, thank you. Good morning.
Good morning. Goodbye, Paul. Yeah,
Goodbye,
so
guys. Thanks, Brice.
Cheers, Paul.
I guess we'll just ask Brice to take it away, right, Simon?
Yeah, thanks.
Sounds good. Sounds good. Brice, did you feel good about yesterday, and are you excited about today, or what?
Yeah, I really liked yesterday, actually. I got a lot out of the talks, so that was really good. And I'm looking forward to today too. There's quite a few things I want to learn about, and people who are very interesting and I want to learn from. So yeah, looking forward to the day.
Yeah, good stuff. Good stuff. People, a lot of folks see your demos out there, so a lot of folks kind of tune in, and you're a popular face within the community from a GitOps perspective and from a Weaveworks perspective. So it's actually good to have that consistent messaging and that consistent person. Today walk them through how to get started with GitOps. I think you do a great job. So the anticipation is high. Don't let us down.
All right, let me try and see what I can do then. That's
you
you set me up now. All right.
Cheers.
Bye. So good morning, folks. I hope you've enjoyed Paul's intro. You did a really good job recapping the day yesterday. I think we had a really good day, but it's time to kind of get a little bit more hands-on today. So hopefully we can kind of learn how to do things in practice. And to get us started, we're going to be walking through what is a reasonably basic setup of a from scratch. This is like nothing up my sleeve. So from scratch setup of the GitOps pipeline on Kubernetes. And this is really from scratch. We should be able to do this from just a browser if you have a terminal that might help you on your local machine, but you don't even need that. What you will need is to get hold of DigitalOcean login to actually run through the tutorial. So let me try and figure out where I can share my screen, and then we can get started. Brilliant. All right, so getting started with GitOps. We'll make sure that the slides are available to you, so that they'll be available to use to copy, use, and abuse, and share inside your company as well if you want. As it says here, I'm from Weaveworks. I work essentially with our customers. On the engineering side, with our customers. So I don't build the products, I don't build Flux, but I work with customers to build their platform. So the things we're going to be talking about today are really the kind of things we'd be doing for a customer or with a customer, and we'd be taking it much further, but when we work with our clients. So the plan for today is, and this is a plan, but all plans will eventually not go particularly well, so we'll see how it goes today. But we'll set up a GitOps deployment pipeline from scratch. We'll deploy an application, we'll expose our application so we have a public endpoint for our application, and we'll release a new version of our application. That's the plan for today. Maybe we'll do progressive deployments. Maybe we'll do a canary release. This is if we have plenty of time. but it would be a bonus if we get to that point. So if you want to follow along, you'll need your browser, you'll need a GitHub account, you'll need a DigitalOcean account, and maybe an SSH client. You don't have to, don't feel compelled, don't switch off. Hopefully it'll be interesting and useful, even if you're not following along. I'll make sure that after this conference, you get in the email, you'll have a link so that you can walk through this tutorial yourself. All the information will be available to you after this conference, so you can do this on your own. So if you want to kind of just relax, kick back, and get a nice drink, please feel free. But otherwise, if you want to follow along, you'll need those things up and running. And this is really going to be a from scratch setup. So we're going to be building the development machine, and then building the environment, and then building the actual putting the application together on top of that. We're not going to write the application code. Stefan, who's a contributor, and you will have known Stefan if you're part of this conference. Stefan built PodInfo, so we're going to reuse PodInfo from him. Okay, so I'm just going to do a quick recap of GitOps itself. I think this is important just in case you're joining us today. I think Paul did a really good job of overviewing yesterday, but I just want to focus on GitOps itself. It should take us maybe 10 minutes. We've got plenty of time today. So we'll do a quick recap of GitOps, and then we'll get started with actually building our environment. So we've talked about what GitOps is. It's an operational model. It's how you operate. It's derived from computer science and operational knowledge, things like control theory, etc. It's technology agnostic. We talk a lot about Git, and we talk a lot about specific technology, but really, as Cornelia said, and as I'll reiterate here, it's really about a set of principles. It's why instead of how. How is something that we can help with, that a lot of vendors can help with, that you can build yourself, but it's really about the why. And the core value is really velocity, right? That's the core value, and Paul made that point very eloquently yesterday and today. So we talk about the GitOps model, and we're going to be working with Kubernetes. Now, this is the GitOps conference, not a Kubernetes conference, so I don't necessarily expect you to use Kubernetes or be very familiar with it, but you can replace Kubernetes by whatever environment you're currently managing. We're going to be using Kubernetes because it's nice and easy to get started, and it has a bunch of nice features around GitOps, but it is not necessarily the only environment that can be controlled with GitOps. And typically what you used to have is kubectl direct access, right? You'd have a direct access into your environment. And I think Cornelia said yesterday that kubectl is the SSH of cloud native. And I think she's absolutely right? It's an anti-pattern to use SSH to manage an environment if you're a sysadmin. It's an anti-pattern to manage a Kubernetes cluster with kubectl if you're an operator of a Kubernetes cluster. Those are anti-patterns. So we make those, we remove those patterns altogether. So from now on, we'll be using a configuration repository, using a deployment agent, and as mentioned previously, and as I'll explain in some detail here, the deployment agent living inside the security boundary makes a big difference. We're actually putting the deployment agent on the cluster itself, not in the CI environment, not in the PR, the verification software that runs on a PR. All of that, actually, the actual deployment agent and the keys are actually running in the cluster. And we'll have an image repository, but that's part of the course when working with Kubernetes. And really what's really important here is this control loop. Right? It's the fact that we're actually iterating and converging towards a good state, the desired state. So if you imagine, I will talk to the engineers amongst us. If you imagine a PID controller, essentially what you'll have is a damped oscillator, right? So it's like it starts off wild and then you're slowly converging towards a narrow point, which is your desired value. Well, it's very much the same about control with GitOps. We're building control loops. And note that there are many control loops in your environment. I like to think of these nested control loops. There are control loops in the Kubernetes cluster with the controllers themselves that are explicit control loops. We have control loops around the coding and the development. And we also have the control loop around actually managing the infrastructure. So there's lots and lots of control loops and all nested within each other. And really those are within the greater, it's worth pointing that these are really part of a greater whole that moves all the way up to the agile feedback mechanisms, things like retrospective, which are essentially human system control loops. That's how I tend to think of them. These are ways of bringing information into the system and changing the system based on the information from the external inputs. And really, that's what we're doing here. Cool. So principles of GitOps, we've talked about these yesterday. The entire system is described declaratively. The canonical desired state is versioned in Git. Approved changes can be automatically applied to the system, and software agents ensure correctness and alert when the system drifts away from its desired configuration. Cool. So declaratively, I really like to belabor the point that this is data, not code. Data is implementation independent. It's very easy to abstract. Code is, I mean, we have tools to abstract code, but data is actually quite easy to abstract in cheaper ways and less complex ways. It's much easier to validate for correctness. If you think validating code for correctness is easier than data, I'd like to introduce you to Alonzo Church and Alan Turing, and the very bedrock of kind of computer science, really. This is where it all kind of started. It's hard, right? Verifying and validating code is genuinely difficult. It's fundamentally difficult. In fact, there are certain things that you cannot validate without actually running the code. So really, when we move to data, we're skipping that problem altogether, which is a big deal. That is a categorical difference when we move to data. And it's much easier to generate and manipulate, right? Within the first few weeks of your life as a developer, you will have written and read structured data from a file, right? So pretty much it's very accessible once you describe the system declaratively. Everything is versioned. We've talked about this canonical source of truth. That's the don't repeat yourself principle. And it's trivial to roll back, right? What I really like about this, and I don't think we've talked about this yesterday, is that having this declaration in a version state store really democratizes the access between humans and machines. I sound like some AI rights advocate, but really what I mean is that it's a really good place for human and software to interact together, and so that all the checks you put in place can be reused for both agents. So you can have a software agent making commits or making pull requests, and then you can have a human agent making commits and making pull requests. And essentially, any verification you do can apply to both processes, human or software agent. And also that means you can start doing things, automating the things that humans do often, but can be automated. As Michael Hausenblas mentioned yesterday, we should concentrate the work of software on things that are repeatable, that are kind of always the same, that humans are not good at these things. So basically get software to do the things that software is good at, get humans to do the things that humans are good at. Everything is applied automatically. That's where you get the velocity gains. We want to separate what and how here, and that's around the privilege escalation and how we move the credentials into the operator inside the security boundary. And finally, we have things that continuously ensure correctness, right? That's really the key. That's closing the control loop. And I'll talk about closing the loop quite a lot during this workshop. But really, closing the control loop is what GitOps is about. And what's quite neat here is it's easy to recover from what I call PEPCAC or picnic error, problem in chair, not in computer errors. So if you're an operator, and as an operator, I can tell you that I do this way more often than I'd like to admit, but you'll make mistakes. You'll make mistakes, and this is a way of avoiding those mistakes. And when you actually do make a mistake, because the system self-corrects and converges to a known good state, your mistakes will essentially be erased automatically. Which is a good feature. That's a positive feature. Okay, talk about security a little bit. I don't think we've explained in detail what that is. Really, this is a typical CI pipeline. So this is your typical non-GitOps CI pipeline. And I think Tiffany mentioned this yesterday. And really, when you move to GitOps, you're moving the actual deployment inside of your cluster, inside of your environment infrastructure. So once you've got that and the deployment is reacting to your desired configuration, your desired canonical state, your state essentially from your state store, which is Git. And then you have operators, and those could be a human, those could be software, actually manipulating that state. And you'll notice here that there's no credential in the CI pipeline, right? You're removing those altogether, and that's a massive improvement in the security, the surface area, the security surface area for your CI pipeline. It's a massive reduction in the security surface area you have to care about, because the CI pipeline no longer has direct access to your environments. The only thing it has access to is a write access to some sort of state store. And I think Cornelia made a point very eloquently that you have this this immutable boundary, which is your state store, your container registry, or your configuration registry. And that immutable boundary improves your security posture dramatically. And because you have a single point of entry into your environment, into how to manipulate your environment, that also means you have a single point of enforcement for policies and constraints. That's a big deal in a lot of enterprises. A lot of enterprises care a lot about enforcing their security policies or their compliance policies, and you might be legally required to do so. So it's a really good idea to centralize that so that you can enforce a common set of policy across all operations. If we had kubectl access, direct access to the infrastructure, this becomes much harder. It's much harder to validate, verify, and enforce policies when everybody can have SSH credentials into your machines. And you get awesome auditing. Really, if you configure your environment correctly, the auditing is really second to none. People are going on about blockchains these days, but I like to think of Git as the original blockchain, and I like to call it Merkle trees because I'm quite old-fashioned. But essentially, you have exceptionally good guarantees, especially if you use things like signed commits, that are cryptographically secure guarantees, which are, I will happily move to any system that provides the same guarantees as Git for state storage if I could find it. I've just not found it yet. So what are we going to actually put on the control here? And I'm very sorry for my sins against the English language here, but really we're talking about, well, everything, right? Kubernetes manifest, obviously, application configuration, provisioning, configuration. So that's how you provision your infrastructure, your dashboards, your alerts, your runbooks, your application checklists. That's the policies you have around how your application should look. Your monitoring data pipelines and your secrets. Everything should be versioned. Everything should be immutable and put in an immutable version store, without exception. And really, once you have a common store for those things, it becomes really easy to implement good patterns. So for example, a good pattern is that every application has a dashboard, has alerts, and has a runbook. Well, you can check that on the pull request that deploys the application. You can verify that an application has those things if they're all versioned in a store, in a state repository, a state store. You can check that any commit is not going to create an application without a dashboard. You can verify good practice and enforce them at that level. And this is kind of it stops bad practices from actually getting into your production environment, while not really being let's just say, as aggressive tool as a code review, right? You're having these things as automated PR, feedback from an automated agent, which has different social connotations from having a review from your team lead or from the rest of your team rejecting your changes. So there's some social aspect around that as well, around having automation enforce good guidelines instead of your peer group. So all the things, right? All the things should be under GitOps. I'm a massive believer that your entire company should be one Git push away from being restarted. We're very, very far from that, especially on the company side. You can imagine the HR system and the finance systems are not managed this way yet. They will be, right? I believe everything, including your business processes, should be in a version store, should be declared, so that your entire company is essentially just a single piece of data. You're encompassing the entire company as data. Some of my colleagues, some people in this industry think I'm a little crazy about this, but I believe we will get there. And I think some of the slightly more eccentric members of the tech community have already started moving in that direction. But to be determined when that actually happens. So why do we actually care? We've talked to no end about why we care yesterday, really. So I'm kind of going to make this skip over this because we've talked about this yesterday a lot, right? We talked about the motivation behind GitOps a lot. Really, I think the one point we didn't make is the software-human collaboration point, which I think is going to be more and more important as we have smart agents making decisions about infrastructure. Okay, so let's set up a cluster. To do set up a cluster, we're going to be using DigitalOcean. Now, if you don't have a DigitalOcean login, relax. You can create one yourself. It will ask you for your credit card details when you sign up. Honestly, we're going to be using this for maybe an hour or so. You're going to incur less than a dollar, certainly less than a cup of coffee if you do sign up for the first time. If you already have an account, I think you'll be okay. The reason I chose DigitalOcean is they're really quick for setup, so it's good for it's really good for demos and tutorials because they can be spun up super fast. Okay, so let's go into DigitalOcean and actually create a cluster. I'll need to find my. You'll need to forgive me. I'll need to go find my desktop. So if I go into DigitalOcean, I go to the home of my project. I can create a new cluster, Kubernetes. I can check my region, check my pool. I'm going to change my nodes. We really don't need fancy nodes here. And click create cluster. Well, within a few minutes, we should have a cluster up and running. This will come up here. And the node pool is just coming up. So this is a good opportunity for you to log in. You can see I've been running multiple clusters since yesterday, and you can see my usage at the top right. So relax for the credit card details if you're going to be signing up. We'll be deleting everything by the end of the day. So yeah, I've got this cluster up and running, but hang on, Brice. There's something wrong here. There's something deeply wrong. That's not GitOps, right? We're not doing GitOps. We're going to get a cluster. We're going to get a Kubernetes cluster, but we want to do that via GitOps. Surely we want to declare our cluster. That's the entire point of this conference. So how do we do this right? Yeah, I agree. That's not GitOps. We're going to get a cluster here, and it's coming up, and it will be up in a few minutes. But how would we do this if we wanted to declare everything? Right. So let's do it the GitOps way. So to start, we'll need some sort of tooling, right? Because we're manipulating files and we're going to need to call APIs and we're going to need to set up operators, we're going to need to set up a tooling environment. So let's tackle that first. Let's build a small, simple machine on which we have all our tooling. Now, in an ideal world, you would do that declaratively, but there's got to be a lowest turtle somewhere. So we're going to call the environment, the dev environment, the lowest turtle that we're going to do imperatively. So let's create a droplet. Instead of an entire cluster, we'll just have a machine, and then we'll use that machine to do all the GitOps instead of our cluster. And once that's done, we can get rid of that machine. Okay, so instead of a cluster, I can delete this guy. And I'll create a droplet. So this will just be a virtual machine. I'm going to choose Ubuntu Basic. I don't need a lot of power. I'm going to put it in London because that's the nearest location to me, so it should be faster. I'm going to use an SSH key here, but feel free. Oh, thank you very much. Yeah, of course. So I've just been asked by the moderators to zoom in a little bit because it's a little bit hard to see. So yeah, so I'm creating a cluster here. So I'm not a cluster. I'm creating a dev machine. This could be your local environment. I'm going to use a kind of off-the-shelf environment here, just so we can have a reproducible tutorial. If you wanted to install the tools on your own, please feel free to do so, and we'll go through what tools you're going to need soon. So I've got SSH key set up, but feel free to create a password if you're doing this. I only need one droplet. Let's create this. So this should be up very shortly. So let's take a look at what we're going to do. So we're going to set Ubuntu Basic, the smallest instance we can get hold of, local region, choose a password, add your SSH key. So essentially what we're getting is a dev machine that has Ubuntu running so that we can run the setup scripts. So let's connect to our dev environment. Obviously, we need it to be up and running, so we'll wait. This droplet here, we've got a public IP. It should be up and running. So I can switch to my console. Please give me a shout when this is big enough. Go through the certificate acceptance dance. Cool. We have a machine. We have now got a dev environment we can start manipulating and changing. So it might be a good idea. I can't quite see the chat or the comments and things, but if you've managed to get something like that up and running, let us know in the comments. If you're following along but you've still not got there quite yet, also let us know in the comment. And Stacy, who's moderating behind the scene, will let me know whether you've managed to reach this point yet. So I'll give everybody a few minutes for the sake of this workshop to reach this point. We want a Ubuntu machine up and running that you have access to. And if you want me to jump back, if you want me to re-show a slide, if a step wasn't clear, do give me a heads up. Do give us a shout on Slack. Do give us a shout on the YouTube chat. For those of you following along on YouTube, let us know, and I can go back and go over any points that weren't clear. All right. So we'll kind of move forward, but don't hesitate to ask any questions. I like to make this as interactive as possible. I know it's quite hard when we're remote and this is a webinar, but essentially do ask questions. I'd be delighted to answer. So now we have our development environment up and running. We're going to be installing a set of dependencies. The dependencies we're going to have are Pulumi, which is our configuration and infrastructure declaration language. Flux, which is the GitOps agent we're going to be using. Python virtual environment, that's just a little bit of housekeeping for Pulumi. And kube control, which is going to allow us to inspect our cluster. Now, we're going to get kube control, and we're going to have read access and write access to our cluster in practice once we set it up. But honestly, kubectl, once you've got it in production, will only ever have read access to your cluster. And that'll be to be able to debug what's going on, to be able to observe what's going on, rather than to modify the cluster. So I can take this tiny URL, setup GitOps day. Let me run this into my terminal. So I'm on my dev machine. Curl -L so I can follow redirects. And you can see, I think I might have got the wrong setup GitOps days. I've just got them the wrong way around. So this is just a small script that actually installs all the dependencies. I promise you nothing nefarious is going on in that script. Hit the shell. You get a welcome message. And as I said, all of this will be made available to you after the GitOps day. So if you want to go and follow this along at home afterwards in your own time, please feel free to do so. And now we're going to grab hold of the various new shortcuts. Cool. So we now have a GitOps days environment that we're now ready. We can check this. Check that. Root kube config, right? There's no kube config yet. We haven't got a cluster. We have no kube config. That seems pretty reasonable. So we have a set of environment. Flux is installed. Pulumi is likewise installed, and the file. So kubectl is also installed. Right, so we have all our dependencies up and running with that little script. So I'll leave this here for just a few moments. So those of you, if you want to follow along, you can grab this URL. It's just tinyurl.com, set up GitOps days. It'll give you a shell script that will set up a development environment. It's designed for Ubuntu. If you're not running on Ubuntu, this script will not work. But if you're following along and you've set up your own development machine on DigitalOcean, this will work just fine out of the box. And you'll see a nice little GitOps Day 2020 shell prompt when you've managed to install that. Just to give people a few minutes to copy that URL. Phenomenal. I'm told that it's also posted in the Slack channel, which is perfect for anybody who's following along. Thank you very much for doing that, by the way. Okay, so we've got our dependencies up and running. So this is a kind of second checkpoint. Is we now have Pulumi, we have Flux, we have virtualenv, although we're not going to deal with this directly, really, not just yet. So now it's time to think about creating an access token for DigitalOcean. So DigitalOcean will let us create access tokens so that we can talk to its API, essentially. So that's what we're going to do next. And that's going to allow us to use the API declaratively, right? We're going to be able to declare what we want, and then an agent is going to take our declaration and turn it into a bunch of API requests. Now, I believe, from what I remember from reading the docs, that the DigitalOcean API is already declarative. It's a REST API, which really, well, it has CRUD semantics, but you can just declare things on there as well. But we're going to be creating that token. So to create the token, go to your DigitalOcean page. You can scroll down to the left at the bottom. It says API. Click on API. Tokens keys. You can create a new personal token. Now you'll notice here that I've already got a few up there, but I can create a new token. What I'm going to do is I'm just going to click generate token. This is live. This is going to be on YouTube. So I'm just going to stop sharing my screen just a few seconds, just so I can copy that token without you guys seeing it. Because I know some of you would be tempted to then go and spin up a Bitcoin miner on my own. And this is genuinely my own DigitalOcean account, and I can't afford to mine Bitcoin for you guys. So let me stop my screen share just for a few seconds while I copy this token across. All right, we're good to go. So I've copied my token. Well, you can still see it on the screen, but hopefully you can't quite memorize that just so fast. I've created my token. I've added it to my environment. So now I should be good to go. I have that access token that lets me access DigitalOcean and create resources from the command line. So now we have a dev machine, right? We have a fully functional dev machine suitable for our tutorial today. So the next step is let's start declaring our cluster. Let's create a cluster declaratively. Now we have all the tools we need. It didn't take too long for us to set them up. I promise you, if you're going to be following this at home on your own time, it won't take you very long to set this up either, no matter what your machine is. Flux, Pulumi, and the kubectl command line are widely available in almost all distribution, Mac, Linux, and even Windows if you must. I believe all of that will work as expected. So what we're going to do now is log into Pulumi. And Pulumi is going to be the thing that manages our infrastructure. And in this case, our infrastructure is Kubernetes itself. So we're going to be, we need a place to keep the state of our infrastructure, the last known state of our infrastructure. And Pulumi has a bunch of options to do this. We can use their servers. So Pulumi is backed by a company, so we can use their servers. We would need to log in and have an account though. You can use S3, you can use a variety of backends, but we'd have to set those up. So for today, what we're going to do is we're going to do it locally with files, right? We're going to be logging in locally with just some files. So if I go into my console, I can do Pulumi, login local, and it'll tell me I'm logged in the file system. That's what I need to tell Pulumi, that I'm going to be storing my state locally instead of storing it remotely. In a production setting, you'd want to store your state somewhere else. You'd want to store your state somewhere like an S3 bucket, or some sort of remote state storage, redundant state storage. For now, this is just a demo. We're okay with the limitations of storing state locally. Once we've got our Pulumi installation up and running, and we've told it we're going to be storing our state locally, what we're going to be doing now is we're going to be using it to generate a template. And that's just a bunch of boilerplate, really, for Pulumi to be able to manage infrastructure for us. So what we're going to do is we're going to create a directory for our infrastructure inside of a directory for our entire tutorial. And then we'll initialize a set of files inside of that directory using Pulumi. Now, for this tutorial, I'm going to be using Python. I think it's very readable and it's very accessible for everybody who's watching. But actually, it supports F#, C#, JavaScript, TypeScript, and Golang, right? In fact, pretty much anything that can target CLR, that's a common language runtime for .NET, is capable of running Pulumi. Anything that can target JavaScript, including ClojureScript and the host of language that have proliferated on top of Node.js, is capable of running Pulumi too, and Golang. So there's a variety of choices for you. Now one thing that is not as perfect as it could be is that Pulumi uses code. It doesn't use data, and we'll see what that code looks like. The code is declarative fundamentally, but it is still code, and it still is harder to verify than pure YAML or pure data. That is one of the issues I find with Pulumi. It's just that it's a pragmatic choice that sadly violates one of the principles, but we'll see how it redeems itself at the end of this tutorial through some of the tooling that lets you build the entire control loop. So this is a kind of a pragmatic choice, and I think that's what you'd find in your own operations and your own development is the principles of GitOps are really there to guide you in a good direction, but you're still allowed to make pragmatic choices along the way. And also, as we've seen here, right, my development machine is set up imperatively. There needs to be a lowest turtle, right? There needs to be something at the bottom that is set up in some way that is not declarative, that can support the declaration of other things. Now, if you've ever bootstrapped a language, if you've ever done that exercise, you'll understand that there are techniques for essentially bootstrapping a declarative system so that it stands on declarative ground. But essentially, it involves a lot of juggling between declarative and imperative. You set up an imperative system that sets up a declarative system that sets up a declarative system, and then you remove the imperative system. It's a lot of hassle, and pragmatically, it's almost never warranted. It's okay too. Yeah, so the question from chat around preferences between Pulumi and Terraform. Honestly, I like Terraform too, and I've used Terraform a lot. The reason I'm using Pulumi here in this tutorial, I actually started writing with Terraform, is that Pulumi recently put out and we'll revisit this particular topic. They put out a Kubernetes operator, which lets Pulumi have a really well-rounded control loop in a way that Terraform operators still aren't quite as mature yet. So we'll regain this. This is why I'm using Pulumi here instead of Terraform. Terraform has a better language, in my opinion. It's more declarative, it's more data-driven than Pulumi, which is code. Now, having code gives you a lot of power, but also makes it very hard to verify in a way that Terraform doesn't have that problem. So I really, the reason I'm choosing Pulumi for this tutorial is because of the operator, and we'll talk about that operator at the end. That's why I made that choice. I think it's, as I said, it's I want to make you feel comfortable with making pragmatic choices here when you implement GitOps yourselves. It's not, it violates one of the principles. I am aware of that, and I've mentioned it. But also, it has some other benefits that let you do useful things operationally. Hopefully, it'll make more sense when we actually reach that section where we talk about the Pulumi operator. Okay, so let's actually go ahead and do this. Let's make this tutorial directory. You'll notice I make a lot of typos. That's just me in general, but it's made worse by the fact that everybody's watching, as usual. Right, so now we're in our folder. Let's actually create the required files. I'm going to call my project GitOps Days. That's fine. Dev is fine. You can choose a passphrase for your secrets. Just remember that passphrase. Cool. So one thing that we haven't done is we need the Python virtual env. So let's actually install that. Must have forgotten to add that to the file. That's quite annoying. You'll have to do this too. I will fix the file by the time you get the links to everything. So this is really dull and boring, but we're just getting virtual env up and running so that Pulumi, so it can manage its dependencies. We're using Python libraries, so we're using the Python packaging. Triggers for ManDB. That's quite unexciting. So let's while this is running, let's take a look at what this actually does for us. We've actually created, and I'll show it in the console myself, but we actually create several files here. Pulumi will create several files for us. One is git ignore. It'll ignore kind of things we don't want around the Python ecosystem. It creates some Pulumi configuration files, which will include things like Pulumi secret references, or encrypted secrets, various environment variables for the Pulumi infrastructure, a main.py in which we're going to be declaring our infrastructure, and a requirements text, which is our dependencies. So that's what we're going to be seeing on the console once we've run Pulumi new. So let's take a look. It's still processing triggers for ManDB. We will get there. Here we go. So Pulumi new Python. Here we go. Because I've run it before, it's already generated some files. I'm not worried about that. I'm going to call it GitOps Days. Minimum dev. Dev already exists. Let me choose another stack, demo stack. That's going much better than it did the first time around. So if I have a look at what's in this, I'm just going to remove the Pulumi dev. We don't need that one. It doesn't really remove the stack, but we'll not worry about it just yet. So as I mentioned, this is, let me install tree so I can show you. So Pulumi has now generated our default file, so let's go and take a look at those. So let's take a look at pulumi.demo. That's just giving us a encryption sort, some Pulumi parameters for the demo stack. How about pulumi.yaml? That's defining our Pulumi environments, what language we're going to be using, and some metadata about the project. And main is literally the simplest Pulumi program you could have, which is a Python program that imports Pulumi. And finally, our requirements are just the requirements for Python. Don't worry if you don't know Python. This is really just an example. Pick a language that you do know and that you're familiar with to run through this yourself. Okay, so we have now got Pulumi environment up and running with our various files ready for us to start developing and declaring our cluster. So that's what we're going to do. We're going to create a declarative cluster configuration. Now, if you're following along, I'm sure Stacy will be able to paste this URL in Slack. It's just basic Pulumi Kubernetes. And this will point you to this particular file right now. Now, I recommend changing the name. This does say Breeze Demo Cluster. You probably want it to be called something else. But for me, I'm just going to copy that link. And I'll be able to curl this file into my environment. I'm just going to overwrite main. So now if I have a look at my file, this is why you should use the, make sure you use the L if you're going to curl this file so that you can have redirection follow. There we go. That's better. So this is now our declaration for our cluster. Let me change the name. Let me go for live demo cluster. So this is now how we're going to be declaring our cluster. Now, I mentioned that Pulumi is code. And right now we're going to be using the DigitalOcean library for Pulumi. But if you squint, essentially, our cluster definition very much is declarative. It's just data. We're not actually adding any other attribute. We're not running any code. This is just a piece of data, really, that has a name, a declaration for the nodes that we're going to be using, a region, and a version. Now, you'll feel free to keep it in London. Otherwise, look up the DigitalOcean regions and add to them yourself. But essentially, this is just a declaration. We can imagine that this could be a piece of YAML too, and that would be perfectly acceptable. And finally, once we've actually declared our cluster, I'm just going to be exporting the kubeconfig for our cluster so we can use it to read what's on the cluster itself. Now, for those of you using DigitalOcean, please note, this is important, that DigitalOcean will rotate the credentials for your kubeconfig every 7 days. So the kubeconfig from DigitalOcean is not suitable for long-term use because the credentials get rotated quite sensibly, I might add. So you have to do different things and you have to grab the kubeconfig in another way if you're going to be using this over a longer period of time. Now, this tutorial should not last 7 days. I should hope not. It won't matter for us today, but it will matter for you if you actually run this at home or if you try and recover your cluster after 7 days. So just be aware of this. If you need help working around that, give us a shout. Literally just send me an email and say, hey, Brice, I've just hit that issue you talked about during your workshop. What do I do now? And I'll send you the appropriate Pulumi Python that will kind of wrangle the right kubeconfig back out of your DigitalOcean instance. Anyway, caveat over. Now we have a Kubernetes cluster. We also have exporting the Kubernetes cluster's configuration, kubeconfig. I think we're good to go. And so the next step, once we have this, once we've actually declared our cluster, is to actually, we need to do a few things. So the first thing we're going to need to do is we're going to need to set up our dependencies. So you'll notice in my cluster configuration here, I'm importing another library besides Pulumi, which is Pulumi DigitalOcean. Now we've not imported that. We've not managed that library just yet. So we'll need to do that. So let's start with importing that library. So Pulumi has set up a virtual environment for us. And as I said, do not worry if this is unfamiliar. If you're not familiar with Python, this is not very important. This is just a dependency management, and this is Python-specific dependency management. So really, really relax if this is not familiar. We can check that we're actually in our virtual environment. Yep, we are indeed. We're going to be installing Pulumi DigitalOcean. It's better if you spell it right. Cool. So now I've got my dependencies up and running in my virtual environment. I'm just going to go pip freeze, which actually just gives us a list of all the dependencies. And I'm just going to use that and put that in the requirements file. Once again, if none of this is familiar to you, relax. This is just Python specific stuff. Don't worry too much about it. So now I should be ready to actually run my Pulumi. So now we have all the dependency. I should be ready to run my Pulumi to actually implement our declaration on the real system, on the DigitalOcean. The last thing we're going to need is we're actually going to need to tell Pulumi how to access DigitalOcean. So you remember at the beginning, we created a DO token environment variable for this purpose of actually telling Pulumi how to access DigitalOcean. And we're going to do that again, DigitalOcean : token. Now I should have the DigitalOcean token up and running in my environment. This is in fact a secret, right? Pulumi will not write that out too. I guess I don't have the DigitalOcean. Now I've saved that up in my, there we go. Now I'll need to unlock my secret. So the secret is encrypted. I'm also going to add my secret configuration to my environment. So and this is something I like to do for projects. So now I should no longer have to type in my passphrase every time because it's in my environment. So now we're ready. This is it, right? We're going to be running Pulumi to actually create some sort of infrastructure. To do that, we're just going to call Pulumi up. And it's going to give us an idea of what it's going to try and do. So it's creating a stack. It's inside that stack is going to create a Kubernetes cluster. Yeah, I wish to perform this. I wish to do this. So I can click yes, and it will start to create my cluster. And we have about 40 minutes remaining. We're about halfway through this workshop, if I'm not mistaken. So we have a little bit of time left. This will not take very long. And we can actually jump into our UI, our DigitalOcean UI. And we can see that this cluster is now being created. We've got Breeze Live Demo Cluster being created right now. So essentially, we're now we are now creating our infrastructure based on the declaration. Now, you'll notice that this is not, we've not committed anything to a Git repository, and I will talk about this later. As I said, there has to be a lowest total, and I'll give you some tips and some hints about how to make that lowest total as declarative as possible, and how to run this entire loop declaratively and automatically, right? Because we don't really want to be doing Pulumi up by hand. We want to be pushing some configuration to a repository and have Pulumi up run independently without our intervention. And I'll show you what tools to use to do that shortly. Now, it'll take a little bit of time for the cluster to come up, but we're not going to continue with our presentation. Now, one thing that we're going to need to do is we're going to need to have read access to our cluster. We'll need to be able to create a kube configuration file, and then we'll be able to use that to access our cluster. So once this is done, we'll go about making that configuration file. Now, since this is going to take a couple of minutes, I think it's a good time for a short break. I don't think we have DJ Desired State up and ready, primed for another session just yet. But we'll take a short 5-minute break while we have that cluster up and running. Smashing. So I'm told music will be up and running. So let's take a short break. I'll stop sharing my screen and I'll come back. It's 22 past 11 now. Let's call it a 3-minute break at 25 past 11 while we have this cluster up and running. It gives you time to get a coffee, get a tea, or take a bio break. Welcome back. Hopefully you managed to stretch your legs. get a drink, take a bio break. Our cluster is still creating, but I promise you it won't be very long. It's almost done. And then we can get going with our actual Kubernetes cluster. So hopefully within a few seconds, we'll be able to poke. Here we go. We're literally right on time to be able to talk to our Kubernetes cluster. So this completes the creation, and if I go back to the UI, I should see it up and running, and it is indeed up and running. We've waited for all the nodes to be up and running. Usually the API, the Kubernetes API is up quite quickly, but Pulumi and the DigitalOcean user interface will quite wisely wait for everything to be up and running before giving you the all clear. So now we can create our kube config file. We have what are called stack outputs. If I just run this, it'll tell you, we have one stack output whose name is Pulumi kubeconfig, and the value is this entire YAML file. So what we can do is actually save this. Now it's complaining that my kube directory doesn't exist. Let's fix that. Cool. So now we should be able to use kubectl, which has been installed as part of the dependencies. Let's get all the pods and hope it all works. We managed to declare a cluster, and we have indeed. So this is what your cluster looks like. We can also take a look at the machines. So there are 2 worker machines. That's my specification. If you remember in my configuration file for my cluster, I only have 2 machines. The node count is 2. I've taken a very small machine. And so now we're seeing that we have 2 machines up and running on our cluster. This is good. This is exactly where we want to be. So hopefully you've managed to get yourself a cluster up and running just as well. If you haven't, once again, relax. You can follow at home later on from the files I'll send. And really, if you have a way of getting a cluster some other means, whether that's AWS or GKE or even Kind, all of this will work just as well. This is just a way of making sure that everybody who's watching can participate and do this, no matter what your machine is, and I don't have to worry about local dependencies for your machine when doing this. Okay, so we have a dev machine, we have a cluster, but what about a Git repository, right? How are we going to put together a Git repository? Well, let's make one, right? Let's start by making a Git repository on our local dev machine. So I'm inside of infra folder, but I'm actually going to make my Git repository inside of GitOps days. So git init here, git add infra, git status, make sure that we're only adding files that we want, and we are. Git commit. So now it's kind of course, we need to tell Git who we are. So let's do that. So this is me. I hope that doesn't come as a surprise. If it comes as a surprise, you're in the wrong workshop. So now we've told Git who we are. We should be able to make that commit, that initial commit without any issue. There we go, good. So now we have a Git commit, a Git repository with our state in. Is this sufficient? Are we GitOps yet? I mean, are we managing to be, what's going on? Well, we'll need a remote repository too, so let's go ahead and do that. I don't know why it's trying to connect to my Microsoft. Cool, so let's create a remote repository as well. And we can do that on GitHub. So let me jump back out. create a new repository. Public, create. Cool. So now I've got an SSH endpoint. I can't clone that repository just yet because GitHub doesn't know who I am. So let's actually create a key on our development machine. So grab our public key and create a new key in Git. I'm having issue with scrolling today. This is going to be awkward. So we go into our Git profile. Inside, I think it's Git setting rather. So Git settings, and in here should have SSH and GPG keys. We can add in new SSH keys. Add this to our Git account. And we have our new key. Cool. So now we have our key. So Git will know who we are. So we should be able to now clone and control our repository. So if I go back to my repositories, grab that, and then we can set it up. Git origin. Push that up to our remote. Cool. So now we have a new branch here, which we can take a look at. And our infrastructure is now committed to Git, right? We have all our infrastructure information in here. So you should do the same if you're following along. You should create your repository. So we've now created a remote repository with our configuration. We've just added our remote repository to so that we can control it from our development environment. And we've created an initial commit with our infrastructure file. So now we have Flux, we have Kubernetes, so we have a development machine, we have Kubernetes, and we have Git. But that's not GitOps, right? Clearly, what's going on? Where's the GitOps loops? How are we going to set up GitOps? This is not yet GitOps. We just have a few things, right? We have the declared manifest. We have the version we have the manifest in Git. But we can't move changes automatically to our infrastructure, and we have no software agents running that is managing all this this deployment pipeline. So let's install the GitOps agent, right? This is the next step, installing the GitOps agents. So what we'll need to do is we'll need to create a personal access token so that the GitOps agent can control repositories on make commit and read commits on our in our GitHub. So let's do that. Let's create a GitHub personal access token for our GitOps agent. So I go back into Git, I go into my settings. Once again, in settings, you can find developer settings. In developer settings, you'll find personal access token. You can see some I made earlier, quite a few. I can generate a new one that has repo. I can call it GitOps Days Live Demo Token. I can generate the token, copy this, and add it to my credentials. So So now I should be able to access the GitHub API, source that file, of course. I'll be able to access the GitHub API using my token so that I can create and manage repositories remotely. And finally, we actually launched the GitOps agents, right? So let's actually take this Flux Bootstrap GitHub and actually implement the GitOps agent. I'll leave this on for just a few seconds for people to have a look at this. The Flux Bootstrap help is available. So if you just do Flux Bootstrap -- help, you'll get a clear idea of the variety of options that the Flux utility lets you configure. For us, we're going to do just several things. We're going to say an owner, a repository. So the owner is whoever you are on GitHub. The repository, the name of the repository you want. The branch, what branch you're going to be looking at. The path for manifests. This is important. So where should Flux look inside of that repository for manifest that is going to deploy to Kubernetes. And finally, we're going to tell Flux that this is a personal repository. There are different API calls for personal repositories and organization and team repositories. So we're just telling Flux which type we are. All right, let's go and do this. Let's go and implement this. So I've got Flux. Let's just check we actually have Flux up and running. Oh, no common version, never mind. Let's do a check instead. It should be much happier now because we've got the kube control command line and the kube config. So Flux is now happy. So we can do Flux, Bootstrap, GitHub. I'm the owner. That's my GitHub username. Repository we were going to be using, let me take a look at my repository. My repository name is GitOps Days Live 2020. This is a personal repository. I'm going to use the master branch. I believe the new branches are main. I think I need to update my Git version for it to do that by default. So personal repository, I'm the owner, the repository name, branch master, and finally the path is going to be Kubernetes. Let me double check I've got everything right. Path, branch, repository, owner, personal. Sounds good to me. Let's actually go and run this. So it'll do a lot there. It's actually going to generate quite a lot of logs, and we'll break those down when it's all done. So if you're following along, I'll move back to the command line, so you can type that in yourself. I believe, if I'm not mistaken, Lee showed this late last night, but you might not have caught his presentation. Do we have any more questions in the meantime while this is actually up and running? Yeah, please. Let me go read that. Should I? So Ilya, who's yeah, yes, please. That would be wonderful. Yeah, so Ilya, who's a former colleague, has made a comment. Let me go see what he says. Yep, perfect. Would love to see JK also. So so Ilya made the comment that it's much harder to validate YAML if you have something more than just trivial. Whereas with config as code, if you have code like Pulumi's code base, you can have unit tests that are based around your abstractions. I mean, whereas YAML, it's much harder to validate you can write the validate tool, but it's much harder to apply those tools in different repository, different projects. And it's only really viable to validate YAML in mono repository settings. So this is Ilya's comment. Whereas a proper language, you can write unit tests for each component at the level of the component. Now, I think I understand what you mean, actually, Ilya, and I would tend to agree with you that unit tests on configuration as code, if it's actually code, is quite nice. But that's a limitation of YAML, not of declarative formats in general. YAML is limited. YAML has issues with typing. It has issue with validation. It doesn't come with a schema. There's a lot of issues with YAML that are beyond just declarative declaration, right? So I think I will stick to my gun around how declarations or essentially data is easier to validate in code. In almost every way. I will say that YAML itself as a way of declaring, as a way of describing your infrastructure is limited. And I agree with you that in terms of the tooling for YAML and the tooling for Pulumi and Python, like the ecosystem around Python validation and verification is extremely mature, right? The language has been around for well over a decade now, probably more than 2 decades. I can't remember when Python was created. So anyway, so the language is the language testing tools are extremely mature. The tools around YAML for composition are basically non-existent, right? They're a very poor composition. So this is one of my, I'm going off on a tangent, but hopefully you'll all find it interesting. I think this is a really good comment. And it raises what one of the fundamental problem of a lot of declarative languages have, which is they lack composition primitives. So YAML has no real composition primitive besides having a sub-object, right? You can't compose 2 different YAML objects, which means it's much harder to, when you're working in the large, it's much harder to create compound objects. What I really want is YAML with a fully algebraic data type. If you've ever worked in languages like Haskell, F#, OCaml, ML, you'll know exactly what I mean by wanting a algebraic data type. When you have that as a primitive for your data language, you get rid of a lot of those problems. So I think I would tend to agree around the testing tools being superior for Python than for YAML, almost to a fault. I think that's true. But I think the fundamental problem here is one of YAML not being very well suited for those kind of use cases, rather than declarative format per se being a bad idea. That's my take on it. But yeah, I think that's a really interesting point you're making, actually, around, for trivial example, it's pretty easy to validate YAML, but when it gets much more complicated, because of how YAML composes, it gets much harder because the composition primitives aren't there, and there's no real, there's the kind of an explosion of different tooling around YAML composition. Whereas if you use Pulumi and Python, it's very straightforward to write unit tests. I agree, but I think that's a specific example rather than a general point about declarative and procedural management. I hope that thoroughly answers the question and provides a welcome distraction for everybody else who's listening. Okay, so we've finished, right? We've got our GitOps agents up and running. Surely this is us done, right? We have all this. Let's actually go check Flux now. Let's do a full Flux check. And yeah, it seems to be passing everything. Everything seems to be very happy. So we've got GitOps. We've done GitOps, right? We're done. Surely this is the end of the tutorial. I mean, what actually happened here, right? What did we actually do? So let's break down the actual log outputs. The first thing that happens is we're actually adding the agent definitions to Git. Let me show you what I mean by that. So if I go into my Git repository now, and I go to the root of my Git repository, you'll notice that Flux has added itself to my Git repository. The definition, Flux is a very well-behaved GitOps operator or GitOps system. So it will add itself to your repository so that you're completely declaring Flux. So if you want to know what Flux is, it's explicit in here. It's very clear what Flux is. It'll add itself to your repository. That's the first thing it does. Let's take a look at the output. The second one it does is it actually installs the agent to the cluster. It's going to be putting the Flux agent, the live software agents, are going to be deployed to the cluster itself. So now we can see those agents. Let's actually go and take a look. If we do kubectl, once again, right, we have a set of agents, software agents running for us that are going to do these reconciliations so that whenever we change our repository, so does the system, so does the infrastructure. It's waiting for the agents to be deployed before performing a set of health checks. So that's what's actually happening, and that's what the Flux Bootstrap setup does. And as we mentioned, it's added its own manifest to our control repository in the directory we specified, Kubernetes in this case. So now we have full control of the cluster, right? We can move from Git all the way to the cluster with application deployments, right? So now we can start thinking about operations with GitOps. How do we actually operate with GitOps? So let's take a really basic operation. The first thing we're going to need to do is, because Flux has changed the repository, let's just pull the latest version, and then we'll deploy a new object into Kubernetes through the command line, through Git, really. We're only going to use Git. So let's do that now. So the first thing I want to do is pull the latest changes. We're done. I want to make a directory, which is going to be my development namespace. In here, I'm going to create a YAML file that declares a namespace. And I'm going to call it dev. This is a kind namespace. It's very picky about, it's case sensitive, so be aware if you're following along. That is my namespace. That's as far as we need to go for our namespace. I can add this file. Too used to my friendly shortcuts. Here we go. Git add namespace. Push it upstream. And then we should be able to watch. And we should expect the dev namespace to come up in just a few seconds. So just to recap, we've pulled to get the latest version that Flux made in our repository. We created a new namespace, and then we pushed our commit upstream so that the GitOps operator can pick that up from our Git repository, and we'll apply those changes to the cluster. It doesn't seem to be working, so what's going on? Let's take a look. How do we debug this? Well, the operator will actually output logs of what it's doing, as it should do. You'll notice these are structured logs. So let's take a look at those. So we're looking at the customized controller. It's a bit of a misnomer here. Don't worry too much. I'm going to follow the logs. Okay. So this was at 11:49 or 11:50. Let's take a look. Has it created our namespace? Reconciliation finished. Was I just too eager? Was I just not waiting for my namespace? Quite possibly. Let's take another look. Yeah, here we go. Dev created 46 seconds ago. So I was just too eager to figure out what was going on. But hopefully this also gives you an idea of what to do to check when things aren't happening correctly. And this is, we've got a really good log, actually structured log output from the operator that in a production environment, you'd be aggregating, storing, and you'd be able to search quite easily. Now, JSON log output is a love-hate relationship. It's a little bit awkward to read. You can see the wall of text on the upper side, on the upper half of my terminal. But in practice, it helps to have structured log outputs because in most situations, you'll never be reading the logs directly. You're going to be aggregating those logs, indexing them, and be able to put them up for searches in some log retrieval system. Okay, so now we have our dev namespace. We've essentially proved that we can close the loop on operations, right? We have our dev namespace, it's up and running. We've closed the loop on operations, right? We have the entire system described declaratively, check. We've got a Git repository version state, check. We can approve changes and they can be automatically applied, check. Software agents ensure correctness and alert on diff, check. The various software agents in the Flux system namespace. Told you make an order of magnitude more typos when people are watching. So the agents in the Flux namespace will report on their status, will report on failures, etc., and will continually converge towards a known good state. Let me actually show you this in action. So we created the dev namespace. Let me create a short alias. I'm getting tired of typing kubectl all the time. So we can see our dev namespace. Our dev namespace on our Kubernetes cluster. What would happen if I was to delete that manually? Well, it deletes the namespace. I send it to command, deleted the namespace. So if I got the namespaces now, they'd go away. What about if we watch this? What about if we actually pay attention? And if our control loop is working, we would expect the namespace to come back at some point. Now, it's not going to be instantaneous, right? There's a delay on how often it's going to do this. It might take a couple of minutes to get there, but it will eventually reconcile, and we should see the dev namespace come up. So what I'm going to do is I'm going to leave it to try to come back and reconcile on its own. While that's happening, we're going to continue with the presentation, and hopefully when we come back, the dev namespace will be back up and running. So now the question is, how do we leverage this GitOps power to do more? What we want, we've created a namespace. Okay, so what, right? Let's do some more. Let's do some more interesting things. We have about 20 minutes left, so hopefully we can go up and deploy an application in that time. So what we're going to need to do to deploy an application, because I want that application to be visible to the outside world. I want to go on a website, on a web page, and view my application. So I'm going to use an ingress controller to do that. So I'm going to install Project Contour to actually act as the ingress controller to my application. To do this, I'm going to create a new folder for that namespace. I'm going to grab the Project Contour YAML manifest from the Project Contour website and place that in that new folder, add those changes, and apply those changes. All right, let's go and actually go do this. In the meantime, 5 more minutes, okay. Yes, it's 5 more minutes, just not 20. That's on me. That's okay. Let's try and see whether we can get an application up and running. Probably not do an update, but we'll try and get it up and running in the next 5 minutes. I think we should be able to do that. So we're making a new directory. I'm going to grab the URL. So that's projectcontour.io quick start contour.yaml. Cool. So now we have our project contour. Let's check on how our namespaces are doing. Still not quite there. It will eventually get there, I promise. You can change the loop times, how long it takes to reconcile as a parameter. Let's actually just put contour in place. So git add Kubernetes contour. So now we're deploying, instead of a namespace, we're deploying an entire application stack. And you'll notice I have not touched my cluster yet, right? But I am expecting that my cluster will actually create the contour namespace. We can check the logs to see when it will actually do that. There we go. So here we should shortly be expecting that the contour, the commit we made, will come up in the logs, and then it will be applied to our cluster. Yeah, so Andre asks a good question in Slack, whether it's possible to use a Helm chart to deploy Flux, or whether it's the Flux Bootstrap is the default way of doing it. The answer is it's perfectly possible to use a Helm chart to deploy Flux. Flux, as you've seen here, is just a set of manifests. It's just a set of Kubernetes resources, really. So you can deploy them however you like, including a Helm chart. I don't know whether the Helm chart is provided by default, but it's certainly possible to do a Helm chart. I quite like the Flux Bootstrap, but I agree that for example, configuring clusters, it's not repeatedly, it's not necessarily the best idea. So Flux, I believe, has the ability to generate the Helm charts for you and just output output the manifest files for you, so you can just apply them to a cluster as well. So the answer is it's possible, and new deployments can be created with Helm too. So the new Flux supports Helm out of the box. So you can have Helm releases, resources that point to Helm charts and data, so that you can deploy your Helm components to your cluster using GitOps as well. All of this seems to have gone okay. Let's get the namespace. And we can see that both dev and project contour are up and running. Now, I believe we're kind of slowly running out of time. We're almost at the end of our time together. So I'm just going to jump straight to some of our concluding remarks, which will hopefully be useful to you. So one of the things I wanted to mention is how do we close the loop on the cluster itself, right? We managed to close the loop on the application operations, but what we did not do is close the loop on the cluster. The cluster we configured manually using Pulumi. While it's declarative, there's no agent reconciling the cluster. But there can be, and that's one of the reasons why I chose Pulumi, is there's a native Kubernetes operator managed by the Pulumi team. That means that if you declare your cluster configuration, you can have an agent that will monitor that cluster configuration and reapply it live, and reconcile the infrastructure with your declarations. Now, this is, of course, applies not just to Kubernetes. It doesn't just apply to Kubernetes at all, because Pulumi is a general purpose tool for infrastructure management. So in fact, you can have a GitOps control loop for things like AWS, Azure, GCP, and a variety of other targeted infrastructure, including, for example, our friends DigitalOcean, right? And for the record, I am not associated or affiliated in any way with DigitalOcean. I just quite like their stuff, and it's quite fast for this purpose. So hopefully, really, I mean, this is definitely out of scope for this talk, and they've got a really great demo. If you search for just Pulumi Kubernetes Operator, you'll find all the details. So a quick recap, and then I'll pass on back over to Stacy and the rest of the team for the rest of GitOps days today. So we reviewed the GitOps principles. We created a cluster declaratively. We provisioned a load balancer and an ingress controller declaratively. I didn't show the load balancer, but I promise you, if you follow the steps, it is indeed there. And finally, we deployed an application with GitOps. Well, we didn't quite get there, but we certainly did get to deploy a load balancer and ingress controller, which are essentially applications. We did close the loop on application operations, and I've talked about how we can close the loop on infrastructure operation with, let's say, the Pulumi operator. Okay, thank you very much. I will be hanging out in Slack if you have follow-up questions for the rest of the day, for the next few hours. Don't hesitate. And thank you very much for your attention and your time this morning. I hope you found it useful.
Thank you so much for your attention, Brice. Thank you. We have a 15-minute music interlude, the music break coming up now. Right after the music break, we're going to have David Mackay from Equinix Metal, who's going to have a pretty interesting talk coming up. But just really wanted to just emphasize that today is going to be a little bit more technical. We're going to, as you just saw in Brice's talk, we're going to, he dove into, why GitOps and how to get started. But if we kind of take a step back and remember the focus as to why we're here in this conference, we wanted to help newcomers really understand the basic of GitOps. And that was a real huge reason for this tutorial that just happened. And then we wanted to also give more advanced people a vision and a guidance for next steps. And then also kind of informing Flux users of Flux 2 and kind of how to get started. So throughout the day, you're going to see Stefan go a little bit deeper. We're going to have amazing content throughout the rest of the day. Really for the Helm users, understanding that Helm is being deprecated, and excited to have Scott part of our team now, who's a Helm maintainer. So, stay tuned throughout today and enjoy this 15-minute music interlude. Thank you for your time.
Pedra é o fim do caminho, é caco de vidro, a vida é o sol, a noite é amor, é rasgo anzolo, é peroba do cano, ainda canto, é madeira de ferro, estéreo profundo, é o vento ventando, é o fim da ladeira, é aqui que é o vão, festa da comida. a luz. São as águas de março fechando o verão, a promessa de junho.
Ja yksi kauni mun haaremist neid päike tundub puuvaid. Stopp, seisku aeg, nii kaebleb neid see kaamel siin, jutt taeva meid viib. Nüüd stopp, seisku aeg, nii kaebleb neid see kaamel siin, jutt taeva meid viib. Meid ju viib. Meid ju viib, meid ju viib. On mul lai limusiin, kiirus on tohutu õhus, kuid on surmav gaas. Ja mu mees, kes istub kõrval, hoiab rooli. Kõik ma olen saanud, mis eales olen ihkand kodul luksima, aga hingel on külm. Ma uurin silmanurgast meest, kes vaatab ainult teele. Aeg, nii kaebleb neid see kaamel siin, ju taeva meil viib. Nüüd stopp, seisku aeg, nii kaebleb neid see kaamel siin, ju taeva meil viib. Meid ju viib, meid ju viib, meid ju viib. Stopp, seisku aeg, nii kaebleb neid see kaamel siin, ju taeva meil viib. Nüüd stopp, seisku aeg, nii kaebleb neid see kaamel siin, ju taeva meil viib. Meid ju viib, meid ju viib, meid ju viib. Siin kuhu viib meid tee, kui kõikjal katastroofid metallikarvis kinni me. Üksi karavan teele ette jäi, ongi aega. Stopp, seisku aeg, nii kaebleb neid see kaamel siin, ju taeva meil viib. Nüüd stopp, seisku aeg, nii kaebleb neid see
I trust you're enjoying some good music. Hopefully, you got a chance to get some coffee, grab some tea. We're excited for David Mackay to join us on stage with this great presentation. David, how are you?
I'm very well, thank you. Excited to be here.
Certainly, certainly. Did you enjoy that music interlude?
Yeah, I was loving it. I was glad my camera was off, that's for sure.
Good stuff, good stuff. The stage is yours. Thank you.
Thank you very much. Let me get my slides up. Okay, so welcome. Today I am going to talk a little bit about applying the law of Demeter to GitOps, which I know is very abstract, but hopefully that'll become very clear shortly. So first, a little bit about me. My name is David Mackay. You can find me on the internet as Raw Code. I'm a senior developer advocate for Equinix Metal, the bare metal cloud. I'm from Scotland, so I'm going to do my best not to speak in my native tongue. But I'm roughly from Glasgow, if you're familiar. As far as technologies I enjoy playing with, I'm a really big fan of esoteric programming languages. That means Rust, Elixir, Gleam, Go, and Pony. And I rant about GitOps regularly on Twitter. Sometimes people listen, which is great. Now, a little bit more about my GitOps journey. I use GitOps for a lot of different things. So, it's very prominent within Kubernetes deployments to be adopting GitOps. But I also do some other really weird stuff. I like to store my data in GitOps. And in order to facilitate that, I've been working on a Rust library, or at least I had some Rust code that did this, and now I'm trying to extract it to a library. So if you're curious about Rust and GitOps, please check out gitlab.com/rawcode/gitsync. And I try to provide live databases, reloading YAML files from Git and stuff like that. I'll talk about that on Twitter one day, but it's a really cool concept. Now, what about this law of Demeter thing then? What is it? Now, you may be familiar with it. It's quite old, at least as far as, computing goes. And that this law came around in 1989, 87-ish. And the whole concept of this law, the whole point of this law was to help us write better object-oriented code, to enable reuse and composability and modularity, just so that we don't, we don't want to write spaghetti code, right? We want our code to be clean. We want it to be reusable. And while you may not be familiar with the term the law of Demeter, you may know it as the principle of least knowledge, right? We don't want leaky abstractions in our code. We don't want to reveal too much. This comes back to declarative versus imperative code as well. We want to write declarative code that asks for something to be done, doesn't necessarily tell the calling object how to do it. And that tell don't ask is another really cool property of the law of Demeter that you may also be familiar with. Something you're probably not familiar with is aspect-oriented programming. This is a new type of programming that spun out, on an alternative to OOP or functional. It has a concept called a point cut that allows you to inject new functionality into existing code without modifying the existing code. Worth checking out, but not something I'm going to talk about today at all. Now, when I talk about the law of Demeter, what I'm really talking about is coupling. And how do we build coupling into our declarative code, whether that be GitOps or otherwise? And I want to talk about something that's already been discussed in this conference, but I think is really important. If we take a look at our traditional CI and CD pipelines, we store our code in Git. Our CI system is aware of the Git, so it's coupled, and it builds an artifact of some kind. And then typically our CI system is aware of all of our environments. Generally, or at least we used to, have push button deploys to dev, staging, and production. Again, the coupling is leaking all the way down here. However, with GitOps, that changes. What we're now enforcing through, what good habits we're now enforcing is that, well, yeah, our CI is aware of a Git repository, is going to build an artifact, which is an image, which we can publish somewhere. And our continuous integration stage stops there. And then we have this other process. We have an operator that lives inside of our environment that knows how to work with those artifacts, that knows how to deploy them. And yes, it does link back to Git, but we do have a very explicit boundary here. The boundary is that we no longer have our CI system aware of all of our environments. We have a single image that can run across all of these environments. And this is a really, really strong benefit for GitOps. Now, I want to talk about this multi-environment thing because it's actually it's actually kind of painful, or at least a lot of people struggle with this. And in fact, on the FluxCD repo, this issue dates nearly 2.5 years, maybe a little bit older now. It's got 53 thumbs up. It's clear to me that as people are adopting GitOps, they want to understand, how do I do it in a multi-environment capacity? And just to remove any ambiguity here, when I talk about multi-environment, this is what I'm talking about. I'm talking about control flow from dev to production with whatever semantics and flow you have in between, staging, performance, QA, etc. Right? All these environments are different and unique, and every company does it. Now back to this issue then. To being 2.5 years, this issue is actually still open. Now, 3 weeks after this issue, someone from Weaveworks themselves actually posted a link to what they were saying would be the home for a definitive or de facto implementation of how Weaveworks suggests that multi-environment GitOps should function. Unfortunately, this repository doesn't have a lot going in it. It hasn't been updated in 3 years. And even though there's just a license and a README, it actually has a failing build. So there's not a lot here for us to understand how Weaveworks intended us to provide the multi-environment GitOps. And this issue is still open today, as I said, and it's still receiving comments. Right? This screenshot I think I took last week sometime. The last comment was 2 weeks before that. There's still a lot of people doing the GitOps journey, not really sure how to handle this problem. So I want to break it down into the 3 ways that we have of doing, at least 3 ways that I see are common of handling multi-environment GitOps. The first one I list here is directory-based. That means I have a repository, and in that branch, whatever it's called, there are directories for each environment that we have, staging, dev, and production. Other approaches may use branches as an environment. So we'd have a branch called dev, staging, and production. And then there's one that's not really as popular, but what if I just have a repository for each environment? And I want to talk about the repository one first because it is the one that I see less frequently. But it does have one really strong benefit, and that we have this great, strong authentication boundary that if you don't have permissions to even see the production repository, you cannot affect or cause problems in a production environment. However, the biggest con to this and why people aren't adopting this approach is that we have manifest hell and drift. In order to propagate changes from one repository or environment to another repository or environment, very manual, very labor intensive. So yeah, maybe not the best approach, but there are environments where that would be a really good one, right? I can think of financial sectors, places with high auditability. You may want to go down that route. And then there's the next lesser frequently one, interesting word choice there, but branch-based, right? Now this, we still have some authentication, we still have some boundaries, and that we can restrict who can push to certain branches. It can potentially enable promotion through pull request, but as we'll see, there are a lot of challenges using that too. And because of those challenges of enabling promotion through pull request, we actually end up in the same situation of having manifest hell and drift, and that we don't enable ourselves to do promotion for pull requests, which means we do have very specific changes in each branch, which means we do still have to make very labor intensive and manual copy and paste to our new environments. And then there's a directory approach. This is the one that all of our existing tooling supports. We can do promotion for pull requests because it all exists in the same branch. So it's relatively easy to make changes to one overlay or the other. But we then have no boundaries. We then have no protections, except for maybe, okay, a certain group within GitHub cannot push to the branch or requires a certain number of approvals. That's maybe okay. Again, it depends on what your environment requires. So which one do we choose? Directory approach is what everyone is doing. And by everyone, I mean Kustomize makes it very clear that this overlay approach is what they recommend. Organizations like JetStack talk about using Kustomize in this exact fashion as well. We have Helm providing value files depending on your environment, very similar to an overlay. Helm file then augments that further by also providing environments as a hard-coded YAML artifact that allows us to do overlays or specific configuration. And it's not just those original or older tools. Newer tools coming into this space are also adopting this model. Tools like Katie are now also saying, hey, you should have environments laid out as directories inside of your Git repository. And then you compile some generation or a YAML that tells you what our environment looks like. So let's try and apply the law of Demeter to this. What does that mean? How is this a good approach to take? So the first thing I want to kind of portray here is that when we talk about overlays, we're saying this is inheritance. If you've written any object-oriented code, then this is classic inheritance. We have some base description, some base class. We provide the ability to extend that class. And depending on your background, you may see a warning sign there saying, oh, if you've only ever done object-oriented programming, maybe it's what you're familiar with, and that makes really good sense. But me, as a functional programmer, it makes me a little bit worried. It makes me a little bit of concern. And that's because we have this coupling. What we're saying here is that by using directories as a way to explain or explicitly define a new environment, we have this two-step process. If I want to deploy a new environment, I have to commit something to my Git repository with a new directory, tweak it with the values or overlays that I require, and then push that up. Now that can be good or bad. Again, that depends on your use case and how you're applying or approaching this situation, but that may be a really good selling point. But for me, I have some concerns. And what I also want us to understand is that not all environments are created equal. Now, you may want auditability on your production branch, maybe on staging, but as the priority of those environments decreases, or the frequency in which we deploy new environments increases, that's a decision that we have to make. So what I want us to understand is when we do multi-environment GitOps, we have to distinguish and we have to first acknowledge and identify concrete environments versus ephemeral environments. And I know I don't like being the it depends person, but the way that we approach our GitOps depends on how we wish to treat these concrete and ephemeral environments. Now, production, of course, is a concrete environment. However, do you only have one production? Now, I know that's a question where a lot of people are going to say yes, but your production environment could be multi-region. It could be multi-cloud. There could be more than one production that we mesh together in certain fashions. And what we want to do with our GitOps here is make sure that we only ever target the Kubernetes API, not the cloud provider, not the regions, not the third-party services. And depending on how you've approached this in the past, what I want us to take away here is that the way that we provision and deploy new environments is completely isolated and separate from the applications that we deploy to those environments. We don't want any leaky abstractions. We don't want any coupling that is going to affect the way that we do that. Now, of course, you can still GitOps your environment provisioning, right? As long as we keep them separate. So let's talk about some actionable tips that allow us to not break the coupling, or at least not introduce coupling that we don't explicitly want. Now, the first one I have to say is just really be cautious with the examples that we see online. I know from experience of speaking with people, that they go down this directory approach to GitOps because there's just so many examples of it online. Now, I was doing research in preparation of this talk and looking at all of these examples, and I can tell you they're all trivial, extremely contrived. The customized example is this. The only overlay modification it makes for the production is a name prefix. Now, there are use cases for doing overlays in this approach, but we need to identify them first. They have to cause us problems before we adopt the directory approach. So really be careful there. We also have to understand the variance and invariance in our applications, right? And anything that is going to be unique or has to change across our environments should be deployed with the environment provisioning. A really common thing we see, and there are talks on this, there are blog posts on this, is using things like sealed secrets and SOPs to store secrets in our GitOps environments. Now, I'm not going to tell you that storing secrets in your GitOps environments is wrong or bad, because there are use cases for it. But we need to understand that we only store the secrets that are ubiquitous across all environments as part of our application GitOps. And anything that changes with the environment should live with the environment provisioning. The environment provisioning should provide an environment that we can infer and adopt and look up these values. And I don't see enough of this either, right? The things that can be randomly generated within the environment should and must be randomly generated. That means when we store random strings to encryption salts and keys in ephemeral environments, we can generate them at application deploy time. And there are a few projects out there. I'm just going to highlight one here, but the Kubernetes secret generator is a really good approach for this. You can see the manifest here is nice and simple. We add an annotation that says add a new field to the secret, and it's going to be a password. There are other ways to customize it, size, length, character classes, etc. Now, this is where some people may get a little bit, whoa. Do not use the replicas field in your deployments, right? And what I want us to really do is that is, again, all the examples that show us how to do overlay-based GitOps. Replicas is the thing. And dev, I only want 1 or 2. And production, I want 100 million of them. Well, we actually want the application to function the same regardless of environment. So let's just always use a horizontal pod autoscaler. We can set the minimum that our application needs to function and a max that we need for our production environment. And then we trust the scaling within our application, even in dev, staging, and production, just to do its thing. And that should just become the norm. We shouldn't replica override per environment. And another maybe controversial point is I really feel that we have to limit auto commits by machines because of the amount of problems those cause. And those have been mentioned a few times now. For concrete environments, yeah, definitely. Maybe there is a great use case for auditability purposes, but do you really need it? And identify that first before just going with the status quo and saying, I am going to commit all of the image resolutions that happen in my cluster back to Git. There is, and maybe another way to handle that. So just identify if you need that for your concrete environments. I also want to give a shout out to Capitan by the DeepMind project, because they're one of the few tools that I've seen that doesn't promote overlays by default. As a functional programmer, I really like it and drawn to it because they offer composition techniques through aliases and targets and other things. So definitely check that out if you're looking for a new way to declare your application manifests. And what does all these actionable tips, what does this all enable? Well, it pushes us on the path to have branch-based GitOps, where we have concrete environments in green, dev, staging, and production. We have ephemeral environments in yellow. Every time we work on a new feature, we can spin up an ephemeral environment. Every time we have a PR to staging, we can have an ephemeral environment. And we use our concrete environments as a basis for building those. Now back to this example, there was actually really good content in this repository. It was just hidden. And it's a shame that it hasn't been updated because I feel that Weaveworks were trying to approach this path initially and maybe just got led down the wrong path through examples of customizing other tooling. But this repository, okay, I just 10 seconds to finish. So we can use, yes. So we've got environments here and we can use the branches, development and staging. And this enables us to have no overlays and allows us to have explicit concrete environments and limited read-only ephemeral environments. And we still have environment parity, we still have branch protections, and we still have promotions with PR. Oh, wrong way. Thank you very much. That was my talk.
Thank you so much, David. Since we're a bit short on time, I just wanted to go directly to introduce Somtochi Onekwere. She's going to talk about tool-assisted RBAC for operators. Welcome, Somtochi.
Thank you. Thank you, Bianca. Hello, everyone. Um, my name is Onyekore Somtochi, and I'm here to talk to you about tool assisted RBAC. Um, I'm going to start by a little intro and thanking the WeaveWorks team for, inviting me to talk, giving me this opportunity to talk about something I've worked on. I'm really grateful. My name is Onyekwe Samtochi, and earlier this year I was a Google Summer of Code intern with Kubernetes, and I'm a contributor to Kubernetes too. You can find me on Twitter and GitHub at Somtochi Ama. So today I'll be talking about tool assisted RBAC for operators. So RBAC is role-based access control, and if operators aren't given enough RBAC, they become kind of cranky and start spitting out errors. So we are basically going to talk about around tools that help tools that help you manage the RBAC for these operators. So first, I'm just going to go over what RBAC is. RBAC is one of the ways that in Kubernetes that you can control who can do what with which resources in a cluster. So we are going to break that down a little further. So the who talks about users, groups, service accounts that interact with the cluster, and what is basically various kubectl commands that like kubectl apply. For you to create pods, create deployments, which are the resources, you have to have enough permissions. And role-based access control, RBAC, is one of the ways that you could give these permissions. It's pretty flexible, it's granular, and it maps easily to resources and operations that you can perform in the cluster. So you say kubectl delete, and you know that you should give the operator or user or group. Service accounts are for applications and operators that run on your cluster. Users or groups are people that interact with the cluster. So whoever it is or whatever it is that wants to perform an action on the cluster has to have enough permissions. So the four objects on RBAC that are associated for Kubernetes that are associated with RBAC are the cluster role bindings, the cluster roles, the role binding, and the role. The cluster role binding and the role do the same thing, but the cluster is for at the cluster level. It's cluster scoped. It applies to the whole cluster, while a role binding applies to a particular namespace. So when you apply a role, it's applied to a particular namespace, or it just uses the default namespace for the cluster. But for the role binding, you don't need to specify a namespace. For the cluster role binding, you don't need to specify a namespace because it applies to the whole cluster. The same thing goes for cluster roles and roles. Cluster roles are roles that apply to the whole cluster, while the role just applies within a particular namespace. So we are going to look at what the YAML for these objects look like. So the first one here is a role, and the second one is a role binding. So the role, for the role, you have to specify the API groups, the resource, and then verbs. This is the API groups and resource define the resource that you want to give access to, and the verbs define what you can do with this resource. So here just says this role contains permission for getting, watching, and listing pods. And then if we move over to the role binding, the role, as the name implies, the role binding, as the name implies, binds a role to a user. It could be a group, it could be a service account. It binds the role to the what, like who can do what, with whoever it binds to can basically carry out whatever permissions that the role contains. So here it's binding to the user Jane. It's binding the role, this role that we just went over, to a user called Jane. So it basically means that Jane is going to be able to watch, list, and get pods in the cluster. So in summary, this role gives whoever is binded to the access to read pods. That's a pod reader role. Then here we are binding it to Jane. So Jane has permissions for reading pods. So we have a bunch of predefined roles in the cluster. These are roles that sort of Kubernetes pre-creates so that it's sort of easy. There are common roles that you sort of need to get started. We have the cluster admin, and these are privileged roles. The cluster admin is sort of superior to the admin in that it can create and edit namespaces, resource quotas, and some few resources. But mostly the admin can create, delete, a lot of resources apart from namespaces and resource quota. So that's basically where it differs. The cluster admin is obviously a bigger role. Then you have the edit permissions too, and then the view permissions. These are just very scoped. These are scoped roles. The view permissions allows you to only view resources on the cluster, while edit allows you to, edit them, make changes to them and stuff like that. There are also a bunch of other ones. These aren't the only list of predefined rules in the cluster. So now we are going to go over how role-based access control ties into GitOps. So normally when you're using GitOps, there's usually a controller that runs in the cluster. It's probably this controller that pulls and applies your changes and or reconciles the actual states, to your desired states that is stored somewhere. And for the controller to successfully apply this manifest, it needs to have the permissions to create all the objects in that in the manifest that it wants to apply. For it to reconcile, probably it has to get the resources to check their state. It needs to have the permissions to get these resources. And oh, okay. Um, so for an operator to apply a cluster rule, um, it needs to have a superset of the roles of the rules that the rule contains. Let me sort of go back to what we've done. So for an operator to apply the rule that we have here, it needs to not only be able to create rules in the cluster, but also it should have the permissions to also get, watch, and list pods. So it not only needs to be able to create the rules, but it needs to also have permissions to each rule that is contained within the rule it wants to apply. So yeah, so obviously it entails a lot of permissions. So most operators now they use a default role, cluster admin role, which it allows the operator to do a lot, but it's not exactly least privilege. Like, could we make that better? Could we make the cluster more secure by giving the operators only permissions to what they need to do? So basically giving the operators that work in our cluster more granular permission, more defined permissions. Yeah, so the problem that sometimes arises with giving granular RBAC is when these permissions are not enough, the operator, can't do his work correctly. It starts to spit out errors like, oh, I'm forbidden from creating this resource, and its work is basically becomes incomplete at that point. It can't function. It becomes like a bottleneck. So that's also something else. So it has to be the exact amount. If you give it too small permissions, then it can't perform its functions very well. So it basically now becomes a manual process of looking through the manifest, looking at each resource that a manifest contains, and then updating a corresponding role for the operator. And anytime that manifest changes, the role too has to change, else the operator will not be able to apply the new changes. Anytime you add an extra resource to the manifest, maybe you had just a deployment before, but now you've added a service. the role also has to be updated from permissions for not just deployments, but the permissions for applying and creating a service also has to be added. So it becomes this manual process. And is a problem I faced when creating operators during my internship with Kubernetes, and start thinking of ways to overcome this problem and make the whole process better. So I developed a simple tool called Outback Gen. It's used to automate the generation of roles and role bindings for manifest. It simply scans the manifest for the various resources in it, and then it adds the role to them. And then if it comes across a cluster role, it adds the rules, as we specified before. For it to apply a role, the operator needs to have permissions to everything that the role is doing. So it also does that for you. It adds the roles to the rule of the operators, and it provides, efficient and well-defined permissions for the operator. It's something that could make the whole process of generating RBAC for operators automated. It could remove the human elements and reduce errors in the process for creating RBAC. So there's also something we could go a step further and further reduce the amount of permissions that an operator needs on the cluster. So you could pre-apply the cluster roles and roles yourself as a higher privileged person on the cluster. So the operator no longer requires the additional rules that the cluster role was supposed to give. It sort of reduces the amount of permissions and rules that the role of the operator is supposed to contain. And RBAC too can help with this by passing a flag into the tool. It sort of skips the rules of the cluster role. It doesn't add it to the role of the corporate operator. So if you still wanted to go this route of further reducing the permissions of the operator, the RBAC tool can also help with this. So I'm just going to do a quick demo of what the tool looks like and using it. So I'm just going to share my screen again to a terminal. So this is going to be a very quick and short demo. It's simply getting the manifest of Flannel, which is a CNI for Kubernetes, and then it basically tries to generate the RBAC for the manifest. So first, so here we see the manifest that we probably want to get a role for. We want to give a role to an operator so it can apply this manifest. So we can see here that it contains, so for an operator to successfully apply this, it needs to have, the rule to create the pod security policy, the cluster role. And it doesn't just need all this, but it also needs each of these rules within the cluster role. This is a cluster role. It needs to also have access to create a cluster binding. So you get the idea. You basically step through each object in the manifest and then generate a role for it. So we can really simplify this by just using the RBAC Gen tool. I already have it installed on my machine. So now the role has been created. It's basically the generated role for the operator. We can see that it adds the rules for the pod security permissions and all that. But also, it also adds, we can also see that it adds all the rules in the cluster role that the operator needs to apply, because that gives the operator sufficient permissions to apply the manifest. We can see it's getting the pods, it needs to list and watch nodes, it needs to patch the node status. So it's basically took out all this and put it in the operator rules for you. So if you also wanted to, you wanted to pre-apply the cluster rule, you don't want the operator to have these additional permissions that it might not need, you could simply pass in a supervisory role We could use another rows YAML so that we can see the difference. So yeah, we can see now that we know it no longer has the permissions for creating pods, just each resource that is in the manifest. Yeah, so I'm just going to quickly summarize now. Oh, um, sorry, let me reshare, let me resume sharing the. So in summary, RBAC is a way of, oh, okay, sorry. Can you see my slide now? Okay, so I'm just going to give a quick summary now. The RBAC is a way to control access to your cluster. It has four major objects that you can use to define RBAC, which is the cluster role binding, the role binding, and the role. The cluster role and role binding as cluster-wide resources, they apply to the whole cluster, while the role and the role bindings are namespace scoped. And RBAC relates into GitOps because the controllers that that apply the changes reside in the cluster, and they require permissions to be able to successfully apply the changes. And RBAC generator is a tool that you could use to generate granular permissions for these operators so that you don't give it the whole permissions like a cluster admin, and yet it still has sufficient permissions to, function correctly. Thank you for listening to me on this talk. I still want to thank the Reef team, especially Tamo and Stacy. You can find me on Twitter and GitHub at Somtochi Amar. Thank you.
Thank you so much, Somtochi. Now we wanted to open it up, if you stay on, for questions from you and David Mackay together. So if people could post questions in the Slack, who's moderating? Paul Fremantle from Weaver.
I'm moderating. I've lost my background. Isn't that terrible?
No.
I'm sorry about that. I've no longer got a GitOps background. I don't know what happened to that. Apologize.
Well, you've got it in spirit.
In spirit, I'm definitely part of GitOps Days 2020 EMEA, yes. So firstly, I would just want to reiterate my thanks. I thought those were two very thought-provoking talks, and I really enjoyed both of them. And I kind of I have a question that I think comes more from David's talk than Somtochi, but Somtochi, you may have some thoughts on this too. I one of the things that I've heard discussed a lot with GitOps is two approaches, a kind of pull versus push approach. And I definitely thought that there was a strong significance of the law of Demeter to that discussion. So I just wondered, David, do you have thoughts about pull versus push in GitOps, and what are they?
Yeah, definitely. I mean, the pull and push is, an argument that we have in various technology things, right? Metrics is one, GitOps is another, and it all boils down to the same thing. It's coupling. Whenever we wish to push something somewhere, both things essentially really need to have knowledge that each other exists. So the pull approach is the one, and this is why Prometheus is so prominently in favor of the pull approach, is that you don't need to bake your applications with the knowledge of where to push those metrics to. And instead, we flip the knowledge and the responsibility to the other sides. I think that pull-based systems reduce our coupling and make things generally much more flexible. But it's definitely a trade-off depending on your environment for sure.
Somtochi, have you got any thoughts on that question?
No. Thank you.
Okay. I kind of, yeah, I do think, I mean, one of the things that I noticed with my experience with Prometheus and this is that it did take a mind shift to shift from that kind of pull-based approach to the push, from push-based approach to pull-based approach. And I do think that some people are going through that. It's also similar in my mind to that kind of mind shift that goes on from very synchronous view of the world to a much more asynchronous view of the world. So I have another question, which is, and by the way, I should remind people, if anyone does have a question for these great speakers, please pop it into the GitOps Days Slack channel, which I am monitoring. And if there's a good question, I will feed it straight to them. So you both talked about access control, and David, you talked very much about access control in Git, and Somtochi, you talked very much about access control in Kubernetes. I'm really interested in how those play out and how you might think about the whole of those across the divide and try and get that straight in my head, how those two things interact. Let me go first to Somtochi. Have you got some thoughts about how the role-based access control in Kubernetes fits with the permissions in Git?
Yeah, I think access control has a lot to do with security, and security is something that has to be applied at every step of the way. So whatever it is, the pipeline, Git, the cluster itself, the application, every single level has to have some kind of access control based on who needs to access what, and that's basically how it ties in. It ties into the whole security of your application and your deployment as a whole. I think that's how it ties. Each of them is like under the rung of a rung in the ladder of security. Basically, each step strengthens the security of whatever you're deploying. It prevents unwanted access from whoever it is. So yeah, I think if you ignore one and just do the other, it's not complete. It could create holes in whatever you're trying to do in the security of your application. So I think taking care of each of them, having it in mind that each of these things are important and taking care of each of them is important. Thank you.
Thanks, Somtochi. Very useful. David, over to you.
Yeah, so it's definitely tricky, right? It's like security key authentication. It's one of those things that I'm always going to make the assumption that I'm going to get it wrong. So I've always just applied this blanket rule of zero trust to all of my infrastructure. In fact, anyone that's worked on a production system with me over the last kind of 15 years will right away tell you that I am a terrible person because I wouldn't let them SSH onto their hardware. So, and I think that's, if we can, I like to adopt that as a blanket approach first. Like, it doesn't mean you can't SSH on, but by default, there's no access. And I generally build fail-safe systems through a controller, very much like GitOps, usually salt stack running on the machine, that I can send a message to and tell it to enable SSH for 1 hour. And that only works if you give it a message to say why you need SSH access. And I kind of take a very similar approach to Kubernetes, especially because GitOps is an enabler here. And that if we identify the reasons that someone may need access to a Kubernetes cluster, they're either because A, my monitoring and logging is not centralized and they don't have access to get logs from pods, they don't have access to debug problems in production. So we need to make sure we are along this journey that we have all that information leaving our cluster. The second reason they may need access to the Kubernetes cluster is they want to make changes. Well, why do they want to make changes, and why is that not going through our GitOps reconciliation? Like, why? And again, there are reasons, but I think by default, I generally prefer to see there's no access and then have something available to permit access. And that just may be a special branch in your GitOps repository that applies an RBAC rule that gives people ability to enter that cluster for 1 hour and then disappears. Like, I'm not sure how that works yet specifically, but I would say just not give people access and try and work out why they need it and get that stuff out the machine or into the machine through other channels. So kind of opinionated approach to security.
I like that approach a lot. I think that's really interesting. I guess one of the things that kind of, and you both made this point of kind of, you have to apply maximal security everywhere and zero trust, which I think is absolutely key. I guess I'm still want to dig in a little further. So if I'm building a permissions model, am I building that fundamentally in Git first, and then the Kubernetes is permissions are really subsidiary to that? And that's really, I guess, what you were kind of implying, David, by talking about saying, well, directory structures don't work, branches do. Or am I sort of using both of them equally to enforce my permissions, I guess, is what I'm trying to get at here.
Yeah, so when we are using GitOps, and say we are adopting a zero trust policy by default, and that the developers don't have access to kube control apply anything, then their only model of modifying that cluster is through Git. And we have the ability through GitHub and GitLab to have teams and organizations and branch permissions, and those are our defaults. Those are where we secure first. And then I think, when we have identified use cases or break glass scenarios that people do need access to the Kubernetes cluster, is when we start to layer in the RBAC models and other security policies there. But I definitely think we start with Git, we trust the automation, and then we provide edge cases rather than, going the other way by default.
Very cool. Somtochi, did you have anything else that this discussion is?
Yeah, I think it's security is something that people don't think can be applied declaratively, like storing, all those policies and stuff in the cluster. But it can, and that's also why it ties into who has permissions to do what on your Git repository. So it all connects, right? So whoever can, has access to your Git repository can probably create the RBAC to do something else on your cluster. And, the controller would apply it and stuff like that. So yeah, I think everything just connects that way, that you can definitely manage security declaratively. It's something that is a bit coming up, and I think it's difficult, but it can be done. But then it also solidifies the idea that your Git repository has to also be secure, because whoever has access can make those changes, security or otherwise.
Very cool. I guess one of the really interesting aspects here is the sort of audit and visibility. I think one of the things that your work, Somtochi, shows is that if you have if you have the permissions and configuration stored in YAML, there's a kind of an analyzable aspect of that. The Git branch and repository access is obviously really cool and useful. I guess you do get the audit log from the pull requests, but I'm not, I guess there's some dependence then on whether you're using GitHub, GitLab, Bitbucket, or what particular system you're using to manage the permissions of access to the repo.
Sorry, I didn't get the last.
I'm just freestyling, guys. That wasn't really a question. Sorry, I just was thinking aloud there. Apologies. So I do have a question from Slack, and it's quite a long question. So you'll have to give me a moment to read it out. It comes from Error Developer, aka Ilya. And by the way, if anyone else has questions who's listening, please type them in. It says, and this is to you, David. With regards to config as code in GitOps, I'd imagine using JavaScript, Python, or another general purpose language of the Reach ecosystem would provide answers to most concerns you'd raised. I'd say that GitOps config repos might still contain flat YAML data, but the operator's developer would interact with a high-level code that generates the configs and repo branch directories as an implementation detail. What do you think?
Yes. I think, I mean, yeah, definitely agree. I think, we have this YAML approach and we're doing the best we can right now. I think we're all suffering from, very much YAML fatigue to a certain degree. And then trying to manipulate, augment, and work with the YAML in a way, we're already noticing the boundaries of where we can actually get with that. And there is a whole wealth of tooling that is starting to come out of the ecosystem and the communities now that are trying to provide alternative template and approaches that do favor composability and extension with better models. Helm 3, I was hoping, we're going to get the Lua scripting. It never really came to fruition, and we're still working with Go templates within YAML. But there are other tools like Capitan, there's Pulumi, there is YTT in the Carvel project. So in fact, even JSON or JSONette, depending on how you want to pronounce that, there are these alternatives that are giving us a little bit more of a dynamic, programmable way of declaring our infrastructure, our applications. And I'm a big advocate for Pulumi. I think I speak enough on Twitter about how I'm using Pulumi to generate. There's a really cool project coming out of the Pulumi team actually, called CRD to Pulumi, where you pass it the CRD definitions from your cluster and it generates static types and TypeScript and Go and Python that allows you to interact, describe, and work with those types in a really great fashion that gives you validation and assertions before you push that code up to your Git repository. Of course, when you go that approach, you have to rely on not using any GitOps tools yet in the cluster because they don't know how to compile those assets down to the YAML-based manifest. So we've still got a little bit of a gap that using some of those tools relies on a push-based model. But I'm hoping the tooling is going to come around to support GitOps working with those tools as well over time.
Have you looked at CDK8S at all?
I have not played with the CDK, no.
Okay. So that also does have some ability to import CRDs. It's not, it was a while I last looked at it, maybe 3 or 4 months ago, and it wasn't perfect, but it was a really good start. And that generates the YAMLs that you can then reason with and manage in a pull-based environment. So that might be another project that might be interesting from that point of view.
Yeah, definitely. I think there's going to be a lot of evolution over the next, hopefully over the next 12 months in this space. I know the Pulumi team are working on operators that will run in the cluster that can, continually process and apply Pulumi code. The CDK stuff is obviously exciting. I think we're realizing now that we need to start embracing our infrastructure as code in code and not just a DSL that covers a small subset of what we actually need to declaratively define our applications and environments.
I did think that maybe Ilya was a developer with his question was slightly questioning. Maybe you didn't get this, but I think his view was that whether it's a repo, a branch, or a directory doesn't matter because you have a build process that creates the right structure and so it's the build process that's repeatable, which I'm not sure you completely agree with. So you kind of said yes, but I don't really believe you meant yes.
Okay, no. So if maybe I'll read the question again later, and I'll come back to them. But my thoughts on that, based on what you've kind of followed up with, if we're relying on these languages to produce YAML that produces an application for an environment, that's really good. We still need a branch-based or a directory-based model for each individual environment too, from a point of view that we still want to be able to promote and work with the YAML that is produced across environments. For example, if we add a new deployment, we want to be able to do that in a staging branch and then test it. And then when we're happy with that, we promote that through to production. But we still want that declarative definition YAML to be the same regardless of the environment. And we want to use the environment and infer the different properties from the environment itself, rather than having the coupling from the application side that's trying to be aware of the environment and going, oh, I'm in production, I'm going to scale faster. Well, the environment should provide these semantics, and we declare them in the environment provisioning step. So, the environments are the snowflakes. The applications should be ubiquitous across them. That's kind of the goal that I'm trying to enable.
Very cool. Right, we've just got time for one last little question, and I'm just really interested. We get such great expertise on. Is there anything you think is coming next that you're really interested in, the future of GitOps, or some project that's upcoming that you'd really like to give a shout out to, or something that is exciting you? So I'll start with you, David, since you've got your mic on, and then I'll come to Somtochi.
Yeah, I mentioned the Capitan project. I really love their approach to composability to declare our manifests. I'm keeping a very keen eye on that. And I've been a very early adopter of the GitOps toolkit. So, I also want to just give a shout out to Stefan and say great work. I'm really enjoying kicking the tires on that and excited to see what comes down the line.
Brilliant. Thank you, David. some touchy.
Yeah, David took it out of my mouth. Maybe the GitOps toolkit. I think it's exciting. I think it lays the groundwork for some other work on top of it. By separating into various controllers. I think it lays ground for other people who might have different use cases than what the builders thought about to sort of take all those pieces and create something else. Yeah, I think that's also what I'm excited about. There's also this cluster API provider nested, sort of like sort of a cube builder declarative pattern way of building operators. I think people should check it out. It's fairly new, but I think it introduces some interesting ideas.
Brilliant. Thank you both. That was a really interesting conversation. And once again, fantastic sessions. And thank you so much for all your help and effort on this.
Yes, thank you all. We're going to be taking an instrumental break right now for 15 minutes. And then we're going to come back with Scott, Kishore, and Mahmoud for a case study with Fidelity. So I'll be excited to have you guys back. Thanks again. All right.
Deixa girar, girar. Oh, gira, deixa girar, girar. Oh, gira, deixa girar, girar. Oh, gira, deixa girar, girar.
Thank you, DJ Desired State. You're killing it. Uh, so now we've got a bigger session, a case study with Fidelity Investments coming up. Scott Rigby, Kishore Goduguluri, and Mahmoud Sada, they're going to talk about Helm 2 deprecation and what it means for you. And this is going to be followed by a session with just Scott about Flux 2 for Helm users. So welcome, Scott, Kishore, Mahmoud.
Thanks. Thanks, Bianca. Okay, well, let me go ahead and quickly introduce Helm 2 deprecation and what it means for you. One moment. So can you hear me okay? Okay, awesome. Awesome. Yeah, so just a very quick rundown before we go into the case study with Kishore and Mahmoud. Just going to give you a brief description of the Helm 2 deprecation timeline. The charts repo deprecation step by step. I'll only review the steps briefly. You can actually look at the documentation and the links that I have in the end for further detail. Just note the distributed charts repo initiative that's continuing. And for those who are wondering, what am I going to do now that the charts, the central charts repo are gone, I'm going to just mention briefly about how charts are discoverable still with Artifact Hub from CNCF. So here's a really funny, or not funny, but cute little poem that someone wrote from the Jabberwocky, but essentially the time has come, the maintainer said, to talk of software fates, of upgrades and shipping Helm v3, of bug fixes and Kates. It's you may have seen this around because there's been a big deal about Helm 2 going away. And today is the day, actually, the 13th, Friday the 13th. So the things that you need to know for users just simply are that there are no Helm v2 releases at all, no security patches whatsoever as of today. The Helm 2 documentation will also not have any further updates. It will be available for a time period, but it will not necessarily last forever because this is now end of life. All issues and PRs are going to be closed. We're transitioning the releases of Helm, the ownership to CNCF, and the actual central charts repo has been transitioned to GitHub pages. I completed that last week, and it's been running perfectly. The main things to know are that this is really just for Helm 2 people. So if you really don't care about Helm 2, just plug your ears for a second, it's fine. Basically, if you need to download the client, the Google Cloud Storage is removed, and now we've got get.helm.sh. Again, you'll be able to see this later. You don't have to write this down now. Docker images for Tiller from Google Container Registry, those have all been moved to GitHub's container registry. And the Google Cloud buckets for the central chart repos, the stable and incubator, have now been moved to GitHub pages, and they're now in specific URLs, and it's on the Helm blog. And I've got some more information about that if you need it later. Okay, so the main point that you may have noticed I'm trying to impress upon you is it really is time to upgrade to Helm 3 if you can. At least consider it, because there are many reasons to do so now. So there's a link here for Helm 2 to 3 migration in general, and then Kishore and Mahmoud are going to cover the Flux migration. Just a few more quick points before they do. The charts repo deprecation, you can really just kind of read this later. There are recommended actions for specific dates. The most important one is you'll notice that as of later today, if you try to use the old charts repo URLs, they will no longer work. If you have the updated Helm client, both 2 and 3, you'll get a warning about this, and there will be information showing you output telling you where to go next. So the repo locations have changed. I'm just going to glance over this for now because it's available elsewhere, including on the Helm blog. The one thing I want to note is that not all of the charts in the central charts repo do have new homes yet. The adoption process by other organizations whether they're the official organizations, the maintainers that of those applications that those charts install, or whether it's a separate organization like, say, JFrog, Bitnami, or say just your own personal chart maintainership. You can do this, and we've got tools to help this. I'm not going to go over them all now, but essentially we've got tools for testing charts and for releasing charts. If you want to do it all on GitHub, it's fairly straightforward. So there's an excellent write-up at the end here. These slides will be made available, but to show you how to continue to maintain Git history when you move those charts over, so that you can have some real continuity there into the new location. And there's an issue that I started about a year ago, which is showing the progress of this initiative. So please join us and feel free to ping me on Slack. And otherwise, if you have any questions. One more note is, well, where are they going, or how can I find them? Well, CNCF started this project called Artifact Hub, which is a central hub for OLM operators, Falco rules, Helm charts, and other cloud native artifacts or packages. And this is something you can publish to, and something as an end user you can look to find where those distributed charts actually live now and how to install them. So check these slides later for the references, because there are a lot of them. The Helm 2 deprecation was kind of a big deal, so this is a very quick breeze over, but it's been covered in depth elsewhere. So I'm going to move on now to Mahmood and Kishore for their case study.
Thank you, Scott. I just wanted to say, DJ Desired State's really good.
Yeah,
really killing it today. So now Kishore and myself will be talking about the case study at Fidelity Investments. So Kishore, if you're there, if you can enable your video and your screen share. Let me check. Let me make sure Kishore is still with us. Let me try to, I guess I could share my screen. Oh, he's here? Okay. Let me turn off my share then. Hey, Kishore.
Hey.
How are you doing?
Hey, Mahmood. Hey, I'm good. Thanks. How are you?
Doing well, doing well. Are you excited?
Good. Thank you. Yeah.
To start today?
Cool.
Yeah, let's do it.
Yeah. So let me start sharing the screen. Yeah. Okay, cool. So do you all see my screen?
Yeah, looks great.
Yep. Cool. Thank you. So hi, folks, everybody. Welcome to our talk, GitOps case study with Fidelity Investments. I am Kishore. I'm a cloud technologist at Fidelity, and my co-host, Mahmood, a cloud reliability engineer at Weaveworks. So today we're going to talk about how Fidelity started adopting GitOps, and then how we are doing it today, and our story of how we done the Helm 2 migration, as you've heard, the deprecation, and some internal knowledge about how we are doing the add-ons management with Helm operator, and how we are going to do the GitOps with Flux 2 in future. So let's get started.
Hey, Kishore, before we get started, can you kind of briefly describe what Fidelity is to the audience?
Yeah, sure, definitely. So yeah, like you might not all be aware of Fidelity. So Fidelity is one of the largest asset management company. We have about 3.3 trillion under assets under management. We do brokerage services, and we have retirement services, like a lot of other financial services, cryptocurrency. So it's sort of like a bank, to put it. And everything that Fidelity does is quite sensitive, and it's monitored and audited like all other financial organizations. And each of these services, right, like I mentioned, brokerage firm, mutual funds, index funds, they all have their own business units inside Fidelity, and they are sort of like their own companies inside Fidelity. So it's sort of like it's like a parent company, and like for a lot of other companies inside Fidelity. And just to give the scale of the business units, right? One of our largest business unit has like about 10,000 associates in it. So that's the scale of business units. And yeah. Uh, so our how we started adopting GitOps, right? We started our Kubernetes journey about like 2 years ago from now, and we knew that it's going to be a big thing at Fidelity, and we are going to have like hundreds of clusters to manage at Fidelity. And we have been fortunate enough to be able to choose GitOps since the beginning, with the scale of the number of clusters and having to maintain the state of the clusters to a desired source of truth, from a desired source of truth. And to do all that, GitOps is the solution, and that's the reason why we have adopted GitOps. And how we are doing it is basically we release a platform version of Fidelity Kubernetes platform. Let's say it's 118 1.1.0 with a bunch of additional components added on top of Kubernetes, which will offer functionalities that are specific to Fidelity, and some other general features as well. And we create a version out of these additional components along with Kubernetes. So we call that platform specific. So if it's a EKS version, then we say like 1.18.18 feed EKS 1.0.0, which will be composed of multiple other components with specific versions pinned to them. And that's how we distribute the software to the BU cluster owners. And they have the flexibility to choose and upgrade their clusters to their specific version whenever they want. And each cluster will have its own Git repo behind the scenes, right? So here is like a glimpse of like how the pipeline looks like. The upper circle represents the platform version that we are releasing, which is pinned to a version in Git, and has all the additional components also pinned to a particular version, and that is distributed to the BUs as a platform version. And the BUs, when they want to pick a new version of a platform, they interact with our CI/CD pipeline, which will offer them to the possible versions that they can go to from their current version, and that will let them choose some additional configurations, such as the size of the cluster, any tagging for resources, etc. Like not changing anything on the platform, but just the configuration part of it. And they can choose the configuration and push the configuration to a Git repo, and that's where the full cluster reconciliation will start. So this is sort of like both push and pull model. Push is sort of triggered by the BU cluster owner by picking the platform version and then the configuration into Git repo. And then we have the components inside the cluster watching for the Git repo and pulling the changes applied to the cluster one by one. The add-ons or these additional components that are on top of Kubernetes, right? They are applied one after other based on some quality gates being passed. We have like quality gates and governance gates before things go to production. Only the ones that are passed will be deployed, and then if there is any problem in between, the deployment will be halted, and then someone needs to like sort of introspect what's happening, and then if something needs to be fixed, or otherwise the reconcilier will take care of bringing the cluster to the desired state that is defined in the Git repo. And with this is how the current GitOps model look like at Fidelity. And recently, we had to do this Helm migration, right? As you all know, Helm 2 is deprecated, and we started with Helm 2, and we have like I said, like we have about like 200 clusters currently running, and we had to do migration for all these clusters, right? And we want to give a seamless experience to our BU partners so that they don't have to like do any additional step. It's has to be like a click of a button for them, and all the migration has to be taken care seamlessly. And and with that and with that information, we are managing our components using Helm releases, right? And then the Helm operator is a natural choice for us having this feature, and we have put the effort to contribute back to the Helm operator to add this functionality to migrate any Helm charts that are at Helm 2 to 3, and yeah, that Helm 2 to 3 contribution to the Helm operator has helped us migrating all the Helm charts from 2 to 3 across all our clusters seamlessly. That has been like a really good experience for our BU partners. Yeah, and I'll hand over to Mahmoud, who has done the efforts with the in Helm operator for the migration from 2 to 3, and yeah. Hey, Mahmoud, please take over and give the demo.
Sorry, I was trying to unmute. Can you hear me okay?
Yep, I can hear you.
Perfect. So thank you, Kishore, for that great introduction. So yeah, as you can tell, Fidelity is running multiple clusters in the hundreds of clusters, right? And in order to do a migration of Helm 2 to 3 with minimal impact, or the least amount of impact, it has to be well crafted, if you will. And using the Helm operator was a great opportunity for us to do this in a seamless way. So the Helm operator for a while supported both Helm 2 and Helm 3 Helm releases, or the custom resource called Helm releases. And but there was no way to migrate an existing release from Tiller into the Helm 3 format, right? And in order to do this, we had to do um, um, basically implement this inside the Helm operator. So this diagram, or this flow chart, describes the flow of the algorithm, how it decides what to do with the custom resource. And we'll show a demo of this in action right after. So the way this works is we get a new Helm release that's applied in the cluster. And the first thing we check is this a V3 release, and does it exist in the cluster? Is there an existing V3 release in the cluster? If so, then we just proceed and pretend it's an upgrade action. If not, we check if there is a V2 release in the Tiller storage. And we also check for a new annotation that will show. And if both are true, then we go ahead and migrate the Helm. We run the 2 to 3 plugin inside the operator, and then do any upgrades that are necessary. If none of this is true, then it's a brand new V3 release, and we just install that Helm release. So I'm going to switch to my terminal. So we have, we have this repo that you can run through this demo yourself later. But basically in this repo, we'll walk through how we can set this up. So the first thing we need is a kind cluster. So I'm gonna, and I have the copy of these instructions up here to make it easier. So I'm gonna follow these steps here. So the first thing, let's check that we have a kind cluster running. And indeed we do. So I can go ahead and do install Tiller. So let's start with, sorry about that. So I'm going to copy these commands. And as you can tell from, if you're familiar with Tiller, this is a standard installation of Tiller. We're setting up the RBAC rules for Tiller, and then we're calling Helm to init. And you can see Tiller already exists, so it didn't do anything. But these are the steps how I set it up, basically. Next up is we installed the Helm operator with version 1.10, which did not support the 2 to 3 migration. So let's run these steps real quick. So we're creating a brand new Flux namespace. We're installing the Helm operator 1.10. And Kishore, if you have any questions along the demo, please feel free to ask them.
Sure. So I see the flags there, V2 and V3. Does it mean that this operator supports both? This version of the operator supports both Helm V2 charts and V3 charts?
Yeah, thanks.
But
Thanks for asking. Yeah. So this means that these are Helm values. So we're using Helm 3 to install the Helm operator itself. And what we're doing here is we're setting a configuration for the operator to say you can support both Helm 2 and Helm 3 side by side. And the first one that you mentioned here becomes the default. So it's defaulting to V2. If you don't explicitly mention a version, it's going to default to V2. But yeah,
Okay.
great question.
So it's going to use Helm 2 to install the installer upgrade that chart if it's not defined as a default option. So if you change the order, that's going to change the default value for Helm.
Exactly. Yeah.
Okay.
Let me make sure we don't have any Helm releases already. Oh, okay. So I'm going to delete this old one for the demo. So I'm going to say delete HR weave scope. Okay. So we should have. Oh, sorry. Yeah. Can you hear me now? Sorry about that. Yeah. Yeah. So I deleted the Helm release that I had, and I'm going to go through the demo now. So let me, so I have a V2 file here. I'm using bat, which is like cat, but anyway, it just makes it more easy to read and more syntax highlighted. So we can see this is a Helm release, a standard CRD instance for a Helm operator resource. And here we're setting the standard Helm values for weave scope in this case. So nothing special here. The only thing is that it's going to be a V2 release since that's the default. We didn't explicitly set the spec Helm version here. So when I apply this V2 manifest, we expect that when we run Helm 2 ls, that we will see weave scope show up. And indeed, there it is. And what this means is the operator picked up the new V2 CRD, applied it to the cluster, and Tiller has access to it now, right? So now we want to move to V3. So in order to do this, we have to upgrade our operator, and we need to do some changes to the manifest. So I'm going to open the V3 YAML again. So this is
if we do,
oh, yeah,
can I
go
ask
ahead.
a question? Sorry, if you do Helm V3 without on the same operator, what do you think the expected behavior would be?
So if we just switch, you mean if we just switch the Helm version to V3?
Yeah, yeah.
So it would try to install it as a brand new
Okay.
chart, and it will probably run into issues, right? Because
okay, you're probably going to end up with two different versions of the application running in the cluster,
right,
which is not don't want to have, right? Cool.
Yeah, and it will probably get stuck. The operator will probably get stuck and say, I already have this resource. It's managed by another by Tiller. I'm not sure what to do, kind of thing, right?
Yeah.
So yeah, that's a great question. Does that answer your question? Yeah.
Yep. That's cool. Yeah.
Perfect. So we so here we have the v3.yaml, which is a replica of the v2.yaml with the new annotation that says migrate set to true. And just I want to mention also that if you just want to test the migration, you can set this to dry-run, and that just makes it so that the 2 to 3 logs get printed out in the operator, but it doesn't actually do the migration. But now for the demo, we actually want to do the migration, and we also set the Helm version explicitly to v3. So these are the only 2 changes we made, which are 1 and 2 up here in the docs, and then we're going to go ahead and upgrade the operator itself to version 1.2.0, which does support the 2 to 3 plugin. We're still going to have the same defaults, the same V2, V3. We want to support both side by side, but the difference is now you can actually run this migration. So how do we do this? All we have to do is apply the v3.yaml. So I'm going to copy this. And now what we expect is that the Helm 2 tiller release would basically disappear. And there it is. It went away. And now if I run Helm 3 LS, we can see the weave scope release was migrated. And I can check the Helm resource as well, the Helm release CRD. And we see that it is still in a deployed status. It's been up for 2 minutes and 42 seconds since the Helm 2 version, right? So it's the same CRD instance with the same age. The difference is it was migrated from Tiller to the V3 storage system, which are, I believe, config maps, if I remember, or secrets. I forget, but yeah.
Cool. This is cool. So it has now seamlessly migrated your Helm 2 chart to Helm 3.
Yep, exactly. And we can check this in the logs explicitly. So if I go here, we can go up into the logs, and we can see here the Helm 2 2 to 3 output of that Helm release migration. Yeah.
So there is no info. The info is probably also available in the Helm release as well, right?
Oh, you mean like
the
CRD
status of
itself?
the migration? Yeah, the CRD itself.
Yeah,
you could also check the status from there.
You can see that, yeah, as well. So let's switch back here. So if I say Helm releases, we can see that it's still in a succeeded deployed status. But during the migration, I believe it goes into migrate phase, and then it goes into the succeeded phase. So it does go through those stages. Yep.
Okay, that's cool.
Cool. I think that's it for me. I'm gonna switch it back to Kishore, who is gonna talk about how Fidelity. So we did this migration from 2 to 3 at Fidelity for hundreds of clusters. So how do we now move to Flux 2, and also some announcements from Fidelity, which Kishore will share. So I'm gonna stop now.
Let me start my share here. Can you see my screen?
Yep.
Cool. Thanks, Mahmoud. That was an awesome demo to see the Helm 2 to 3 migration in action by the Helm operator. And yeah, like Mahmoud said, this has helped us migrating from Helm 2 to 3 in across all our clusters and giving a seamless experience to our BU partners. That was a nice experience. So let's go through. Yeah. So next, we're going to check the add-ons management with Helm operator. So what's an add-on before going to the add-on management? So add-on is like an additional component that we add on top of Kubernetes to offer a set of functionality for our business needs, right? So we have we use external DNS for DNS, and we have cluster autoscaler, vertical pod autoscaler, components like that. So we add additional components on top of Kubernetes, and then we call it a version of platform, and that's how we distribute the software to our BU partners at Fidelity. And these add-ons have dependencies between them. For example, we have a cert manager that is deployed as part of the add-ons, and cert manager is a needed dependency for vertical pod autoscaler or any other component which has like a need for certificates to be created, right? So in that with that kind of dependency, we currently have like an internal component which will take care of these kind of dependencies to ensure that each dependent add-on is deployed in an order specified, and then it also ensures that each add-on is passing the quality gates. We use Helm test. Helm test is one of our quality part of our quality gates, which will give us back if the deployment is functioning as needed. And then if everything looks good, we go to the next add-on in the list and deploy that particular add-on, and go so on. And as we do this, we deploy each add-on, meaning we apply the Helm release basically to Helm operator, and Helm operator is going to pick up these add-ons and then add-ons Helm releases and then apply them to the cluster. And Helm operator is going to ensure and it has the credentials to pull the new charts that are defined in the Helm releases and then apply them to the cluster. And yeah, that's how we do the management today. And here is a glimpse of our platform version. Here this is just an example here, like the initial part indicates 1.16 is like the referring to the Kubernetes version, and then FeedEKS is the platform, and then the version of the platform with all the set of add-ons. So you see there are like plenty of other add-ons used in this list, like Cert Manager pointing to V0.1.15.6 or ALB Ingress Controller 2.2.9. So these are all pinned to a specific version of the platform that is given to the BUs. And we have each of these add-ons having dependencies, right? We define these dependent add-ons as one layer. So we consider like if these set of add-ons are dependent on another set of add-ons, so we consider them as layers. And it's easy to from the consumer point of view, like for the BU, it's easy to understand how a particular layer is functioning. If we have like a security layer or a common layer or some sort of application specific layer called ML layer, right? So the bunch of add-ons will form this layer, and that will sort of make it easy for our BU partners to understand how the layers are functioning, right? Yeah, and what we are going to do with our GitOps strategy in future is we are announcing a new project called Cron that is built on top of GitOps Flux 2. And what this is going to do is this is going to offer us a mechanism to manage the layers of add-ons so that they are cross-functional across the cloud providers. Like let's say here in this image, you can sort of like see there is a security layer, there is a common layer, there is the platform specific layer. And this is sort of like helping us to abstract the a set of add-ons which are dependent on other set of add-ons, and then also give the consumer of the platform a good understanding about the health of the cluster in a good way. So let's take a closer look at a layer, right? So here's an example of a common layer. Currently, the layer is composed of a bunch of Helm releases, but the plan is to have additional Kubernetes resources as well, not just Helm resources like Customize or any other plain manifest as well. That's the plan to have. So in this example here, we have a common layer, which is a prerequisite for the management layer. So what cron is going to do is it ensures that all the Helm releases in this common layer goes together and are deployed before going to the next layer, which is the management layer. So cron gives this flexibility of helping us manage the dependencies between the layers, and it's a mix and match. So you might know that the Helm operator has the dependency feature as well. So you can define like a Helm release X is dependent on Helm release Y. So that is still there intact, and this is just on top of what Helm operator offers. You can have dependencies between the layers, right? Yeah, so that's our plan for future, and this is an open source project, and we welcome any additional contributions to it. And here are the links for the cron. That's the first link there. Cron, please go ahead and check it out. And the demo that's done today is also available. You can always go and try it out by yourself. It's pretty cool to see it in action doing the migration. And we would also like to mention about another cool project. It's a bit unrelated to GitOps, but it's a nice project for if if you're operating in cloud with multi-cloud providers like AKS, EKS, GCP. This is a project that we started, K-Connect. It is to connect to your Kubernetes clusters across the cloud platform providers. Yeah. So, and we are also hiring. Please look at our careers page, and if you're interested, please go ahead. And then we are open for questions.
Awesome. Thanks, Kishore.
Thank you so much, Kishore. We don't really have time for questions, but I just wanted to remind both speakers and audience to please post questions in Slack, and we'll have a conversation there. So take it away, Scott, on Flux 2 for Helm users. Yeah, it seems like we're having some kind of technical issue with your audio, Scott. It's actually a bit creepy. It stopped. Oh, okay. Well, yeah, so it's not. All right, so I'm gonna entertain everybody while we resolve this. We'll resolve this issue in backstage. Yeah, Mahmoud and Kishore, could you just come back and we can have a chat? Oh, we can actually address the questions because we didn't have time for that. So let's get back on, you guys, and let's talk for a little bit while Scott fixes his creepy. Cool. So I at least saw a question for Kishore. It might not be the first one, but Prasad Gunasekara was asking, could you please speak to what tooling being used for quality gates and governance gates?
I'm not sure if I'm allowed to talk. At least the one thing that we do is Helm test that is open. So every time we deploy a Helm release, if it's a Helm, we also have non-Helm releases components. So if it's a Helm release, we ensure that Helm tests are passed before actually going further with any additional add-ons in the deployment pipeline. So yeah, hope that answers.
Cool. I don't know about other questions. I don't think this was directed to you. Someone was asking about micro Kubernetes kube spray for bare metal provisioning. I don't know if you have anything to say about this. Yeah, I don't see any more questions. Do you?
Cool.
Oh, great. Yeah. So we're just gonna take a music break then, and we'll come back when Scott has his audio. Thanks.
We got prescription for the night shift junkie. We rock the country, the town and your city. But you can't blame me for the ecstasy. We talk about hey, Mr. Taliban, I wanna be alright. We walking at the W in the far west side. The dots of the ship will lock down by $100 cushion Lord God in Jesus Christ. Hey, Mr. Taliban, I wanna be alright. We walking at the W in the far west side. The dots of the ship will lock down by $100 cushion Lord God in Jesus Christ. Up back, hip up, electro rock a funky. We got prescription for the night shift junkie. We rock the country, the town and the city. But you don't blame me for the ecstasy. Yeah. Up back, hip up, electro rock a funky. We got prescription for the night shift junkie. We rock the country, the town and the city. But you don't blame me for the ecstasy. Yeah. The ecstasy, yeah. The ecstasy, yeah. The ecstasy, yeah.
That's the sound of the police. That's the sound of the beast. That's the sound of the police. That's the sound of the beast. That's the sound of the police. That's the sound of the beast. That's the sound of the police. That's the sound of the beast.
Welcome back, Scott. Did you get your audio fixed? Oh no, I can't hear you. Hmm. Are you muted? No. Oof. All right, can we bring back the music break? I'll just dance without the music. Don't hear you. I'll just stay to my own tune until we come back with the music break. And
Is everything good? Bianca, need a dancing partner?
Yeah. Oh, thanks. You're back.
Hey. All we doing is dancing on stage.
Arrêtons les débats. Là c'est chaud. Il frappe ici et là. El Niño. El Niño. El Niño. El Niño.
All right. So we've got DJ Desired State coming back up.
Direction du nord. Very hot. Mets ton cap vers le sud. Very hot. 40 degrés à Brest. Very hot. Nos leaders sont à l'ouest. Very hot. Very
Hello, can you hear me now?
Oh, you're back.
That was some serious technical voodoo. Okay, well, thanks for everyone for being super patient.
Yes.
Rocking out to good stuff. I'll just have to go very quickly now.
Right, stage is yours.
All right. I will share my screen. You know, that's what we do. It's all about reconciliation, right? So in the cloud, things don't always work the first time. So, for example, the slides are not loading. Let me stop the share and start again. Okay, should be okay. Let's try it one more time. All right, can you see my screen? All right, hey, all right, so let's pretend I'm on 2x speed, but I'll try to be clear and I'll just skip things that aren't really that critical, and I won't get into detail at this moment because of time. So, overview is just, I'm gonna go over some of Flux 2 awesomeness specifically for Helm users. going to just briefly at this point mention when to migrate and perhaps when you might not want to migrate. Okay, and then I was going to do a demo of the Helm operator to the controller migration from Flux v1 Helm operator to Flux v2 Helm controller. And I have that migration all set up, and I'm happy to do it if we have time at the end. So I'll just check in then. Okay, so Flux 2 awesomeness for Helm users. One is the primary thing, which I think our technical difficulties illustrated, is that reconciliation is super important, right? I know you've probably heard that about a billion times so far in GitOps days, but now with the Helm controller, you can pause and resume that reconciliation per release. That is pretty important. Flux 1, if you needed to do this with the operator, you had to pause the entire operator. You had to scale it down to 0 in order to pause reconciliation, or rather just simply pause the entire thing, and it paused all releases. Now you can have a more fine-grained, flexible way of doing that. And this is important for, it's valuable in non-production environments, so that you can debug, but it's also valuable in production in case you need to do specific and manual things. For example, some teams, don't have all of their, I know this never happens to anyone in this audience, but don't have every application in fully stable microservices and everything's running smoothly. Sometimes there's legacy code, sometimes there are manual gates, sometimes there are things you have to do. And this is really important and valuable for those purposes. The controller also has a depends on feature, which is very nice. This is essentially if you, I'm going to skip to the example first about if you have, say, workloads that have ingress and you rely on an ingress controller, well, you might want that installed first. If you are using annotations for Cert Manager, for example, for TLS, same deal. You may want to ensure that that's installed first. So depends on is really valuable here. The other nice feature of depends on is that it's more memory efficient than a way of doing it that many people may have done in the past, which is to make one gigantic umbrella chart that installs all of your dependencies. Helm does a lot of things, stores a lot in memory when you have an umbrella chart and all of its dependencies. So depends on really helps keep that a lot lighter. Another nice feature of, and I'm just kind of going over some highlights here, but another nice feature of the controller is that you can use Symver ranges. So you can see the examples here. My understanding is that was a feature that was added in the controller. I have a link to the docs, so when you look at this amazing slideshow later, you can actually read up on the details of when that was introduced and what you can do with Symver ranges. This is nice if you really want to keep up to date with, say, just the 2x version, and you don't really want to pin a specific version below that. You can also keep to a minor version. Really anything that normal Symver ranges allows you to do with Helm, you can do now with the controller. This was a nice feature. Some people may not need this. Many may not, but some do. So you can install from S3, Google Storage, Azure, really any bucket. For those of you who can't see the GIF, the KFC note is just a joke about this meme, but basically any, well, not any, but let's just say currently supported storage buckets can be a source. So the source controller allows that, and you can pop your charts in there and install from there. Another really nice feature is that if you want to add an additional Helm repository, you don't have to restart your daemon to do that. Your daemon that's supposed to do your reconciling can stay running. Now with Flux 2, the controller, because we use references, we actually separated out Helm repos from Helm releases. Those are separate CRDs. now those custom resources are now referenced, and it really is what you would want to expect, I think, at this point from a developer experience. It allows greater isolation ultimately, just like the last feature. So this essentially allows you to reuse repos and reference them. You don't have to define them over and over again for each release. You can define one repo and recycle that, reuse that ultimately. It's because it's pointed to by name now rather than the rest of the metadata stored with the release. And a cool feature that I think Lee covered pretty in depth in his demo is that you can now have an out of cluster experience. You can use a Flux, a management cluster to now control other clusters. Flux uses CAPI under the hood for that. And it allows you to essentially do fleet management or any other kind of pattern that you can actually get creative with it and use this for different things, perhaps use cases that we haven't envisioned yet, but it does in fact work and it works well. So I'm now to the point where I was going to do a demo of the Helm operator, but just in preparation for this, I have a gist up, which I've linked to as well, and I can just. Do you think it's better for me to just show the images of what this does rather than showing the demo? Do I have time to demo? Okay. Then in that case, why don't I now escape from the slideshow and go ahead and open up my gist. So I'm just going to show you all how this works. It should be relatively fast. I'm creating a kind cluster. Could I zoom in on the gist? Is this a little more readable? Okay. So basically, I'm just creating a local cluster. It'll take a few more seconds. I'm going to install a barebone Flux 2 installation that doesn't have all the things you would normally install with Flux 2 using the new Flux CLI. I'm just installing only what we need: the Helm source controller, the source controller and the Helm controller. So that'll just keep this demo shorter. Oh, actually, you're supposed to be seeing my terminal. Give me 1 second. Sorry about that. Yes. So can you see my terminal now? Okay. Just believe me that I actually literally created a kind cluster, and I literally also installed. So that took 30 seconds, and I just literally installed the only the components that I need for this demo with Flux, and that took 2 seconds. So now I'm just really going to be copying and pasting from that gist, and I'll describe what I have in text. So now I'm going to install the operator. This is going to be fairly fun. I'm just going to simply apply the CRDs, the RBAC, and the deployment YAML. This is from the Flux docs. The one thing that we had to update, I don't know if the Flux docs have been updated yet for Flux 1 rather, is this patching needed to change a little bit. And that should be there properly now. I'm now going to install the Flux 1 operator custom resource. The Helm release custom resource. So you'll be able to see this in my terminal, but I'm basically taking this this demo example, and this is the fluxcd.io v1 custom resource for Helm release. So people in the audience that are familiar with this, this is how you did it, right? I'm using Stefan's wonderful pod info release. So now if I do a Kubernetes get that resource, I should actually see the operator custom resources there. I should be able to do a Helm ls to also see that it did in fact install the Helm release. Yay for Flux One. Okay, so now what I'm going to do is I'm going to scale down the Helm operator, because that's what you would normally do, and that's how you do it. You set it to just 0 replicas, because you don't want this reconciling while the controller is also trying to reconcile. They might not like that very much together. So what I'm going to do is, because I've already installed the Flux 2 components that we need, I'm going to now apply a version of the custom resource for Helm 2, the same version of that custom resource for Helm 2. Or I'm sorry, rather, I'm going to do this in 2 steps, because I'm going to install the Helm repository that I mentioned. We split out for better reusability. And I can actually do a describe on that repository to show that that it fetched the index, which it did. And now I'm going to apply the version 2 of the controller, the version 2 controller custom resource for that same Helm release. And so this is how it maps. You can check out the details of the demo later, but there are reasons why there are ways to map it, and it's all in the docs. Okay, so I'm going to apply that. By the way, just to be clear, this mapping is something from V1 to V2 you have to do manually. There's nothing, we can't really do that for you with the tools. It could be possible. It's something like a Helm 2 to 3 plugin, but there are so many different use cases, so many different ways that these were used, that it really isn't worth the time now, especially now that Flux One is in deprecation mode. And, so in any case, in future though, for version 2, I just want to clarify to the audience, to everyone wondering if they're going to have to do this over and over. The answer is no. We're going to have conversion hooks for new CRD versions of Flux 2. So you don't have to worry about that for the future. I'm going to go ahead and see that now. I was looking, remember, at the V1 resource. Now I'm looking at the V2 resource, just to make sure that actually populated correctly, and it did. It looks like reconciliation succeeded. Wait a sec, what does that mean? I'm going to do a Helm ls, and now I can see that there are 2 versions, because now the controller has reconciled and created a new Helm version. It's exactly the same, but Helm now knows that this is reconciled and that actually worked. So I'm going to do Helm ls just to prove that that's. Excuse me, I just did that. I'm now going to let's see. I'm now going to show what reconciling is like. Let's say I want to go ahead and uninstall this release. Okay, and you can see that that it is in fact. Oops, excuse me. Helm ls. You can see that it is in fact no longer there. But if I now use the flux reconcile command, if I had just waited 10 minutes, it would come back, because I specified this, or sorry, I specified the interval for 5 minutes. We could wait 5 minutes, but let's not do that. Let's go ahead and just trigger this manually by doing a flux reconcile. This is another thing that human operators have at their disposal, in addition to webhooks. Okay, great. So now that's there. Now let's do a Helm ls again. Whoa. Can I zoom in on the terminal? Yes. Can you see that? Okay, great. So I do a Helm ls again, and voila, the the release is there. And so now what I'm going to do is, let's just assume that we've moved through, users have finished upgrading all of their V1 Helm releases, the upgraded Helm releases, and we're all finished with that. Now I'm going to go ahead and just go ahead and well, let's say I won't assume that. I won't actually assume that. We've just finished with this one release, so I'm going to go ahead and remove the V1 custom resource for that specific release definition. So once users are finished with all of the their releases migrating, then they can go ahead and delete, remove the operator from the cluster, and then you'll be all cleaned up. I'm going to clean up this demo just by deleting the kind cluster, and I'm now finished. So that was that. And great. So I think we're now at, okay, just when to migrate. So we think new users should go right to Flux 2 for the most part. Nearly everyone will want to do that. It's better architected generally. I mean, that's why it's a version 2. It's got a lot of new features, some highlights of which I've covered earlier. But you know, and existing users can also do this for the most part. There is an upgrade path, which I just demoed. But here's the caveat: is that there's not 100% feature parity yet, specifically with image updates. So if you're a user that relies on image updates, it is a good way finished. It is in progress. Just hang tight with Flux 1 if you need that. If you're a new user and you absolutely know that you need that, then you may want to consider either postponing temporarily or starting with Flux 1 because there is an upgrade path. And then otherwise, just go ahead and go to Flux 2. One other caveat that's important, it's not really a caveat, it's more like, please join us in this journey. If you have very complex charts that do very weird things that are not recommended, there might be use cases that this raises that we just don't have the ability to test yet, and that the various Flux maintainers just haven't run across yet. There are a lot of people testing this, using it, but it's always possible that, you know, Helm allows you to do so many things. So please test those if you have them in non-production, and help us by posting issues. Let us know what you run into, and we'll see what we can do together. So we thank you for that.
Are we doing Q&A? Scott, thank you so much.
Yeah, thanks, Damani. That's great. So if there are no questions, I'll just go ahead and head out. But if you do have them, just send them in, and we'll connect with you on Slack. Thank you.
Yeah, I'm looking on the Slack, and I don't see anything pressing for you right now.
Okay.
Good stuff.
Thank you.
I feel like I was watching 2X. The long-awaited time is here. Everyone's been asking for Stefan, so there's been a lot of questions, and he has an exciting demo coming up, an exciting conversation. Stefan, how are you, boss?
Hey, Damani, I'm great. I'm nervous, like before any talk, but I'm here and I'm ready.
long time no see.
Yeah, hopefully next year, right?
Right. I'll leave the stage. I'll leave the stage to you.
Okay, thanks. Gonna share my screen. I hope that's okay. Everybody sees it. Cool. Hello, good evening. If you are in Europe, my name is Stefan Prodan, and I'm a developer experience engineer at Weaveworks. And for the last couple of years, I've been a Flux maintainer, and I'm also working on a tool called Flagger that fits in the same space around continuous delivery. So today I want to share with you the evolution of Flux, how it started here at Weaveworks and how it's evolving into version 2, which I guess you heard about. So like all CI/CD stories, it starts with this. Have your app repo, everything is in there. You have manifests, Docker files, and if you've done that like 4 or 5 years ago, there was no Helm, no customized, no nothing. So you'll be running probably a Jenkins server, build your image, then do a replace inside your manifests to set the image tag, or maybe even worse, you push the latest image and then you add I don't know, a label or an annotation on your pod, so the pod restarts and Kubernetes will pull the latest version. And this worked for us for for a bit. Then we decided that this kind of approach has major limitations. For once, it works if you have a single app and you place all things in your repo here. Let's say the namespaces, maybe an ingress controller, and everything else that your app needs. But if you have more than one app, then where you place all these shared manifests? Also, what happens if, let's say, you deploy the app, everything works fine, and after a minute or two, the app runs into a problem or a bug? How do you roll back? With such a pipeline, you'll have to maybe rerun the previous job, produce a new image, and deploy the old code this way. Or you go into the cluster and manually change back the image tags and everything else. So as you can imagine, if you have hundreds of apps, this approach has a lot of issues. Also, if you are targeting more than one cluster, every time you add a new cluster to your fleet, you have to go into your CI/CD pipelines, add the new cluster there with a kubeconfig and so on. So if someone hacks your CI/CD system, then yeah, they have control over your production system as well, not only your pipeline. So to improve this, we made a decision to break CI from CD. So CI, it's about test, build, and push. It stops at pushing the container image in Docker Hub or any other container images that you may use. The important bit here is that you should produce immutable images on every job run. How you can do that? You can use the Git SHA or the Semver if you are building a release, and never push over an image that was stored in your registry. Now, once you no longer do the testing on the Kubernetes cluster, and here you may wonder, like, how can I ensure it will not fail on the cluster? There are a couple of solutions. What we use in the Flux organization for Flagger and many other projects, we spin up a Kubernetes kind cluster inside GitHub Actions or inside Circle CI or whatever CI platform we are using. So we spin that there. We deploy our app inside the Kubernetes cluster that's running in the CI VM, and we do the end-to-end tests there. It's one solution. I'm not saying it's perfect. It works great for us. But you may actually want to spin up, I don't know, ephemeral clusters to do this kind of testing if kind is not good for you. Okay, so this is how CI works. And for continuous delivery, we made the decision to run the continuous delivery logic and everything that implies managing the release inside the cluster. So CI stays outside, but for continuous delivery, we move that inside the cluster. And this gives us a couple of advantages. If you add a new cluster to your fleet, and let's say that cluster has to deploy the same thing, you can just connect it to the Git repo and it will work. other things you can do inside your repository, and I'm going to demo a couple of repository structures later. You can create customized overlays or Helm releases and target different cluster groups: staging, production, development, pre-production, and so on. The advantage of this approach is that the cluster is in charge with its own reconciliation. You don't connect to it from outside and tell it what to do. The cluster knows what to do based on a Kubernetes controller that's running inside. So that's a major shift in terms of how you instrument your pipelines. Now, what's running inside the cluster for Weaveworks? That's Flux. And I wasn't at Weaveworks back then, but Flux was started 5 years or 4 years ago. So it's a long time for Flux G1 production usage in Weaveworks. This is how Flux version 1 does cluster management. So you have a cluster Git repo that defines the whole state of your cluster. You copy all your manifests from your app repositories in here. You define namespaces, everything else that you need. Then you deploy Flux on your cluster, and you configure Flux with a deploy key to connect to your Git repo. And since all the app's manifests are in here, how would you update an app to a new version? And how we tried to figure this problem out was for Flux to scan container registries, find new images, and write back to Git based on a Semver expression or a regex or something like that. It will write back to Git the new tag. Then another part of Flux will detect that change and apply it. So you can think of Flux as a monolith from that perspective. It does a bunch of stuff besides just applying things on the cluster. It does Git operations, so it knows how to connect to Git, how to authenticate. It knows how to authenticate to container registries, scan them, pulls everything together, then applies it. Now, later on, Helm became really popular. So we decided to create an operator for Helm that will deal with Helm in a native way. So we could just use Flux v1 and call inside Flux Helm template, get the YAMLs like Argo and other solutions are doing, and apply that YAML. We thought that we want to give the Helm users a full Helm user experience when they do GitOps. So that's why we chose to build a dedicated thing called Helm Operator, and Helm Operator will uses existing Helm packages, Golang packages, and does the same stuff as you would do with the Helm CLI in terms of installing, upgrading, testing, rollback. All these operations are expressed in a custom resource. That custom resource can be placed in a Git repo. From there, Flux will apply the Helm release custom resources in your cluster. Helm Operator will react to those changes. And what Helm Operator does, it connects back to Git. In some cases, if you store your charts there, pulls the charts inside its own container, builds the chart and applies it. Or you can configure Helm Operator to connect to a Helm repository, pull the index from there, pull the chart, and apply the release. So as you can see, there are a couple of overlaps here in terms of operations. If you use the same Git repository to store your charts and also all your manifests, then inside your cluster, that particular repository will be pulled twice by Flux and by Helm Operator. And Flux version 1 is limited to a single Git repo. It cannot connect to more than one. While Helm Operator can connect to more than one, but you have to configure known hosts. You have to mount files inside the Helm Operator container to give him the SSH keys and configure the right authorization for it. Also for Helm repositories, it was the same. You had to create the repositories.yaml, set there all your secrets, and mount that file inside Helm operator. So having this running in production for, I don't know, I think Helm operator is close to 2 years now, 1 year at least. We decided, hey, we need to come up with a new thing where these two controllers don't have to do the same operations twice. So while thinking about that with the other Helm Flux maintainers, we come up with a solution that manages sources, and we call that source controller. So we've built this thing as the first step towards Flux version 2. We didn't know where we'll get back then. So we built this controller that based on custom resource definitions, and it comes right now with 3 of them, a Git repository, a Helm repository, and a bucket. It knows how to connect to all these storage solutions. It will pull the manifest from there. It will create an artifact inside the cluster so other controllers can consume it. And while we were working on source controller, we came up with the idea to create an SDK, and the name of the SDK is GitOps Toolkit. What this means is that we've built Golang packages and specialized tools like Kubernetes controllers that work nicely together using Kubernetes events and using custom resource definitions. They have no HTTP API. You drive the operations through the Kubernetes API. And we decided to write these controllers with Kubernetes upstream libraries instead of doing what we did in Flux. Back then, when we started Flux, there was no custom resource definition. There was no operator concept. Things have evolved a lot in the last 4 years. So inside the Kubernetes project, there is a library called Controller Runtime, which offers a lot of good libraries, so you can build controllers easily and in according to upstream. So we adopted this framework, and we developed our own SDK for it. So we have source controller built in that way. And then instead of rewriting Flux version 1, Helm operator to use source controller, we decided to go forward with the refactoring and rewrite all these specialized controllers with controller runtime libraries. So instead of rewriting Flux v1, we created a customized controller, which is the controller that applies plain YAMLs or customized overlays. And instead of Helm operator, we now have Helm controller, which is specialized on Helm operations. And we are working right now on a set of controllers that will deal with the image update feature. So a lot of people asked us for Flux v1, hey, can I scan for registries on a different cluster and write to Git than some other Flux instances from other clusters could reconcile and so on. So that wasn't possible because you cannot tell Flux, hey, just scan a library, a container registry. Now that we have these dedicated controllers, you can run these controllers wherever you want. And there is no tight coupling between them. So you can run the image update controllers on your management cluster. They will take care of all your repos, and then the production clusters will detect the changes and will apply it, for example. The idea behind the GitOps toolkit is that all these controllers are working together. So if we put all the things inside the cluster, we get Flux version 2. So Flux version 2 is made out of source controller. We manages Helm repositories, Git repositories, S3 compatible buckets. Then Based on those sources, you can configure customized controller and Helm controller to reconcile your cluster state. So this is the part, the reconciliation part. And also in Flux version 1, a lot of people asked us, hey, we want more insight in what's going on. We don't want to tail the logs every time something goes wrong. We want to get a clean picture of what's happening. So in order to do that, we created yet another controller, which is called notification controller, and notification controller deals with incoming events and outgoing events. Incoming events means webhooks. Let's say you do a Git commit and you don't want to wait for Flux to detect the commit in 5 minutes, 10 minutes, or however long you've set the reconciliation loop. Notification controller has a custom resource definition called receiver, and you can create receivers for GitHub, GitLab, Harbor, and even Jenkins, doesn't matter what. It will bind to a load balancer or an ingress controller. It will validate the payload using HMAC, and you can tell notification controller, hey, listen for events for this particular repo, and when it changes, know the reconcilers about that change. So let's say you do a Git push that changes a Helm release file. Notification controller receives the payload from GitHub. Then it will tell source controller, hey, there is a change. Source controller will actually pull the new revision inside the cluster, and then we'll trigger an event for customized controller and Helm controller. Customized controller say, hey, there is a new revision, I have to apply it on the cluster, and it will apply the Helm release. Helm controller will detect that, hey, Helm release has changed, I have to upgrade it. And if the upgrade succeeds or fails, it will issue a Kubernetes event. Notification controller then can capture that event using a different custom resource called alert, where you can say, if that particular Helm release, let's say the Nginx ingress controller Helm release, issues any kind of events, I want these events to be forwarded to Slack, Microsoft Teams, or there are other options here. I want that event to be forwarded. So the team that's in charge of that particular application can see what changed, if it failed, and if it failed, why it failed. For example, we will tell you that a particular Helm test failed, or customized controller will tell you that your YAMLs is not valid, or maybe didn't pass an admission webhook, and so on. So you get visibility out of what's happening inside your cluster. And in terms of observability, we've added more things to Flux because, yeah, people asked about that a lot. First of all, now you have custom resources to define a source, to define how your cluster gets reconciled, and so on. So you can do kubectl get, kubectl describe, and for each thing, for example, for Helm release, when you do kubectl get, it will tell you if it's reconciled, at what version, and if it fails, it will also tell you the error message. We also added health checks to the reconciliation loop. So, for example, with customized controller, you can tell it to check for after it applies a change, to check for the health check of deployments, of stateful sets, Helm releases, and many other custom resources that report ready status. A lot of custom resources out there are compatible with our health checks. We haven't invented health checks. We are using a library from Kubernetes Upstream called K-Status, which was developed inside the customized project, that knows how to wait for a resource and report if it reconciles successfully or not. So if your custom resource is compatible with K-Status, it will also work with Flux version 2. As I said before, we expose Kubernetes events for everything that's happening. We also expose Prometheus metrics, and those metrics are compatible with Prometheus Alert Manager. So you can also use those metrics and trigger alerts to PagerDuty and other alerting systems that we don't support with Notification Controller. And we export metrics for each custom resource. So you get the same alert through a Prometheus metric, the same that you get through our Notification Controller. For example, if a reconciliation has failed, or if a Helm release upgrade has failed, or a Helm test, and so on. We also made Grafana dashboards based on these metrics, and there are documentation on how you can install it. It's very simple. And of course, we have Slack, Microsoft Teams, Discord, and so on, supported by our own Notification Controller. Now let's talk about multi-tenancy. So because in Flux version 1, we had this limitation where a Flux instance, a Flux pod, can only connect to a single Git repo. If you want to add more repositories to your cluster, let's say you have a repository per team, then you have to install one Flux instance in that team namespace, and that Flux instance will connect to the team repo. And this works well, unless you want to use app repositories and not team repositories. And if you have hundreds of apps, then you have to install Flux hundreds of times. So you can see that this works for team management, but not for distributing configuration across app repos. And we really wanted to enable this use case. So what we did in version 2, we have 2 ways of doing multi-tenancy. One way of doing it and works well for organizations where the dev team collaborates with the team that's in charge of the clusters, I know, operations team, SRE team, however you want to call it, platform team. The idea is that every time you want to add an app repository or your team repository and you want to change the cluster state, let's say you want to deploy things to a particular namespace, you will be opening a pull request on the Fleet repository where the operation people will assign an app to a service account, to a Kubernetes service account. And once that gets merged, then the app repository will be reconciled on the cluster, but that will be reconciled using that service account. So Flux version 2 knows how to impersonate service accounts. And with service accounts and Kubernetes RBAC, you can restrict what a particular repository can change inside your cluster. So you can assign a team to multiple namespaces and bind that service account to all those namespaces, or you can create a service account per app and restrict what the app manifests can change inside your cluster. The problem with this approach is that when you do multi-tenancy like this, you enforce the people in charge with the apps to open pull requests on the Fleet repo. And if they can open pull requests, then they can see the content of the Fleet repo. So they will be aware of other teams and other apps that are running on your cluster because the whole state is declared there. Maybe they cannot see the actual manifest, but they will know what other repos are being reconciled. Now, if you are a platform vendor, you don't want your tenants to know about each other. So in order to solve this problem, what we are working on right now, so this is currently not released, we are working on this multi-tenancy for platform vendors approach, where instead of developers or people that are responsible for app repository, instead of them opening pull requests on the Fleet repo, here the platform team, they are going to add a tenant repository to their Fleet repo. Then developers will add their apps to the tenant repo. So a tenant cannot see what other tenants are running on the cluster. And in order to enforce this, we are going to use Kubernetes users, and we are going to automatically create users for each tenant. And when you add a tenant repo, a tenant definition, a tenant repo to your fleet repository, that user will get automatically assigned. So you as a tenant, even if you want to escape, you want to bind to another user or to another service account, it will not be possible. Everything that's reconciled from that tenant repository or any apps repositories that are added to that tenant will run under that particular user. So it's very similar to the service account approach, but it's more it's hidden in a way and it's enforced by default. Okay, so that was my presentation. If you have questions about Flux version 2, we are using GitHub discussions to collect feedback. If you also have proposals like, okay, I envision Flux, I want to use Flux to do this particular thing and it doesn't do it right now. This is how I want it to be. You can create such proposals also here in the GitHub discussions. So please please join us and let's work together on Flux 2. Okay, that was my presentation. I'm going to do a demo. So we've made this repository inside the FluxCD org to give people an example of how they can structure their fleet repo and target multiple clusters. And in this particular example is around using Helm and Helm charts to compose the cluster state. And first of all, I'm going to fork this. Oh, I already forked it. Okay. One second, I'm going to delete it. Okay. GitHub is very slow today, or maybe it's Zoom. Okay, let's try this again. Fork. No. Okay, I'm going to use this one. Doesn't matter really. So Flux comes with a new CLI. We made a new CLI for Flux version 2. In Flux version 1, it was called Flux Control, FluxTL. The new CLI is called simply Flux, and you can install it from Brew or other package managers. We are also trying to make it compatible with Windows. So what Flux can do for you, the new CLI, is streamline the whole Bootstrap experience. It works with GitHub, GitLab, and we are looking at adding Bitbucket support. If you are using a Git provider that's not in this list, you can follow the manual instructions. And we also have a Terraform provider that does the same thing for the Bootstrap. So with the Terraform provider, you can do whatever you want. This is an opinionated way of how to install Flux on a cluster. So first, let's look at my cluster. Get namespaces. It's a clean cluster, have nothing in there. So with this command, if you give it your GitHub token, Flux will create a repository for you if one doesn't exist. will push all its install manifest to that repo. It will create a deploy key for you, and then will connect the target cluster to that repo. So okay. So this repo is structured like this. I have my app definitions. I have my infrastructure layer that has Nginx ingress controller, has a Redis cluster, have some source definitions. And in here, in my apps dir, I have a Helm release for my app. Then I have overlays for production and staging. So I'm changing things between clusters. And now I'm going to provision the staging cluster, and I'm going to tell Flux Bootstrap, hey, this is where you should look for to synchronize this particular cluster. This is a path inside the repo. I'm going to run this command. And what happens now, FluxTL has pulled all the manifests from our latest release on GitHub. It has committed all these manifests to our repo, and now it's applying for the first time the whole GitOps toolkit controllers, custom resource definitions, network policies, and everything that's needed to create the installation. Okay, Bootstrap finish. Now, if we look at the repo, refresh here, we're going to see 2 commits. So first commit that Flux made with my token, that's why it's my name here. This commit adds the install manifest. So the Flux system namespace, as I said, network policies, custom resource definition, RBAC, everything that Flux needs. Then there is a second commit that contains 2 custom resources. One, it's called the Git repository, and this is how I'm adding this particular repo to the cluster using the SSH address. Flux has generated an SSH deploy key for me, has added that key to GitHub. And what this manifest does, it tells Flux, hey, I want to register this Git repo at this branch inside the cluster. So nothing gets applied from that repo. It only pulls the manifest inside the cluster. That's it. Now, if you want to configure how manifests are getting applied, you have to create this custom resource called customization, which is, you can think of it as the server-side version of your customization object that configures, customize itself. And in this custom resource, I have a path where I'm telling Flux, hey, apply all the manifests from here on this cluster. And where are those manifests? Are in this source called Flux system type Git repository. So the one that we've created here. So based on these two, based on this configuration as a whole, this is the equivalent of installing Flux version 1 using command flags where you specify your Git repo, your path, and all of that. You can modify these custom resources, and Flux version will reload it and will apply the new config. You don't have to restart it or redeploy it or anything like that if you want to change anything in here, let's say the branch or other things. Okay, so now if I'm looking at my cluster, with the Flux CLI, I can do get sources git, and it will tell me all the sources that are registered on my cluster of type Git repository this time. So I see I have a registered Flux system, and this is the commit that has been pulled inside the cluster. Now I can inside my repo, I also defined Helm repositories. So I can do get sources Helm, and I've defined two Helm repositories, one for the Bitnami repo and another one for a demo app, Podinfo, that's a repository hosted on GitHub on my own account. Now, this is how you can query sources and see what's going on with them. You can also see the reconciliation configuration and how that is doing. So I can do Flux get customizations first. And you can see that I have the system one that installs Flux itself and everything else. And then there are two different customization. One is the infrastructure one, and one is for the applications. And yeah, the infrastructure and applications contain Helm releases. So I can do get Helm releases. And this time I'm going to look at all the namespaces. And I see that Helm controller has detected and installed 3 releases for me. The Redis cluster in its own namespace, demo app in its own namespace, and Nginx ingress controller in its own namespace. So how did I configure all of that? Let's go back to the repo and browse a little. So let's start with infrastructure. Here in the infrastructure directory, I have defined my components. If we look at the Nginx one, it has a namespace definition, and then it has a Helm release definition. And this Helm release definition, I can override the default values with everything I want. I can pin to a particular version of Nginx. It's not a good idea to automatically update this one. Breaking changes can happen. So for infrastructure items, I would say do the upgrade manually. And you can see here that the Helm release source is a Helm repository, and that's Bitnami, which is in the Flux system namespace. So if we go here at sources, in the Bitnami definition, it's very simple. We have a Helm repository, we give it the Bitnami URL, and we tell Flux, hey, every half hour, go to Bitnami and check if new things have been added to that repo. And I also have my own Helm repository, which is on GitHub pages. Now, I have this infrastructure, and I want to think of infrastructure as a layer that I want to apply on the cluster. So I have all these separate definitions for Nginx, for Redis, for sources, and so on. But I want for my infrastructure items to be reconciled on the cluster before my applications. So how can I do that? Inside my cluster definitions, if I'm going to staging, I see here that I have 2 custom resources. One is infrastructure, which is a customization which tell Flux, hey, install everything in infrastructure. And now I have this custom resource that represents all my infrastructure items inside my cluster. What can I do with it? I can use it when I define how my applications are being reconciled and say my apps that are, in this case, comes from a customized overlay called staging, because this is the staging cluster. But before, I'm telling Flux, before you try to apply or upgrade any kind of apps, make sure that the infrastructure layer is up and running and is healthy. One good example of why you need this kind of dependencies between layers of manifests. Let's say you have you use the service mesh. Let's say you use Linkerd, and you want to deploy your apps on the cluster. When you first create the cluster, if you would apply the Linkerd Helm chart and all your apps at the same time, there is a great chance that some of your apps will start before Linkerd has the chance to set up its own injection webhook. Using the dependency, you can say, all my apps depend on Linkerd. Linkerd has to be up and running, and you can also define a health check for their injection webhook. And you can say, install these apps on the cluster only if the Linkerd injector is up and running. Dependencies work also between Helm releases. So with customizations, you can define your layers and dependencies between layers. And with Helm releases inside each layer, you can define dependencies between them. So you can say things like, when I'm upgrading my app and my database, I want first for my database Helm chart to be upgraded, that to succeed, and only then upgrade my app. So it works at bootstrap time, but it also works at upgrade time. So it gives you more flexibility if your app have interdependencies. And maybe your app doesn't have that. Maybe you do microservices only and everything run on its own. But when you deal with Kubernetes custom resource definitions versus custom resources, and when you deal with mutation webhooks or validation webhooks, you want those first before anything else. And this is how you can express it in Flux version 2. Do I still have time, Tamo? Okay, I have 15 more minutes, and I want to show you how to structure the apps. So for this example, I'm using plain customized overlays, but with Helm releases. So here in the base directory, I have my app pod info, and how I'm defining my app. I'm defining my app by creating a namespace where that app will be deployed and a Helm release for it. And in the Helm release, I'm setting here values that are common for all my clusters. Doesn't matter if it goes on staging or if it goes on production. The Redis cluster is here, and I'm using Nginx as my ingress controller everywhere. Now, for differences between clusters, you can create overlays with the name of the cluster. That's a good option. So let's say for staging, I have a Helm release patch that only specifies the fields that are different from the base one. So here for my staging cluster, I want to deploy any Helm release alpha, beta, or pre-releases, right? I want to use my staging cluster as a testing ground, and every time I'm doing a pre-release, I want that chart to be deployed here. And since this is a staging cluster, the host name, how my app gets exposed outside the cluster, is definitely different from the production cluster. So here I'm setting a different host name for my ingress. With this expression, what Flux will be doing, because I have here the Semver with the pre-release format, it will look for any pre-releases. So it doesn't matter if I am at version 5000 minus alpha 1. If that's the latest thing that you've pushed to your Helm repository, it will pull and deploy that one. Now, you may wonder, should I build a Helm chart and push a new Helm chart every time I'm doing a commit into a future branch? I think yes. I think you should do it. But if you don't want to do it and you want to override some Helm chart release in your Helm repository, someone contributed recently a feature to source controller where source controller will pull the latest versions, but it will also order them by timestamp. So it will detect if a new version is newer, even if you didn't change the version. But you shouldn't do that. You should bump the chart version in CI and push a new chart every time. So to resume, my staging cluster can deploy pre-releases. Now, if I'm going into my production overlay, now here I have a assembler expression without including pre-releases. So what that means is that only stable versions will be deployed on my production cluster. And of course, here I'm changing the host name. This is not something specific to Flux itself, how you can patch all these things. This is purely a customized feature. And if we look here in the customization.yaml, which is the customized config, we use the base app definition, then we patch our Helm release with our production values. Now, if I go here into staging, and let's see what version am I here. 503 is the latest. Let's say I want to do a manual rollback of this. I'm going to do 502. Going to enable testing, and you'll see why. So this enables Helm tests. Going to commit these changes. Now, what I can do, I can tell Flux, instead of waiting 1 minute, or I don't remember the default, I can tell Flux to reconcile my Git source called Flux system. So it will pull the whole thing. Okay, I've done that. Let's look now at customizations. So I'm at ACB. Let's see what's my latest commit here. It's ACB, so it has synchronized everything. Now, if we look at Helm releases, we see that, oh, we have a problem. We didn't manage to downgrade to 502. Why? Because the Helm test failed. So what this means that we tried to apply a new version, but we told Helm controller, hey, run the tests after you apply it. And if it doesn't work, roll it back. So what Helm controller did, run the test, applied 502. It has run the tests. The test has failed. It told us that the test has failed, and it rolled back automatically for me. You can configure it to not roll back and so on. You have many options here. But this is a feature of Helm controller where you can tell it to roll back. It will also roll back, for example, if your chart has a deployment inside and that deployment fails. Why? Because Helm itself, after it does an upgrade, checks for all the health checks of deployment, stateful sets, and so on. And Helm controller makes use of that. So, and it will also tell you why it failed. And this will end up on Slack, Microsoft Teams, or whatever you are using. This is also Kubernetes event and so on. So we have, let's say, maximum visibility why a release failed and so on. Now, of course, I can roll back through Git, get to the all version and so on. So this is an example of how a change affects the cluster. It failed for some reason, and instead of leaving that particular instance that was failing, we roll it back automatically. Now, this is a feature dedicated for Helm itself. If you want to do rollbacks of plain I don't know, Kubernetes deployments and so on, customized controller has no such feature. So this is something for Helm on its own. But if you want to do controlled rollbacks and have the rollback decision based not only on is my pod working or not. Maybe you want to take into account metrics. Maybe you want to take into account SLOs or what actual users are experiencing with your new version. You can add Flagger to Flux version 2. And with Flagger, you can define a policy for releases where you can say, deploy this new Helm release, but route only 10% of the users to the new version, wait 10 minutes, see, collect metrics, what's happening with that 10% of your users. Are they encountering 500 errors or maybe 404s? Or maybe the app is very slow and request latency is very high. Maybe the app responds in 1 second, 2 seconds, 3 seconds, and so on. And based on that information that Flagger can collect from Prometheus, Datadog, CloudWatch, and other systems, it can take the decision based on your SLO to roll it back or not. And I'm very happy to let you know that we made the proposal. The Flagger maintainers made a proposal to the Flux CD team and CNCF to move Flagger in under Flux CD org and add Flagger to the Flux family. Make Flagger one of these specialized controllers and bring all these tools into the same family and make them work better. I imagine, for example, in the future, Flagger will be using notification controller to issue the same events and so on. Maybe other controllers from Flux will do automatic rollback also in Git based on the Flagger analysis and so on. And so I'm very excited for next year. What we have planned for Flux. We are also working on an image update feature. So if you are depending on that for version 1, we'll have something by the end of the year so you can play with it. And probably early next year, we'll integrate the image controllers inside Flux CLI, and you'll be able to deploy the whole thing like I've shown you today. And that was it. Tamani.
Love it, love it. Good stuff as always. We have a load of questions for you. Are you ready?
Ready. Wait, before the questions. So we have a major mental issue, the Flux maintainers. We created a new repo for Flux. So it's Flux 2, is no longer Flux. It has so less stars than the other one. So if you like what you are seeing, please go to GitHub, click on that star button and make us feel better. Thank you.
Need stars. We need stars, and we're also hiring. Just as a heads up. So folks want to join the Weaveworks family. We are hiring. Check out our hiring page.
Yeah, about that.
We also
so
need stars there.
yeah, we are with the Flagger move inside Fluxid.org and CNCF. We are looking for engineer to help us move Flagger forward. So if you want to work on open source stuff, you like service meshes, you have knowledge about ingress controllers, and you really love this stuff, please reach out to us on Slack, and I'm very happy to explain what this job means. But in the end, it means working on Flagger and Flux together. That's it. Okay, let's go with the questions.
More plugs. So since if you're interested in spending some money, we also sell software as well. So just in case.
Or if you need help, you can pay us to help you. We will be happy to.
So I'll jump in. I have a quick question. They're saying for notification controllers concerning Flux events, not Prometheus alerts, do you manage targets, teams, alerting services natively with Flux CRDs? There seems to be some overlap with Alert Manager receivers.
Yes, there is overlap with the Alert Manager receivers, and I'm going to show you what we support right now. So this is the docs website. We have notification controller, and here we have documented each custom resource because there are a bunch of them. So if we go here to receiver, we see that we support a couple of things. Um, these are the webhooks. The providers are those, let's say, overlap with other manager, these ones, but we also write back to the Git status. So that's something that other manager will never do. What we are doing here, let's say you do a commit in your GitHub repo, you change something, that change gets applied on the cluster, maybe it fails, we'll write back to that particular Git status inside your Git repo, and we will tell you that it failed. So you can, like with CI, you look at your commits and you'll see a red dot. Hey, this commit has failed, and this is why. Another reason we cannot use alert manager for reconciliation events is the fact that we attach in the event body the diff that happened on the cluster. So we'll tell you, hey, from 100 YAMLs, only 3 changed. Or from 1,000 objects, this kind of objects change and these objects got deleted and so on. This is not the kind of information that you can put in Prometheus. Prometheus is not made for, I don't know, log aggregation and so on. But of course, you can say this has an overlap with, let's say, CloudWatch. They can crawl all the Flux version 2 logs, extract all those information from there, and let you know on Slack and so on. We build this because a lot of Flux version 1 users wanted this kind of feature and not depend on third-party things. So that's why we build it. And of course, the Git commit status updates are something that no alert system can do.
Is there a way that Git repositories are refreshed on GitHub webhook rather than pulled on a certain timing?
Yes. So with this receiver custom resource, this is what you can do. You can create a receiver of type GitHub. You can subscribe to the push event. Here is your secret for the token. And then you can say, for this particular receiver, I want to refresh these objects, a Git repository and a Helm repository. In this example, let's say you are using your Git repo for both raw manifests, and you also use something like GitHub pages to store your Helm charts. So from one single repo, you want to trigger 2 things. One, pull all my plain YAMLs, let's say your namespace. If that changes and your Helm release, then pull the actual chart itself from GitHub pages. So you can, Flux version 2 works so Flux version 1 was only pull. With Flux version 2, it works with push and pull, but the push model is all about letting Flux know, and Flux will do the pull for you. So that's how it works.
Got another interesting question here. Any gotchas to be aware of when deploying Flux v2 with a self-hosted private GitLab instance?
I've been debugging a lot GitLab private instances. There are some issues with SSH deploy keys. If you are part of it's not an organization on GitLab, it's a group. If you are part of a group, there are some things that you have to do in order to generate a token so the Flux CLI can create that particular repo. If you get stuck with that, just create the repo on GitLab manually. You create the repo, then you run the Flux Bootstrap command and it will work. Also, we released a couple of days ago a version of the Bootstrap where you can tell Flux to bootstrap the whole thing using a token and no longer an SSH key. So you have the choice between SSH key and token. So if the SSH key doesn't work, the token will work for sure if you give it the right access.
Nice. I still see some questions coming in on the YouTube. I'll just remind everyone to make sure that you're joining the community, the Weaveworks community Slack, and join the GitOps Days channel. But the question from there is there any timeline for the image updates release feature?
So we have a roadmap that has a progress bar that Bianca made. The progress bar doesn't show a deadline. And this is open source. There are no deadlines. So I cannot tell you something for sure. What I can tell you is that you'll be able to test it this month, and maybe you're able to use it in production early next year. No promises.
That's a good answer. That's a good answer.
I see another question earlier in the Slack conversation. It's how do you handle GitOps toolkit updates when running several instances in one cluster concerning the CRDs when you update the CRDs in a new version? How would that upgrade process look like?
So you'll not be running multiple controllers in your cluster. That's for one. So if with Flux v1, you had to do that for each Git repo, is no longer 2 in Flux version 2. So there is a single instance of each controller, and the bootstrap command doesn't only install Flux, it also upgrades it. So you do brew upgrade Flux, that will pull the latest CLI. Then you run the same bootstrap command, and if something changed, Flux CLI will commit that change to the repo. Then Flux itself will see, hey, there is a new change, there is a new version of me. It applies that version and it restarts in the new form. So it does its own upgrades, does self upgrades.
Nice.
Very nice.
Can the values from the Helm chart be inferred from a different repository other than remote source config maps? So avoiding to fork some charts instead of having them defined directly in the CRD.
I don't quite get the question.
Can the values from the Helm chart be inferred from a different repository other than the remote source config maps?
Oh, it's another remote source. So it's a different repository, another remote source, or config maps.
Yes, so you can have values inline in the Helm repository, in the Helm resource manifest, or you can tell Helm controller, hey, for this particular Helm release, go and take the values from a config map or from a secret and so on. So you can create the secrets and config maps in a different repo, add that to the cluster. Customized controller will create those secrets and config maps for you. Then in your Helm release definition, you can reference those files. The only condition here is that the config map, the config maps, and the secrets must be created in the same namespace as the Helm release. And I know a lot of people were upset by this change, but from a multi-tenancy perspective, we cannot allow secrets from being referenced across namespaces. So you can not say, I want to install this Helm release in my namespace, but I want to use the secret from the Flux system namespace. That's not possible. And the reason for that is, multi-tenancy.
So a new question just came in. It's what's the go-to security container tool these days outside of native ones like GitLab uses, and mindful of things like Docker bench securities, Snyk, Antro, etc. Curious to know what the over-indexing choice is here. So this would probably be the last question that we have time for.
Yeah, so in terms of security, I just look at Kubernetes objects from that's my perspective of it. I don't care about containers and everything else. That should be done in CI. There are so many solutions out there that can scan containers also in cluster. From a GitOps perspective, I think you should have 2 types of validation that should also include security features. One, inside your Git repo, you should have some kind of static analysis, and that can be done with a couple of tools that will scan all your manifests and will ensure rules like, do you have limits? Is that container running as root? Don't allow that. Or privilege, sorry. Is that container running privilege? Deny that from being merged into the branch where Flux does it, and so on. And on the server side, if you want to enforce policies on Flux, any kind of admission webhook and validation webhook will work there. If you use dependencies, you can tell Flux, apply the, let's say, OPA gatekeeper first, then everything else. And if everything else means something that's not conformant, gatekeeper will stop it. Flux will error out and it will let you know, hey, have this problem. You've, I don't know, enabled privilege mode on a pod or something like that. One last thing I want to show here in the example repo. So the example repo also comes with a script that validates your YAMLs. It checks if the YAML is actually well formatted. Also does a customized build of all your customizations and uses kubeval to validate what's in there. And they are run on any pull request with GitHub Actions. But I think we can do that no matter the CI. And you should be doing that even if Flux version 2 right now, compared to what we did in version 1, it doesn't just apply the manifest. First time, when it detects a new thing, it will ask the Kubernetes API if the manifests are valid. And it will do a dry run apply first, and only then it will do the actual apply. So you no longer have a state of the cluster where some things from your last commit are applied and some things failed. We trigger all these validation webhooks before we try to apply anything. So even if one thing is wrong, then the whole commit will no longer be applied. And this is how with Flux version 2, we can ensure a transactional mode from Git to the cluster state. Yeah. Any other questions?
Thank you, Stefan. That was amazing.
Thank you very much, Tamani.
Yes, yes.
And
but if you can stop sharing, and if we can invite Cornelia up on stage, hopefully I want to get a screenshot with all of us on stage first before we switch over.
Oh, before I come on, or
no,
you just invited me on?
No,
can I be part of the photo?
Yes. You guys ready? On 3, say cheese.
Cheese.
Perfect. This is one for the books. Stefan, thanks a lot. Much anticipated, and you didn't disappoint like always.
Thank you.
And we have Cornelia Davis to close off the day for us. We're really excited to have you close us off, and then after you're done, we'll have some reflections over the past 2 days. Bianca, anything else?
That's it. Cornelia, please take it away.
All right. Thank you, Bianca and Damani. All right. So good afternoon for maybe most of you, and good morning for those of you who are joining from the US as well. I'm delighted to be here again today. It's, I believe, slightly later than I was yesterday. So that doesn't mean I stayed in bed longer. It just meant that I had a little bit of time to actually watch Scott and Stefan before coming on. I want to thank you all for being here, especially those of you who have made it the last 2 days. Your tenacity is really very much appreciated. And I hope that I can spend the next 50 minutes, 45, 50 minutes or so trying. My attempt is really to put a little bit of a bow on things. Yesterday was a day where we spent a lot of time talking about the if you will, the reasons for GitOps, and then also some of the demonstrations of the outcomes that people have been achieving with GitOps-based approaches. And then today has been really far more hands-on, like how do you actually do things? And so to wrap up the conference, I want to kind of spend, given that today is day 2, it's a little bit more concrete. I'm definitely going to, I allowed myself a little bit of free rein to put on that propeller hat that you saw in one of my slides yesterday and go a bit techie. Now, I'm not going to be doing like Scott or Stefan did and actually show you, real YAML and those types of things. I will be a little bit higher level than that, but bear with me. I think there's going to be a few places where we're going to be a bit techie as well. So it's a little bit on that balance between tech and business side. So without further ado, let me go ahead and share my slides, share my screen. And so if I share this desktop, and I am assuming, and I can see in the GitOps Days Slack, do let me know if you're not seeing right now. You should be seeing the GitOps Days schedule. And okay, excellent. So when I share, I am confident that you will see my slides. And so, excellent. Thank you, Stacy. So the title of this session is, what's your first or next step towards powerful GitOps? And is it in all good techie talks? The answer to the question is, it depends. If you will, that's kind of the foobar of these types of dialogues. By the way, I'll share anecdotally, the other day I said something about foo and my husband said, "What does that mean again?" And I said, "Nothing. It's just something that us computer sciencey nerds." My son is 1 year in on his software engineering career. And when he and I are talking and he says something about foo, I think my husband just rolls his eyes. So in any case, it depends. So how do you get started? It depends. Well, it depends on a lot of things, but I decided to break things up into 3 different categories. The first is, and these are all very valid entry points, but the entry points that I wanted to talk about here were, if you are an application team, how do you get started, or what are the next steps? If you are a platform team, how do you get started, and what are the next steps? And if you're somebody that's interested in extending this GitOps environment, what does that look like? And I hinted at this a little bit yesterday in my talk, and I'll hold off on giving away any more on that because we don't have too much longer to go. So I'm going to start first with the applications. So my first bit of advice to you is, if you are starting with applications, start with Kubernetes. Now, let me be clear here that GitOps is something that doesn't only apply to Kubernetes, but the reason that I'm suggesting that if you are in a state where you're getting started with GitOps, that perhaps the best place to get started with that is Kubernetes, is because of the bookends. I talked about the bookends yesterday, and you've seen a version of this slide before, which really talks about these 4 principles of GitOps. And I talk about the bookends, and I want to emphasize again that the reason I'm suggesting you start with Kubernetes in the application space is because you get these things for free from Kubernetes. If you are aiming to do something outside of the Kubernetes space, then you have to come up with a way of dealing with declarative configuration, and you need a way of implementing software agents and having those software agents running. Remember that reconciliation pattern. We talked about GitOps patterns yesterday, and that reconciliation pattern is so central to cloud native operations. And that's really what GitOps is about, is these modern cloud native operations. So if you start with Kubernetes, you get the bookends for free. We know that we are declaring our application configuration, our manifests, in YAML. So we have declarative configuration, and we know we have the delivery controllers that are going to keep that declarative configuration in line with the actual state of the system. Okay, so you get that for free. Now, of course, that means that when you're taking and you're applying the GitOps solution, you need to add the things that are in the middle of this screen. And that's what we're going to do. I'm going to talk a little bit about how you get started or make progress on implementing those other two elements that are going to build out this slide. Now, this is going to harken back on some of the things that you heard Stefan talk about, you heard Scott talk about, you heard Lee talk about, all of those things that you've been hearing all throughout today, kind of in a concrete sense. Think of this as kind of a reminder, or maybe a way of stitching all those things together. So I was just watching Stefan myself, and he was showing you in his demo how he instantiated, he cloned a Git repository, and then he had in there already a folder structure around things. Well, that's the first place that we're going to start, is we're going to start on, okay, get the Kubernetes thing for free. Let's add the versioned immutable store and configure it properly. So what that means is that I want to really look at, okay, I've got the runtime environment. I know I'm going to have the declarative configuration stored in Git. What does that look like? Well, my first recommendation to you is that you really need to think about your SDLC. You need to think about that software delivery lifecycle, because that is going to place requirements, or it's going to help you design all of this stuff. So when I say all of this stuff, let me be a little bit more concrete than that. Your SDLC, and by the way, when I talk about that, I mean the entire life cycle, from the beginning stages where you're cutting code in an IDE and checking it into the GitHub repository. And then, as you have seen throughout the couple of days, there's a CI system that is generating the container images for you, and those types of things, all the way out into your production environment. But to get to production, you also have some other environments. You have a development environment in which you can start to test the basic configuration and making sure that, for example, your applications are truly stateless, so that you have multiple instances. You're testing things like having an instance go away and the application is still up and running. Those are all part of your kind of, if you will, unit tests. And I say unit tests, actually, I'm putting kind of quotes up in the air, that those are kind of your unit tests. You have to include that as a part of your developer testing. And then you also have maybe a user acceptance testing environment, and then you have prod. So when I talk about the SDLC, I'm talking about that entire gambit. How do we support the early parts of the software development lifecycle, as well as all the way out to production? So when we're considering those, the first thing I want you to do is think about your runtime topology. Now, you might already be here, and what I'm talking about here is, am I using namespaces? Am I using separate clusters? How am I configuring RBAC? And you might already have all of this wired up. When I'm out talking to customers, they're usually fairly far along, not always, but they've started to think about these things. They understand, for example, the limitations of namespaces, that it really represents more of a soft multi-tenancy than a hard multi-tenancy. They're starting to do that analysis on the failure domains and understanding what happens. You know, clusters still need to be upgraded and might need some downtime, or clusters still can crash and those types of things. And so they're understanding those failure domains. And those are some of the things that you need to analyze. But you also, not just looking at it from a production setting, you need to analyze those requirements in the context of your entire SDLC. So again, you might be thinking, all right, well, in that soft multi-tenancy that I was talking about, well, that's okay. We can have a single development cluster, or maybe two development clusters if you want some type of a DR scenario. And I'm going to have multiple namespaces in that. Each app team is going to get its own namespace. So I don't need to maintain separate clusters at that level. But then when it comes to prod, I definitely want separate clusters for each of my microservices, because I want to set up those failure domains. So those are the types of things that you're thinking about. Now, there's the equivalent side, and notice that I call that the runtime topology. On the other side is, I'm going to call this the Git repo topology. So what are some of the topological elements that you're using on the Git side? Well, there's folders, branches, tags. Are you going to use separate repositories? And again, there's RBAC. So what you are thinking about here as well is your team structures and what are the requirements around those team structures? Where do you need to set up separation of duties? What different teams that you have? And so you can see here that there's RBAC on the right-hand side, there's RBAC on the left-hand side. So really you're thinking about both of those things. And again, you're thinking about your entire SDLC. I've got dev, I've got user acceptance testing, I've got production. You need to be thinking about that. And then there is this. I've also got, it's not just the Git repo, I've got external stores. So I've got my image repository. We've been talking about that today. Yesterday, Luke Marsden in his talk around ML ops pointed out that a very common practice in the machine learning space is to have containers, images, container images, encapsulate the, kind of the runtime environment, but then have the models for those runtime environments for the machine learning applications, have those models be loaded in from an S3 repository. So you heard me, this is the category, if you remember, this is about setting up your versioned immutable store. GitHub, we know, is a versioned immutable store. But when I start thinking about things like the image repository or an S3 bucket, wait a minute, is that a versioned immutable store? So I'm not going to spend a long time talking about it, but I do want to highlight just a few things. Again, if you didn't hear me highlight this yesterday, in the earlier GitOps days this year, in May, I did a longer talk. I did what was called an overview and deep dive, a little bit of attention there. So, a little high level, but also a little bit of a deep dive. I definitely did more of a deep dive on this topic of Git semantics. And I mentioned it yesterday. And I talked about the fact that there are certain things that are absolutely essential to GitOps that include things like versioning, having a version history that is ordered in time, that it be immutable, and that facilitates things like repeatability. It provides safety nets so that you can do rollbacks, or actually more like a roll forward by simply accessing an earlier point in time, and you have the entire representation of things that were running at that time. So those are very important Git semantics. And on the left-hand side of the screen here, you see a Git log that I just, grabbed from the terminal. And you can see some of those elements that I just talked about, those Git semantics. You can see that I have versioning embedded in. Oops, sorry, that's not clickable. I have versioning baked in. So these commit SHAs, that is a versioning mechanism. It is a way of identifying a version where somebody can't accidentally go and replace that version with something else, and then you end up with a system that you can't recover. Because it's a SHA, if you so much as insert a space somewhere, even an inconsequential change, you're going to get a different SHA. So that's what I mean by versioning deeply baked into this implementation of Git. You've got time ordering here, so you can see the time ordering that is set up here. And you can see that at every single one of these nodes, I have an entire representation of the state of the system. So going back to the question that I was posing, which is, well, if part of my runtime state is stored outside of Git in an image repository in an S3 bucket, am I compromising that requirement about versioned immutable store? And the answer is that you may have to you have to think about implementing some of that into your entire system. So you, for example, when you're coming up with how you're going to put things into your image repository, and that's something that you're generally doing with your CI system, As a part of your CI system, you have to build into that CI system a mechanism that implements versioning in such a way that you can avoid that situation where somebody inadvertently or intentionally replaces a version without replacing the version number. So that's something you need to tool. And for goodness sake, you've heard it from multiple people already. Don't ever use latest as your tag in your image repository. Now, that really is getting to the second bullet here, which is, okay, what you're effectively doing there is you are effectively figuring out what your keys, your database keys are for this store. Now, the third one here is really interesting, which is time ordering. So does that mean that I need to have an image repository that's time ordered? Does it mean that my S3 buckets, but wait a minute, S3 buckets don't apply this versioning thing. And what about this time ordering? They don't really have a historical thing and all of that stuff. How do I do that? Well, there's an interesting element here. And again, forgive me for getting a little computer science here, but what we're talking about here is by reference. The whole thing we're talking about here is, are we doing things by reference or are we doing things by value? By value would mean that I'm storing my images in Git. It would mean that I'm storing my machine learning models in Git or the parameters in Git. And we aren't always going to do that. But if you do it by reference, you do have to ensure the versioning thing that I was just talking about. But now you can, in fact, use the time ordering. You can use Git as the time ordering thing and just have it have references to the things that are stored in S3 or on image repositories or in some other external repository. So it's the combination of Git and these external repositories where you can start to achieve these Git semantics. Then of course, and that's what I'm pointing out in the last bullet there. And then of course you have to think about RBAC. Okay. So all of these are the things that you need to be thinking through as you embark on your Git journey. These are all the things that are involved in establishing the way that you're going to store these declarative configurations and references to the entities that are outside that declarative configuration. All right, so that's how you get started with the Git repository. And now what's left here? Well, we're going to link them up, right? We're going to link up the Git repository and the runtime environment. And for that, we are going to use those delivery controllers that I talked about yesterday and that many of my colleagues have been talking about throughout the day today. And it's perfect that I'm doing this talk right after Stefan's talk, where he described to you the latest, greatest with Flux. And he described to you how we decoupled Flux, the original Flux, into various components. Well, now, hopefully, this is going to kind of stitch these things together from how you get started to what are the mechanisms within the delivery controllers. And he talked about the source object. He talked about a source controller that will pick up on new instances of the source object and then do, and deliver and pull those things and establish the cadence by which the Git repositories are reviewed and checked with for latest, greatest. And he also talked about things like the customize controller. And so there's this notion of customizations, which say, all right, once the latest changes have been pulled into the Kubernetes cluster from the Git repository, then what do I need to do to compile that YAML in such a way that I can deliver it over into etcd, and then the runtime controllers will take over. And of course, you're going to stitch all of those things together in GitOps pipeline with GitOps pipelines. Okay, so to summarize what we've talked about here, get started with Kubernetes, design or understand your teams, because RBAC showed up everywhere, your runtime topology, clusters, namespaces, your GitHub structure or your Git repo structure, and how you're dealing with those external stores. Then design the GitOps pipelines that are going to stitch those things together and you are well on your way. Okay, and you can do that incrementally. All right, so let's move on to the next thing, which is let's talk about, well, what if I'm the platform team and I am delivering these capabilities, these application platforms to the teams that I just addressed here. I'm delivering that to them so that they can do the process that I just described and not have to worry about the infrastructure. I'm taking care of the infrastructure. And by infrastructure here, I'm actually including the cluster itself, the cluster that the application teams are just going to use, the Kubernetes environment. I said they start with Kubernetes. Well, you're now responsible for giving them that starting point. So let's go back then to this picture. What I'm talking about here is really GitOpsing those environments. Now, I'm going to start from the ground up, but I'll make a few comments on this in just a little bit. Starting from the ground up, I'm going to say, I've got lower level infrastructure. I've got some machines. They could be virtual, they could be physical machines. I've got some machines, but I want to turn those machines into a Kubernetes cluster. Now I'm starting with the bookends again here, because if you remember when I was on the application side, I said start with Kubernetes because it already gives you 2 of the 4 things for free. It gives you the bookends, it gives you declarative configuration, and it gave you these software agents. Now in the application setting, the software agents I was talking about were, of course, it's things you're familiar with. It's the deployment controller. It is the replica set controller. It's the daemon set controller. It's all of those things that were baked into Kubernetes. But hang on, does Kubernetes, do I get something for free here if I'm going to try to actually establish clusters? Well, the answer is, well, it's not in Kubernetes mainline, but there is a community project in the CNCF that does give you the bookends. And yes, that's the Cluster API project. Cluster API gives you the left bookend. It creates custom resource definitions that allow you to describe your clusters, that allow you to describe the machines and the cluster topology that are going to be running on those machines. Now, the reason the machine is there is that's the interface down into the lower level infrastructure. Remember I said, hey, I've got some machines and I want to turn those into a cluster. That's the way that you do that, is with that machines.yaml. It's all declarative. So Cluster API brings you the left bookend with these CRDs. It also brings you the reconcilers. It also brings you an implementation for some of the controllers. And there's a whole host of controllers, and we could spend an entire morning, afternoon, or indeed even an entire day going through the details of those controllers. It's quite sophisticated and quite complex. But the answer is that there's a lot of really good work that's going on in this space that is, in effect, packaging this for you. Just like you didn't have to build a deployment controller, you don't have to build all of these cluster management controllers. They're being built by the community. But there are these controllers, and I called out only a couple of them, the machine controller and the cluster controller. Those are the software agents. And there are implementations that are either part of the Cluster API project or implementations that are infrastructure specific. There are implementations that are specific to VMware. There are implementations that are specific to AWS, etc. So there's a number of different infrastructures that are supported, and I'll talk in just a moment about a particular infrastructure provider that we are very deeply involved in. Okay, so you get these 2 things for free, well, for free by embracing Cluster API stuff. So that means that if I've got the bookends for free, do I need to do anything special for the things on the inside? Well, the good news is no. The very process that I sent you through in the earlier part of the conversation, where I built out, hey, you've got to create this, go through this process of structuring your Git repositories, and then you've figured out how you've structured your runtime environments. and then you use, something like Flux to connect those things together, that same exact process works here. It's all about structuring your Git repositories. It's all about creating your GitOps pipelines using the components that you have available, like source controllers, customize, Helm controller, and so on. Okay, so Cluster API and GitOps are really, truly a perfect fit. Now, I'm going to talk about topology again. I warned you at the beginning of this conversation that I was going to be a little techie. So when I start using the word topology throughout and RBAC throughout, of course, we're getting a little bit technical. So let's think about that topology, because there's something that's really interesting about the topological elements here as well, especially for those of you who might be newer to the Cluster API project. So if we go back to this picture, I said, okay, we've got declarative configuration in this machine.yaml and this cluster.yaml, and we've got these controllers that have been installed into the runtime. I'm emphasizing that, and I'm pausing here for dramatic effect because I'm going to come back to this point in just a moment. So those are the key elements. So let's kind of lump those things over here. Now, if I have declarative configuration and I've got some agents that are running, well, I need a place, first of all, to store that declarative configuration. Hey, how about this? How about I store that declarative configuration in etcd? Okay, well, that makes sense. Declarative configuration has been proven. It works well in etcd. And I need these controllers. I need these reconciliation loops. And of course, I have a great runtime for running reconciliation loops, and that's Kubernetes, right? So those things right here are naturally fit into a Kubernetes setting. I'm going to say, I'm going to make that first assertion to say, okay, well, this machinery, this engine is going to be a Kubernetes cluster. The thing that's going to allow me to do cluster management is a Kubernetes cluster itself. And I'm going to call that the management cluster. Now that's foreshadowing the diagram that I'm going to build out here. If I then have that management cluster, then how can I use that management cluster to establish additional clusters? Well, it's actually quite simple. What I'm going to do is I'm going to, in a GitHub repository, add a machine.yaml and a cluster.yaml. That is my declaration that I need a new cluster. Those reconcilers are going to recognize that. Oh, actually, sorry. The reconcilers don't see that yet because it's in a GitHub repository, right? Something has to deliver those things from the GitHub repository into the runtime environment. And that, of course, are your GitOps pipelines, powered by Flux, for example, at the background. So source controller, customize controller, let's say. Once that delivery happens, then those reconcilers will say, aha, I see you want a new cluster. Let me look out in the real world. I don't see that cluster there. And so I'm going to go ahead and create that cluster for you. Okay. You want another cluster? You create another machine.yaml and another cluster.yaml, and you create another cluster and another. Okay. So this is one topology that you can have where you have a management cluster, and now the reconcilers running in the management cluster are the ones that are responsible for taking care of each of the target clusters on the right-hand side. Now, that's only one topology, and it's a relatively simple and easy to understand topology, right? I hope at least laid out the way it is here. The mechanics of doing all of this, well, the good news is that we're writing automation for this, and you just heard me describe that automation. To a large extent, that automation is what we're doing with these GitOps pipelines, et cetera. But there's another topology that I want to suggest to you. So I'm going to make a little bit of room here and say, well, wait a minute, hang on. The target cluster is itself a Kubernetes cluster. So What you might be thinking is that the left-hand side of this picture and the right-hand side of this picture bear some similarities. Can I just do this? Can I have those very things that are in the management cluster running in the Kubernetes cluster that it's responsible for? And so what you're starting to see here is hints of what we've been talking about. Remember, one of the GitOps patterns that I talked about yesterday was a pull model? And that previous topology sure looked pretty pushish. And so indeed, that's what we're hinting at here. So yeah, so the first answer is yes, what I'm showing you here on the screen, absolutely doable, absolutely running. This isn't hypothetical. This does work. And in fact, it works this way in our Weaveworks product, WKP product that you heard Brees talk about yesterday. This is we do have this running on the right-hand side. So it's even running in production. Pretty cool. So how do I establish that though? Because now I have this bootstrap problem of, well, wait a minute, if I need etcd and I need reconcilers to set up a cluster, and I want those things to run in that cluster, how do I get that whole thing started? Well, there's a couple of options. You can use the management cluster to bootstrap this self-managed cluster. And the way that you do that is you've established the management cluster, you have done as I described, you've created your machine in cluster.yaml, it has spun up the target cluster, and then you can in effect run this command, which is cluster_cutl move. And it does the effect of moving the machine and cluster YAMLs over into the new cluster, as well as moving the reconcilers over. There's another option as well, though, is what I like to call the self-bootstrapping mechanism. And the self-bootstrapping mechanism says, hey, rather than starting with the management cluster, are there other ways that I can bootstrap this? And that, in fact, is exactly what this open source project does, WKS_cutl. It does this self-bootstrapping. And to get a little bit techie, the way that it does that self-bootstrapping is it leverages some execution in the client, in the WKS_cutl client, to do the bootstrapping. It just barely bootstraps it with a first node and sets up that first control plane node. Then it lets the control plane node, it installs everything, including the machine.yaml and the reconcilers, and then it takes over from there. So the bootstrapping mechanism is really quite thin, and then it takes off from there. Okay. So this is another topology. So you can continue to have a management cluster, but especially when we start talking about doing this at large scale, and we start talking about doing this in things like edge scenarios, then you start to appreciate, even instinctively, intuitively, you start to feel like, yes, okay, this kind of the self-management topology is really advantageous in many cases. All right, so to sum up this section on platform, what I've just been talking about is this, is that we have been talking about, all right, how do we do this cluster management? And I'm suggesting that you're going to use GitOps in the same basic patterns that you did at the application layer to do cluster management. Well, I'm not going to spend a lot of time on it, but here's the thing. We believe that the infrastructure that your application teams need is not just a cluster, because that burdens them with too much other stuff above that. There's this whole configuration layer, configuration of the Kubernetes cluster that is also needed. And I called out RBAC here because you saw earlier that there's all sorts of RBAC in setting up policies. So it's not just a matter of installing things like Prometheus and Grafana so that your application teams and your platform teams can use it. It's also configuring the cluster with things like network policies and role-based, cluster roles and cluster role bindings and role bindings and those types of things and roles. So all of that also GitOpsable. And I don't know whether Brice mentioned it. I didn't have a chance to take a look at it. But again, kind of calling out what we do have in our WKP product is that we have some capabilities there that do that for you in the setting of, teams. So it allows you to set up tenancy and those types of things. And then, of course, there's the application part that I spent at the very beginning. And that, of course, is going to be GitOps all the way. So what you can see here is that you're using that same GitOps pattern across your entire thing. Your platform teams are using it for the 2 lower layers. Your application teams are using it for the upper layer across. So to sum that up, not going over applications again, but only going over platforms, Cluster API is just brilliant. It allows me, it gives me the bookends. It gives me those things that I got for free in the application setting. It brings those along for platforms. I've got a couple of different topologies. I'm also applying all of this to cluster configuration. And how am I doing that? I'm doing that with GitOps pipelines. I'm designing those pipelines for how I'm going to use a cloud native operational patterns to manage my platforms. All right. So I think I'm doing just great on time. I've got about 10 minutes left, and I think that's just about the right amount of time to talk about this last bucket, which is ecosystem. By ecosystem, I am, yes, indeed, inviting you to join us to build out the GitOps capabilities, to continue to enhance those things so that more and more use cases do come for free for the application teams and the platform teams. So let me make that a little bit more concrete and talk about where are the places that you're excited about this, you want to contribute to this, you work for an ISV and you think, oh my gosh, I want my ISV stuff to be GitOpsable. I want it to be operable in this new modern cloud native way. How do I get started? Where can I offer the things that we have available? That's what I want to spend the last few minutes talking about. Now, yesterday, I showed you this picture. I talked about GitOps, and then I went so far as to say, okay, this is kind of the way that we think about GitOps. And then I said, but what I'd like to do actually is call this the GitOps runtime. The GitOps runtime has a set of delivery controllers, and that's where the source controller, Helm controller, customized controller, image automation controller that we talked about, something else maybe called a profiles controller. I'll get back to that in just a second. There's a whole bunch of delivery controllers there. Then I have a whole bunch of runtime controllers, some of which are baked into Kubernetes to start, things like the daemon set controller, the replica set controller. Then I also, you saw when it came time to thinking about managing clusters, I introduced, there's some additional controllers that you can bring to the table, which are the CAPI controllers. And that's the one that's second from the bottom there, Kubernetes Lifecycle Management Controller. And it doesn't say CAPI, it says CAPI. I'll say more about that. In fact, I'll say more about that right now. Remember that WKS Cuddle thing, the self-bootstrapping, self-managing cluster? Under the covers, that uses this cluster API for existing infrastructure controller. So it allows us there to do that self-bootstrapping, excuse me. And the way that that particular controller works is it assumes that the creation of those virtual machines or physical machines is out of band. And all you need to do is provide it SSH keys and IP addresses, and we can turn those machines into a cluster. So that's the particular CAPI provider that we are maintaining here. It is maintained in the open source, but we're maintaining here. We're the primary committers on it at Weaveworks. So that's the GitOps runtime, delivery controllers, runtime controllers, and then GitOps pipelines are used to stitch those things together. And that right there is, remember we had the picture where we had Git and we had the runtime environment and I had Flux sitting in the middle? Well, it's not just Flux, it's more this GitOps runtime is the thing that bridges the gap between these two things. So what I want to do now is suggest how you can participate. So I've moved the pipelines out. They'll come back in just a moment. And I've made a little space at the top. Well, the first place that I invite all of you, if you've got something that's applicable, is help us add to the set of controllers that are part of the GitOps runtime. Bring more delivery controllers. So yesterday somebody asked about external repositories and kind of was really poking at this. Well, I've got external repositories. What are those controllers? What do those controllers look like? Well, we have an alpha, and it's available in the Flux repo today. We have an alpha, the ones that are watching the image repositories. So while Stefan answered the question of, not ready for production, that'll happen, in the early part of the year, they are available out there in alpha. But are you part of an organization that has other repositories, that has some kind of storage, whether it be, an S3 compliant storage or something like that, and you want to bring a delivery controller to bear? We do have that, by the way. We do have the S3 that's part of the source controllers. We do support S3, but if you had something else, you can bring in more source controllers, or you can bring in more, kind of, if you will, YAML compilation controllers. So I invite you to bring us more controllers here on this side. The other thing is that you can certainly bring more runtime controllers. So Cappy is a great example of additional runtime controllers. I'll also call your attention to Flagger. Flagger is a runtime controller that is brought into this entire GitOps, vision, if you will. And it's a runtime controller that is very applicable in the GitOps space. So that's the first place that you can come and participate. Now, the next thing is, I'm going to move that off to the side and make a little bit more space on my slide, is that you can, of course, use Flux to then, once you can extend the set of controllers, and then using that extended set of controllers and the existing controllers, you can actually create pipelines, and those pipelines now are a part of how you can extend kind of turnkey capabilities. So there are, for example, it may be a little bit nuanced, but when Stefan runs the Flux bootstrap command, what he is doing is he's not only installing a set of controllers, he's also installing a GitOps pipeline that is responsible for the management and automatic upgrade of those very controllers that he's installed. So he is also installing and maintaining a set of pipelines. So if you want to do this either internally for your organization, or you want to do it more broadly for the industry, you can tool up these pipelines that can then be used by a host of people to generate value very quickly, so that they don't have to build the pipelines themselves. So there's another place that you can contribute into this ecosystem. And then finally, okay, if I'm building controllers and I'm building these pipelines, what's my delivery mechanism into that? And that's where we have been talking about this concept of profiles. And profiles, what they do is they are a GitOps native or a GitOpsable packaging mechanism that allow you to install things into your runtime that then offer the next set of capabilities to your users. I like to refer to this picture here as the GitOps platform. The GitOps platform supports this construction of GitOps-based workflows and automation. It supports the extension of this GitOps environment for you, the configuration of the GitOps runtime. It provides a programming model for you to be able to tool these things up. And in that programming model, to sum up again, to remind you that there's a number of different kind of programming abstractions that you can use to program that. There's GitOps profiles, which is the bundling mechanism. And actually, let me start at the bottom. There's the controllers, delivery and runtime, stitching things together in the pipelines. And then at the top, the profiles is a way that you can bundle these things together so that the bundles themselves can be GitOps controlled, GitOps managed. So that rounds out our entire picture here. To sum it up on the ecosystem side, I introduced this notion of the GitOps platform, which is really offers this programming model, if you will, an SDK. And here are the things that we're inviting you to contribute. So to put the final bow on it in the last minute that I have available, what I'm really talking about here is developing a community around which, and whether you're on the ecosystem side or the application team side or the platform team side, please do continue to leverage the community for education, for ideas. Please bring that innovation to the space. That's really one of the fundamental things that we are aiming for with these GitOps days, is for that type of sharing. And of course, as the CTO of Weaveworks, I would be remiss if I didn't say it. Of course, Weaveworks can help you with this, when either with education or with product. And I promise I'm not going to make this whole thing an advertisement. I hope that the entire presentation, my intent was really to help you kind of create a mental model for how to think about these things. But again, we certainly can help you in a number of different ways, including through our community involvement. And with that, I will thank you for your attention, both for the last hour as well as the last 2 days. And I think that I'm pretty much wrapped up right on time. I shall stop sharing my screen.
Thanks so much, Cornelia.
Okay.
Ooh. I love it. Where can I go myself?
So I'm going to, Damani and Bianca, I'm going to excuse myself. I do need to run off to a meeting. But again, just one last thing. Thank you everyone for being here. And Damani and Bianca are going to give you a wonderful close to the whole 2-day experience. And I thank you both for your stewardship of the community for the last 2 days.
Thanks, Cornelia.
Thank you.
Thanks everyone for tuning in and staying with us over the past 2 days. If you cannot see, I have my party hat on, and we've been backstage jamming out with all of our speakers. So if you want to hang out for a little bit longer, we'll have some music. We'll have all of our with the majority of the speakers over the past 2 days that are joining us, and just here for some good time to kind of end off the conference. Bianca, how are you?
Doing great. I'm really happy with the in-depth look, especially Stefan's talk about just getting really hands dirty with how to really use GitOps today. And curious to know if anybody has any final questions for the speakers. Maybe we'll get to those at the end.
Yeah. If you still have questions, feel free to drop them into the Slack chat. Really want to give a high level overview. If you're tuning in late, yesterday was more business level, high level overview and the business value of GitOps. We spoke about, how to get started with GitOps. We spoke about how to bring GitOps into the organization. We looked at some different use cases from Fidelity. We looked at use cases from Meadow at NatWest Bank. And we looked at a use case from Automotive Mastermind, and all of these were good examples of how GitOps is being utilized in the field and what we're seeing in the community as well as at Weaveworks. We kind of covered a number of key things in regards to it's not just the technology at hand, but the people in the process. And I think GitOps more so, hopefully over the past 2 days, you got an understanding of the process that we're trying to put out and how this methodology can essentially really help you along that path of cloud native operations. And I think that was the common theme that I saw throughout the past 2 days.
Absolutely. We also had to transition from yesterday to today. Bruce Fernandez from Weaveworks, he did a 90-minute workshop about how to get started with GitOps using our recommendations. So we're going to have the session recorded along with all of the other sessions. So if anyone wants to check it out later, I really recommend it. Another thing that I wanted to say is if all of this stuff interests you, or you're good at it, or you want to be good at it, we're hiring. So please don't hesitate to reach out to jobs@weave.works or check out our job listings on weave.works. We'll really appreciate it.
Certainly, and for all the Flux users, or understanding that we moved over to a new repo on GitHub, so we have we need stars on Flux too. So if you like Flux, jump over to Flux too and give us a star. We need to get our stars up on GitHub. And
Hi, Allison. How does everyone have hats? I want a hat. How do you do?
I see the folks joining in.
All right, we're gonna wrap it up, and everybody's gonna come back to the stage now for a final curtain call.
Yes. Yes.
I would honestly, I have to ask us to do a round of applause for Stacey, our producer.
Oh, I was thinking for all of you guys. No, thank you.
When we have been
I'm
saying
gonna click
things
the reaction.
from a voice in the background, that voice is her. So thank you very much, and also thank you to Tama Nakahara, who is our co-producer.
Organizer, jack of all trades, just everything.
That was fantastic. Thanks, everybody.
We
It's
take
really
a group
great.
photo?
Yeah, let's do it. Is
Group
this
photo.
everyone? Do we have everyone on screen? I can't really tell if I actually. I think the screen would just fill up a little bit more, right? Yeah.
Where did Alexis go?
Oh, was he? He didn't come to the stage.
By the way, are you noticing what's going on with Steve? Do the thing you did earlier where it looked like you were zooming in
Are you
from outer
getting-
space.
Oh.
Are you moving? Whoa. Nice.
Just vanished.
It needs a sound effect. Who's got a slide whistle?
Woo. Well, here we go.
There he goes.
All right. I'm gonna pipe us in some music, you guys.
Yes.
Okay, are we gonna
There
do
we
a
go.
little jam?
Oh, hold on.
I wish I could add Daniel in a little extra screen here.
Come on, David, you're not feeling it?
Come on, Stefan. You can do it. All you got to do is move. Just a tiny bit. Oh, there we go.
How should Alison got on our end?
Oh, we have our
my squish.
I thought it was
Nice.
a real.
It's
Wait,
not a
my
real
hat
hat.
like floats over my head.
If you click the virtual backgrounds button, there's another thing called video filter near it, and you should be able to get hats like this in Zoom.
I want to see Paul's facial hair. That you had blue facial hair earlier, or maybe it is blue now. I can't see it. Oh, there you go.
We have to make a get upstairs outtakes video.
Oh my gosh, Tama, you look like you're freezing.
Oh,
You got so
blue
cold.
lips. I have my get upstage blue underwater
Is it?
lips.
That's cool.
It looks good.
Trying to think what Damani looks like. He's from one of those cartoons.
Somebody try the. You can play with the.
This is what we all
glass-
really
the
look like.
masks with the other one.
Oh wow, look at that's cool.
Oh, now Steve's inside the tube.
Steve, I will make a gif of this. You might end up immortalized in gif form. And, I will not take full
Oh my gosh,
responsibility
Damani
for
framed himself.
Oh, Bianca, that is such a good look.
Oh wait, wait, that's
Actually,
a
it has a bit of color things. I can't see it.
that's a real one.
Nice.
That's
Yeah.
not a
Is this a song
virtual.
about Jira?
Okay, we need
Oh, God.
Lee to.
I didn't know
Lee,
they
you gotta
had
do your
that.
hair wrap.
You know, it looks like Allison has a zoom effect, but this is real life. She is holding
Yeah.
a real life.
That's real.
Does it have a name? Allison, does it have a name?
it is called camembert, like the cheese.
Camera bash.
Camera bash. Yeah.
I see Lee here, but can you get your camera on?
Lee's here?
Yeah, I got Lee and he just joined.
Oh my gosh.
Look, Paul's on TV.
Yeah, that's true. It doesn't show when you're none of your camera on. Hopefully Lee will have the camera on.
I feel cheated. I haven't got any of these.
Not under your videos?
No, I don't think. I think I had to update my Zoom or something, didn't I?
Oh, me too. That's why I only have this snap one. But
I hope the audience is enjoying this.
Okay, Lee, look at that.
Oh yeah, the Unabomber has now joined the conference.
Lee, I want you to do the hair wrap.
Oh, David's on too. Oh my gosh, what is that? A ferret?
You have a ferret? Are you a nihilist?
Oh my gosh, oh,
This is Zelda.
All right, if we're doing pets.
Oh, my pet's downstairs.
we're doing buddies. I got more buddies on my desk.
Lee, that's
Okay,
my favorite.
Look at Lee
That's
now.
my favorite.
Oh my
Look
god.
how amazing Lee looks.
Okay, Lee has
Yes,
the best
darling.
pics for sure.
Lee looks amazing.
So beautiful.
Dashing.
Yeah. Wear it really well.
Oh,
I'd like to announce our newest adopted WeWorks dog.
Oh, did I see
We
what
had a
you
foster
did?
fail this past weekend, and Wookie is now an official member of the WeWorks dogs family.
Oh, nice! Yay!
Gets along very well with Winston, and that was the clincher.
Oh, what is she?
I mean, it appears to be some sort of dog.
As in, any idea?
Terrier mix or something.
Oh,
And she's got we decided that she's a Wookiee.
Whoa, Lee. Oh my god.
she's gorgeous. Oh.
Lee, that's the best for the music.
Yeah, totally.
Hey,
Thanks
David,
again, everybody.
What is your pet?
Wait, Sebastian. Sebastian, your alien eye transferred to the dog for a second. Yeah.
Oh my god, cute.
So
good.
So David, when is your ferret going to make a guest appearance in Raw Code?
Whenever she bites my feet and I pick her up, mostly.
I need to watch more videos. I need to find more.
Oh yeah, Paul's gone all this. That's great.
Yeah, this is really good. I think now's like a really good time for like, I don't know, us to share our thoughts maybe, because I definitely do want to say a huge thank you to everyone who came and attended GitOps Days. Like, y'all are awesome, very awesome. Everyone who's been like liking the GitOps Days tweets, like, yeah.
Oh yes, thanks for live
tweeting, Allison.
Sorry, I'm distracted by Lee as an
Okay, now Lee has freaked me out completely.
Nice.
Oh my gosh.
That is like, yeah, that's one step.
You need the butterfly in your other hand, like, is this GitOps?
Oh my god.
And well done, Alison. Well done, Alison, for helping Scott with the slides. He was very grateful when he came backstage. He was like, Alison, help me with those.
Yeah, I made a new thank you slide as well. That's pretty baller.
I also would like to thank Scott for like helping me with my slides as well. 'Cause, like I remember it was actually pretty much like the night before. I was like, oh my god, I need help with just this one thing. Oh, Scott's online. I'm gonna message him.
It was a fun collaboration. I think it'd be, we need to do more of those.
I think.
Watch this space.
I think Steve, guys. I think Steve is running in Kubernetes now.
Yeah, I was wondering if he could spin. We could spin him.
That would be fun.
Oh man, Bianca, what happened?
I'm not even sure.
That's
There's
a sad
obviously a threshold here that I'm crossing.
That's terrifying.
It's really scary.
I just want to find a cartoon that looks like Lee. I think Lee's using snap filters too.
Yeah.
Yeah. What's it called, Lee?
I think it's like anime something. Yeah.
By the way, Craig messaged you, Lee, because I was telling him all about your Windows filters to make your Windows look like XP or Windows 7.
I've added it to my to-do list to reach out to him about the theme patching stuff.
Well, first when I was telling him, he was like rolling his eyes, and then by the end of the conversation, he's like, "Oh, I better reach out to him."
All right, everybody, I'm going to switch the live stream over. So say bye to the audience, and then we can hang out.
Bye. Thank you. Thanks, everybody.
Thank you very much,
speakers.
Thanks, everybody.
Thank you. Oh my God, Lee.